kompetents ja sujuv koostöö. See on Mark Wood.
Tõlkimise järgi. Tere hommikust!
Good morning. Good morning to everybody. Welcome to the 16th International Wood Architecture Conference. This conference has been taking place for a long time. It's an annual conference, and that's the way we're going to continue. When we started with the conference, it was a marginal group of people, perhaps even a little bit strange people who came together to discuss topics which didn't have that importance or impact in our society as today. And we feel that through this conference, the situation has changed. And in today's Estonia, we are very active wood users in architecture, and timber has found its way into big constructions already. And if we try to see a bit into the future, then we see that in very many presentations we hear about large buildings made from wood in the whole world. And probably it's only increasing. It means that wood as a construction material is one of the quickest developing materials of all. A little bit about the organizational side of today's conference. It is possible to listen to simultaneous interpretation. For that purpose, there are earphones available by the entrance.
One of the first announcements is that there is synchronous translation available, and for that at the entry are headphones. So if you don't have it yet, take it, use it, because today's main language will be Estonian on the stage, and the translation will help you. Järgmine asi on see, et
the next thing I'd like to remind everybody, please use the opportunity and ask questions. Today we have several presentations, and after each presentation we have specifically left some time for questions and answer sessions. But there is also an opportunity to ask your questions via web if you don't want to do it direct here. And on your tickets there is a code. You can register yourself into the web environment and use it for asking questions. And if possible, please try to ask your question before the end of the presentation, and I'm going to scan them and use the opportunity and ask some of them orally. Behind the seats, behind the tribune, you find the stands of representatives at this conference. Those who are still studying to become engineers, you are also going to get credit points for today's conference. For that purpose, there are registering forms at the registration desk. And if during the breaks you are leaving the conference hall, then you also see an exhibition displayed outside the conference hall. So we have a lunch break, and After lunch break, we continue with the afterward session, and by the end of the conference, we have the awarding gala, which means that we will award the authors of the best wood architecture designs for this year. We have two moderators for today. One of them, myself, Andrus Kõresaar, and I'm one of the founders of Coco Architects, and I have been working there a little bit longer than the history of the Wood Architecture Conference. And in my everyday work, I very often encounter the situation that in the very early phase of designing, you have to pass the decisions, not just what the building will look like, but also what materials to be used. And that's why I'm very interested in this topic. And this is also the reason why I'm one of the moderators today. Our second moderator today is Veronika Valk. She's a very well-known architect and also speaker for the development of architecture as such. When we think about wood architecture and its importance, its impact, there is no doubt that there is the aesthetic side, but on the other hand, in today's world, we all speak about the sustainable materials and not so sustainable materials, bearing in mind the carbon footprint. And Estonia has been known as a concrete country, not steel country like England, for example. But then on the other hand, concrete is a building material which has the biggest carbon footprint. And then wood. We have a lot of it here in our homeland in Estonia. It is growing here. Why not to use it? And if we develop this sector in Estonia, then no doubt in each case we are always on the positive side. And that's why we need to increase the awareness of wood as a construction material, because you always have to weigh between sustainability and the price. But then Estonia being a very small country, sometimes you may get the feeling that whatever we do here is just a drop of water in the wild world. But then thinking about bigger world, we know what's happening where terrorists are doing whatever they want to and literally take the world back into Stone Age, destroying everything. That means that each country is important, and I would call the head of Rightwood Architecture Company, Ivo Dembrovski, to take the floor and to speak about the mission that Estonia has. So can you tell me something about the carbon footprint statistics in the world and our share in it? Good morning to everybody. I'm very happy to be here, because I was also one who was at the birth of this conference session. And now, as an answer to your question, during the recent years, I have been connected with these studies and this research, and it has been possible for me to make the picture clearer to myself. And some figures. The greenhouse gases created in the whole world is something like 60 gigatons, which is 6 billion tons. The Estonian share of it is 14 million tons. And if we speak about the emissions we're speaking here in Estonia, it is something that each one of us has given a share. So with their everyday purchases and we are not considering the emission gases which have been created when the materials have been produced somewhere else, not in Estonia. We have a consultation bureau, AFRI, which is trying to figure out what is the impact of Estonian wood and timber sector. If Estonia has 14 million tons of emissions, then in the wood sector it is actually negative 9 million, which means that our forests are binding carbon, and the binding is increasing in time. And thirdly, the effect, the impact created when we use wood for construction. We don't use fossil fuels. It is a double effect. And please think about that. What we are doing here today, it is possible for us to build or to create another wood in our towns if we use timber as a material. And all these buildings we are going to speak today, they are in an allegorical way perhaps even like timber warehouses. And by now quite a lot of work has been done, and we know that per 1 cubic meter of timber the emission is about 10 kilos of CO2, and the footprint of our product is about 160 kilos, which means that our share is 10 kilos and the rest comes from the rest of the chain. And why it's such a big figure? Because the big part of it comes from transportation of materials. But if we will focus more on local materials, we can decrease the transportation share a lot. And this is what we can do here in Estonia. In this 1 cubic meter of a product, only 10 is our part and the whole is 160, which means that it is 750 kilos of binded CO2. Thank you. Thank you very much. These figures were speaking for themselves. I think that now we can start with our first presentation of the conference, and for that purpose I ask Villu. Villu, well, I think I must use the full title. Dr. Villu Kukk is an expert, nearly zero energy buildings research group, Department of Civil Engineering and Architecture in the University of Technology of Estonia. And part of it, what we are going to hear, that comes from his doctoral thesis. He has defended by now.
Good morning. It's my pleasure and honor to be the first presenter today, and this material and input has actually been very topical also in the theme of this conference over the last few years. So this is the CLT and its structure. So this presentation is a summary of my PhD that I defended this year, and the topic is the hygrothermal criteria for the design of cross-laminated timber external walls with ventilated facades. Why these hygrothermal criteria are important and where do we implement them? The reason is that most buildings in Estonia, they traditionally have been either timber frame or traditional log houses. But the biggest concerns of wooden buildings are always moisture, as we know. And for a timber frame building, these criteria that mainly apply, they have to do with the vapor barrier, ratio, so it's the ratio of vapor resistance between the internal vapor barrier and the external wind barrier, so that the moisture doesn't accumulate. And the air tightness is also important. And we always speak of insulation of log houses. And that is why it's very critical that we avoid moisture damage. And we have to consider the internal insulation thickness and also the air moisture content of the logs. So traditionally, the timber frame and log houses are limited to small apartment buildings or, so they are usually small-scale buildings. But CLT has actually created a way, an opportunity to build large-scale buildings and high-rise wooden buildings in Estonia and outside Estonia. So compared to timber frame buildings, the CLT envelope doesn't actually require an additional vapor barrier, as the panel alone controls the vapor diffusion.
And CLT, it also has significantly higher proportion of wood compared to timber frame buildings. So this means that during the construction of this large-scale building, the wetting of CLT panels is significantly more likely when weather protection is not applied. So this may cause various deformations and they can permeate through the cracks of the panels. So if there are very clear hygrothermal criteria that have been set for timber frame and historical log houses, then there are no clear critical moisture conditions for CLT buildings. So in case the building is wet. So there's a very clear gap in the research that would determine the hygrothermal criteria for the designing of CLT external walls. So as for CLT, then it is a standardized multi-layer wooden composite structure. So regular wood is not homogeneous, but when we glue these panels together, then we can make it more homogeneous. And CLT, its actual criteria have been studied before. There are several studies that have been made. So 20% is the evaluation that is based on the moisture content. So mold can be occurring when the relative humidity is from 70% at the temperature of above 0. And this means that mold can occur even with a lower moisture content. So mold can start growing in case the moisture content is low. And this was then the reason why the objective of our research was to set very strict criteria to secure that the air tightness and moisture safety of the building envelope are considering the design, the production technology, and also the built-in moisture of the CLT panel. And to meet our objective, we had to answer certain questions. So what is the impact of the production technologies on the crack formation and air permeability of the CLT panel? What are the climate conditions during the construction phase of the CLT external wall? What is the built-in moisture of CLT that affects the hygrothermal performance of CLT external walls? What is the impact of the wall assembly of the hygrothermal performance?
And what are then the criteria to avoid these issues? So the following methods were used to answer the research questions. So we measured the air leakages at 7 steps of the pressure difference between and including the minimum and maximum pressure differences. And the minimum maximum pressure differences were selected to be 50 and 500 pascals. And so we also had panels that were 3 and 5 layer thick. So the panels in which the air leakage was measured were 30 millimeters thick and 1.4 by 0.4 meters wide. And the panels were produced with 2 initial moisture content of laminations, 6% and 13%. They had edge bonding or didn't have edge bonding. So, for example, in the summertime, when the indoor humidity can be around 70%, and then in the winter it can drop to 15%. So this means that the moisture content of the wood can drop from 13 to 6%. So there's a drop of 7%, and that means that the volume shrinks by about 1%. So the cracks occur between the boards, and this is the first source for air leakage. So we also measured the air leaks in the external walls. So the external walls, they were sort of test walls for us. We had 3 types of walls, and they had different type of insulation. So we used mineral wool, cellulose, and PIR. And we also doubled our test walls. So these are the external walls. So we had walls that had low moisture content, 13%, and we also had panels where we increased the moisture to 26%. And so this is a situation that imitates a panel that has been exposed to the weather and the climate in the phase of construction. The air pressure remained the same, but here we then had a threshold of 0.9, and this is set for the zero energy, nearly zero energy buildings. So what about our results then? So the results of air leakages from CLT panels that were conditioned in decreasing relative humidity from 75 to 15% are presented as airflow rate at increasing pressure differences. So the results are divided between the panels that had initial MC of laminations of 13% and 6% during the production. And first, the results showed that all the panels that had 5 layers, regardless of the initial moisture content and edge bonding, they were impermeable to air at growing pressure difference. But in contrast, 3-layer panels had a significant growth of air leakages at increasing pressure differences. So one additional layer is not enough to make it, so to say, airproof, but 3 layers are enough. So from 5 layers and onwards, these are resistant to air leakages. And as for external walls, the results of air leakages, so this is at 50 pascals, and the results were divided then according to the orientation of the walls, either facing north or south. And the results here showed that where the CLT had a low moisture content of 13%, the air leakages were below the threshold, and the variations were between 0.1 and 0.6, meaning that the external walls were air leakage resistant.
kus paneelidel oli algne niiskussisaldus pinnal kuni 26% ja see kõik õhulekke arv seatud piirväärtus.
Given the fact that the measured external walls had 5-layer panels, we can rephrase the last conclusion by saying that the 5-layer CLT panels can be considered as an airtight layer in external wall assembly. So, as the panel had 5 layers, then we can also say that this 5-layer panel can be considered airtight as long as the moisture content is maintained in the construction phase. And if the moisture content increases, then we have to use an additional method like a membrane. Next, the hydrothermal performance. So here again we had our test walls measurements where the moisture content and the external insulation was different, but we also tried to look at the internal layers and their importance. So we used as an internal layer clay, plaster and pear. So we designed all of the walls so that they would suit our climate, that the facade is a ventilated facade. So the wind barrier was mineral wool. So our test walls were placed in our test facility, which faces both north and the south. And the internal layer was also studied in our climate chamber, where we tested both the internal and the external climate. And in addition to the measurements, we also made calculation models so that we would be able to predict how they react hydrothermically, depending on the internal and external climate. So obviously, we have to consider certain discrete random variables, and one of those was the thickness of the CLT. So 100 to 200 millimeters. And in case we would also have to use additional airtight membranes out on the outside panel. And these random variables always have an importance in what kind of material we use, whether it's the thermal conductivity, vapor resistance, and the initial moisture content of the CLT. So the variable was between 13 and 26%. And this covers then the initial production and the construction phase. So in order to analyze this data, we used a criterion called the mold growth risk. And we came up with a model which looks at the mold growth risk, and the scale of it is 0 to 6. And our evaluation criteria was 1, with the objective that the design of the panel is that there is no mold growth at all. But we have to have certain sensitivity classes considered. Different materials, they react differently. For example, mineral wool type of materials, according to the model, they have average sensitivity. Sawn timber, which is also used in CLT, are sensitive, and untreated wood is very sensitive, like sawn timber. And on the basis of our calculations, we also had to set the probability of the hydrothermal performance. So here are the results of the data. So the measurements from the test facility and the climate chamber first confirmed that the CLT panel in the wall assembly controls the vapor diffusion and no moisture accumulation occurred on the interior surface of the wind barrier. But when we used PIR, then an unexpected low RH occurred between the soaked CLT panel and the vapor-tight PIR external insulation. So these types of boards have to be installed so that they are airtight. The cellulose insulation, it prevented large fluctuations of relative humidity of the interior surface of the wind barrier, and this decreased the variation of the relative humidity. So when looking at internal insulation, then in case of a large high moisture content, then mold can occur. So this shows that when vapor-tight layers are designed to cover the CLT panel in the wall assembly and they are installed airtightly, the built-in moisture may pose a risk for mold growth. So we had a panel, CLT panel, that was covered with an additional vapor barrier. But when this panel has a high moisture content, then we need to guarantee air tightness, and then we add an additional membrane. So when we use vapor permeable layer like PIR, so our studies confirmed that the wall type in which the CLT is covered with a vapor permeable layer, and therefore the dry out capacity is not impeded, they all had a very high probability of a safe hygrothermal performance. So we had a sort of a decision-making process that can be used by others when designing moisture-safe CLT in external walls with a ventilated facade. So the first question is the building going to be built and totally protected from the climate? If yes, then we have to consider whether the panel has at least 5 layers. So if we know that additional protection has been added, then probably if the panel has 5 layers, and then there is also vapor safety, then it's hygrothermically safe. But if it has only 3 layers, the panel, then we have to use additional protection measures. In case the structure is built without any additional protection, for example, the scale of the building is so large, or you just don't have enough financing. In this case, the probability that the panel gets wet is much higher, and airtightness measures have to be implemented. The process here is a little more complicated. We should consider what kind of external insulation is used. So in case you use mineral wool or cellulose insulation, then you have to consider that when covering the material, the external moisture content shouldn't be higher than 20%. In case you use materials that have various types of boards, then the panel has to be less than 16%, or it should have its initial moisture content that was at the production phase. So obviously all the conditions have to be fulfilled, and in case they are not, additional measures have to be used so that the moisture content is brought to the right level.
Kas paneel ise on ka seespoolt kaetud?
Is the panel itself also protected on the inside? And if not, if the vapor layer is low, for example, a clay plaster, then we don't need any extra conditions, but the internal side of the panel should have initially low moisture content when you use PIR, for example. And when we look at this decision-making process, we see that the conditions, there are not so many in case we follow the regulations and we protect the building from the climate. But of course, having such a tent installed, it may increase the construction costs quite considerably, in fact. But I would like to stress that from the design phase, you should consider to have such a hydrothermal plan. So these are the conclusions. So at least 5 layers are sufficient for ensuring the airtightness of the CLT panel as long as the initial low moisture content is maintained. Because high moisture content during the construction phase, it makes increases air leaks, basically. And the high initial moisture content of the CLT panel, it significantly weakens the air tightness. And the CLT external walls, they have a high probability of safe hydrothermal performance when built-in moisture is not presented. So in case the building cannot be protected, then we have to have another airtight layer. The moisture content shouldn't exceed 20% in the use of vapor open external insulation. And in case of when the building is covered with vapor-tight layers, then the moisture content shouldn't exceed 16%. And the wall assembly requires vapor open wind barriers. I've also listed all of the different publications where these conclusions can be found, the criteria. I presented them in a very simple format for you today. And the latest publications, they have a lot of details. So in case you would like to read them, please don't hesitate to contact me. I will send you copies or we can discuss this topic. Thank you very much for listening and thank you for your attention, and I'm happy to take your questions. Thank you very much for this exciting presentation. I will take the first question. So all those remarks you made were if in case and if things go well. But what if things go wrong? And the CLT panel has been exposed to moisture and it's totally wet through. And so the architect is there on site and the people who are building, they say that, what can we do? So can you replace these panels? Well, you just have to let the panel dry out. There are certain methods, but it also depends on how moist it has become. So in case the panel is totally wet through, then you have to have this tent installed. And you have to create these conditions, external conditions, in order to dry the panel. And the builders, obviously, the construction time, it monitors moisture. And you can look at it, at the panel, and see that it's wet. Over the last 10 years, when CLT buildings have been constructed, this moisture safety, it has actually developed quite well. So covering the panels and the construction phase, nowadays it's very carefully considered. But obviously there's always room for development. Does the audience have any questions? Seems that we do have one. Hello, my name is Tiit. Did I understand you correctly that the model that you used for the measurements for the air tightness and the moisture and the cracks, that it was 6 millimeter thick, the lamelle? That's correct. So this is the panel that we tested for air tightness. So if in real life it's 20 millimeters and you had 6 millimeter panels, why do you think they behave in the same manner? So if we set our hypothesis, how to consider and how to make them airtight, then it has to do with the internal layers and the number of the internal layers. Yes, obviously the thickness of the layer has an effect, but it doesn't have enough effect. So when the volume decreases and cracks appear, that happens on the outside, and that also has to do with the number of internal layers. So the reason why we had a thinner panel is that we conditioned them at different relative humidity conditions, and we had to reach a certain moisture level, and that was the reason why we chose a thinner panel. Thank you, Dr. Vellu-Kukk, for your presentation.
If you are going to have more questions afterwards, you can use the break for talking to Villu direct. Thank you.
And
our next speaker today is an architect, Ülo-Tarmo Stöör, and he is the winner of the Wooden Building of the Year 2021. And even before he takes the floor, I'd like to reveal a secret about him, namely the fact that he is dealing with wood architecture is his fate. And you know why? There is a song by a group called Redel. The song is about a timber town, and that timber town is the hometown of Ülo-Tarmo, Viljandi. Hello. A very good introduction by Andrus. Yes, that's why I use wood so much. I come from Viljandi. We have guests here from all over the world today. I wonder how the simultaneous interpreters are going to translate the heading of my presentation. Ö is the word for night in Estonia. Night, woodwork. Töö, with the initial T, is the word for töö. So that's the name of our architectural bureau. We work together with my brother there. And 2008, we won the architecture competition in Riia. And here I am lying down and I am watching my older brother doing the work. But before we start looking at our night work, quick trip to history. We both started to work in the Koko Architecture Bureau. Let's have a look at the things we did then. One of them is a villa in Merirahu area. And, well, if you look at it, you perhaps think that, well, the guy is joking there. wood architecture. Of course, it looks like this. But Merirahu, yes, this was a very interesting location because in that area, people have a very clear understanding what a house should look like. They want to have wooden villas, and in the detailed plans, there are very clear explanations whether it should be concrete or plastered, they should be white or black or something in between. And at that time, Emil Urbel was the chief leading architect, and he always signed these designs. I was a very young architect at that time, and I didn't like the idea that everything should look like very similar. And well, in a way, the result is good, because if we look at that district now, Merirahu district, all buildings looks very much the same, so it's very harmonious. But in this case, this particular order, it was allowed to consider other materials as well, and that's why we jumped at it. And most of the building is made from concrete, but we were allowed to pick other materials for the facade, and we used the special timber shingles, and we checked just in case whether that met the requirements, and they said yes, it does. And this is how using timber started to climb into our projects secretly. And here you also see the windows, which are part of the facade system. They have been attached to the glue lamp, and this continues also on the roof as a material. And there is a closer picture of it. But now let's get to our work in our Architecture Bureau. One of our first projects was a beach house in Laulasmaa, and that's when we won our first award for Wood Building 2013. We had the interior architect Katrin Öllöp, who recommended us to one of the acquaintances of her. And from the very beginning, we decided that we are going to build a 100% wooden house. And perhaps some things could have been solved a bit easier way, but we still stayed with 100% wooden structure. And the idea was that as this house is located close to the sea on the northern coast, and well, that's a typical problem there. On the one side, you have the sea and the wind, on the other hand, southern sun. So we had the living room in the middle, and then we wanted to have this clear view all through the building, and the owners could see both the sea and the sun. And well, it is in forested areas, so we fell the trees there and used the same wood for building. And there is a terrace all around the building. And we also restricted the areas where cars would not be allowed. And just a few more pictures. So on the second floor you have the sleeping rooms, and in the middle more like an open lounge. And we didn't want to have this traditional thing that you have a corridor and a room standing side by side. We use this bridge-like approach. And in order to make it a little bit more easier to grasp for the builder what this house is going to be, we made this little model and 3D, and well, we practically named every detail, where is the right location for it, and so on. Now some exterior views of the building. And as I said, Katrin Öllöka was our interior architect, and she also used a lot of wood inside, a lot of glulam. We thought that we tried to keep as many inside structures opened as possible so that they will be exposed to the view. And here you see the bridge in the house. And for the engineer, I kindly asked him to do all the calculations so that if the whole family with all the relatives and in-laws comes together and they want to take a picture on that bridge so that it would still be safe. And now I'm going to show you something very small. Usually people want to show big designs, but I am going to show you a small grill house, which was the nominee for 2018 Architecture Union. And this is the first meeting of the client. The plot itself is right on the beach, and there is a lot of wind there, and he wanted to have a barbecue place where it won't be so windy. And, well, we went there to have a look, beautiful sea view, small houses there on that plot. And he had chosen the place already and showed it. Well, that's where I'd like to have my grill house. And then he also brought some old window frames out and said, I'd like you to use these ones as well. And then yes, and then he also said, I'd like to have something that wouldn't be too ordinary. And then we decided to have a grill house where you have a little space for the table, to sit down at the table, and we used the old window frames for him to have the windshield so that he can still see the wind, but not to sit in the wind. And what's interesting, the house is different, looks different from every direction. And if you look at it only from one side, you can't understand what the building is like. But when you go around it, you get the idea. And we had a metal work artist, or actually a blacksmith, who made the final piece to it. And then we say that now it's finished. And let's have a look at the next project. That's a parish school visiting center in Palamuse. And for that work, we were noted for, in 2018, the best wood architecture competition. And it's a little visiting center. They needed a place for exhibitions and some offices for the employees, and also some workshop rooms, and it had a very historical context. The old parish school is still there, and the new thing we were supposed to add should somehow match it. And then we thought that, well, we don't want to have just a copy of it, but we'd like to have something more to it. So we, in a way, deformed the same building. And as the visiting center very often has theatrical performances, we made this deformation as a functional stage. And that means that the original building is as if cut into two parts, and now under the stage or behind the stage we even had this little cinema room. And now, very quick overview of all those different. And there is a cross-section of the stage, and under the stage, the cinema room.
Sisearhitektid olid Mari-Liis Süld ja
Internal architects, Mari-Liis Süld and Rein Loop. And you see a lot of timber and all those structures also visually opened. And Coco architects were the main designers. And we had a very interesting project in Saaremaa. It's a factory building. And actually, what the client wanted, they wanted to have a shed for storing hay. And one of the conditions was that it has to be approachable with a tractor from different sides. It seemed to be something very simple in the beginning. But then as an architect, you always start thinking, is it possible to make it a little bit more complicated? And then we thought that, okay, it's going to be a hay shed, which means that during most of the summer it's empty. And then we thought, wow, would it be possible to add another function so that it would be in cross-use, for example, having summer concerts there when it's and then we thought that we can use the trusses and as it is now going to be used also for concerts, it has to be more interesting than just ordinary trusses. And I was actually ready that the client would tell me, now think a little bit, it's not what we needed, it's not what we wanted. But then in our case, we had a very good constructor, and all the doors are functioning perfectly. And by the way, we designed the doors also with another purpose. So one, of course, was that it would be this wow effect. But then there was another reason that as these openings would be used daily and it is possible to regulate the, let's say, scope of their being opened. So it somehow creates this very interesting feeling inside. You can regulate the amount of sun coming in and the size of shade. And here you have the view of the trusses and the inside of the building. And this is what it looks like at night. All the doors are opened. And the most important building I want to talk about this is the building for which we got the award last year. That's the building I'd like to speak about, starting from the beginning of the process. And here you see all those existing buildings on the site already. So the pink ones, these are the ones which architects have designed. And I also want to point out that in the beginning, there was a villa designed by Emil Urbel, and that played an important role for the whole project, why it became what it finally became. So the red one is not designed by us, by Emil Urbel. But then there was also a very old storage log house on the plot, and a sauna. So actually one of my schoolmates called me and said that I need a sauna. And when we were designing that sauna, we thought that, well, there is a beautiful orchard, apple garden outside. Why not to open that view for the people using the sauna as well? So we designed a big window there. But then this is the sauna, and there are also possibilities for housing the guests there. And why I mentioned Emil Urban, because when we were designing this little building, the sauna building there, we understood that the main building on the whole plot is still the one which is used for living in. So we didn't want to compete with that. And we were thinking about the materials to be used. And when we understood that it has to be the first building designed by Emil Urbel, so we thought that we choosing a little bit less outcrying material for the roof, perhaps we are a little bit more humble beside that living house. And it is a traditional reed roof, and we added this top to it, which takes the first blow of weather on it. But let's go quickly through the pictures. You see a corner of the sauna. You see the detail of the top of the roof. Here is a little bit of the interior design office pink. The authors, this is the sauna, and this Okay, the next building, my schoolmate called me again and said, now I need a shed for keeping my firewood. And then I thought again, not a traditional quadrangular shed or something. We tried to approach it again a little bit differently. And then instead of that shed, there was an old building which was taken apart, but we used all these details for so-called playhouse. And here the most interesting thing is perhaps the floor, and it's wooden. And we made our research, and we actually saw that paving has been used in America even for streets, and it is quite endurable. So we decided for that. And then the owner also needed a little grill place, which we did for him. And then time came to that living house. And in this case, we understood that it's as important a building as the first house, which was designed by Urbel, and we used shingles for the roof. You see there is the living room and the bedrooms, and in the beginning we meant to have the kitchen on the upper floor, but the owner said that I have a very big family, and in our household the kitchen table is the center of our home, and that's why the kitchen and the dining room is actually the central focal point of the building. Yes, and now my advice to everybody, if you want to win an award, build a bridge in your house, because we also have the same bridge I showed you in the first design in this house. And we have several entrances, one meant for the summer period, the other for the winter period, and we also thought about the need for a bigger storage space for winter shoes, for example, and in summer you don't need that, so you can enter. Well, here you see the Urbel house interior. You can see the bridge again from below, and this is the view from the entrance side, and again lots and lots of wood and exposed everywhere as much as possible. And this is the overview of the whole plot with all those different buildings there. And the last project, it's a small house in Otepää. And this was the nominee. This is our nominee for the small house competition. And it's an old drying shed, and the owner wanted to have a little weekend cottage, and we found out that A-frame that was first used in Estonia That was done by the father of this plot. So we use that. Perhaps it's a nice reference. We use the same approach. And here you see the view from above. You have a little bedroom and a corner for sitting. And that's, by the way, in South Estonia, which means that it's very hilly landscape, like cupolas over there. And here you see the construction taking place, and again, I have to praise the builders. They were very good and they were very precise. All the corners are very exact. Thank you. Thank you. I managed with the time given to me. Thank you. Do we have questions among the audience? I do have a question myself. I like the villa, which had the round foot plan, and also the roofs. And actually all these designs you showed us, they are all very well fitting into the context. But the roundhouse, the roof looked like a saddle, and I liked it. It's an interesting, beautiful nuance. And this freely flowing surfaces, is it something you do often? Because we don't see very many saddle roofs here. Well, when we completed this one, we were thinking with my brother that the next house should be something simpler. Well, as that house was again open to all sides, we needed actually more stiffness to it. And one of the possibilities to guarantee stiffness was that the roof had to be made with materials providing that stiffness. So they covered the saddle roof with OSBs. And, well, it's always when you do something a little bit more complicated, then in the course of doing it, you think, why am I doing it? But once it's ready, you are very happy that you decided to do it the way you did. And when I showed you the 3D structural model, it's not an ordinary working drawings. It was a very complicated house, and there were so many different details, and that's why we wanted to help the builders as much as possible and wanted to make work easier for them. Thank you for leading the innovation in architecture. And I understand that your architecture bureau is very often coming forth with some solutions which have never been used in Estonia before.
Järgmist esinejat kutsun sisse juhatama minu kaasmoderaatori.
I would like to introduce Veronika Valksiska, my co-moderator, to introduce our next presenter. Good morning. I'm very pleased to welcome you, and I'm actually welcome you on behalf of the Ministry of Economic Affairs and Communications. I am in charge of the Department of Housing. Previously, I worked at the Ministry of Culture in the field of architect. I am an architect, in fact, and I work as an architect before becoming a government official and working in the public sector. I'm very pleased and very honored to introduce our next speaker. He is from France, from Bordeaux. And I'm going to switch over on to the English language.
Great privilege to introduce our next speaker, who is coming from France, from Bordeaux. And as I've learned just recently, yesterday when we met, he he's a true fan of bio-based solutions, and as a chemical engineer, he has been active also beyond the very active position and work in the timber industry. Today, he has been also been active in agro and cosmetics field. So, as said, background in chemical engineering, a very interesting connection here. Today, does some great leadership work in timber industry on an international scale, and certainly is a champion of innovation in timber construction. It is my pleasure to welcome on stage also Director of Woodrise Alliance, Frederik Straat. So please join us on stage. Join me welcoming Frederik Straat.
Good morning, everybody. It's a pleasure to be here in Tallinn, and I wish to thank the organizers to have invited me today. So I'm gonna have a lecture devoted on the work we have done in the last 15 years in France in the field of building renovation with wooden solutions. And the idea, and that's what I want to point out, is to show you how R&D works, collective studies, standardization developments finally help wood to penetrate the market. First, a few words about the French Institute FCBA. So we are the technical center of the forest and wood sector in France. And this economical sector weighs roughly 65 billion euros with 400,000 persons. And as you can see on this picture, FCBA is addressing all the companies involved in this sector from the very beginning, the seed of the tree, down to wood construction or furnishing industry. What do we do at FCBA? Mainly research works, but also we bring some technical support to industry through consultancy, assessment, training, and testing. We have important laboratories, both in our Bordeaux facilities as well as the one in Paris. Also, we are a certification company, which means that we guarantee quality products, quality services, and also person expertise to the market through different brand trademark that you can see on the picture. We're also involved in the standardization business, so along with R&D, that's bring us to international connection, this standardization issue. And finally, we try to help to dissemination of knowledge through different vectors, such as scientific publication or participant to conferences like I'm doing today. It has been said that a few words about the Woodrise Alliance that I am coordinating. This alliance is a consortium of organisms involved in R&D timber business, either by supporting this R&D works or by operating them. So currently we have 26 official members out of 16 different countries. belonging to the Alliance. And as you can see on the slide, there are 3 types of organisms. On the left side, it's, I would say, the academic world. In the middle, you have technical centers, private or public, such as FCBA. And on the right side, you have, I would say, the field of professional organization, in which you can find EOS, which is the European Federation of Sawmill, and CEI Bois, which is the European Federation of Wood Transformation. And the Estonian Forest and Wood Association is a part of this CEI Bois Federation, European Federation. So what do we do within this alliance? What do we want to try to promote? First, the members help the ones who are involved in preparing conferences, congresses under the Woodrise umbrella to have a nice, interesting, and ambitious program in their events. So that was the case 2 months ago in Slovenia, with the first conference specifically dedicated to renovation of building with wooden solution. And that would be the case next year with the 4th edition of the Woodrise International Congress, which will occur in Bordeaux. Also, with all these people within the Alliance, we share our expertise, our knowledge, and we try also to support projects prepare and perform in between members. And finally, we help to disseminate this information, disseminate this knowledge. It's a world, I would say, of open innovation with the only objective of promoting wood, both in construction and renovation, with a specific focus on mid and high-rise building. So I was talking about Porto Rose. So you see how nice this place was. This conference, very interesting conference organized by InnoRenew. There is an InnoRenew speaker coming up in the program. We show you the nice building they have made there. And also you see how nice this place on the Slovenian coast is and how interesting the conference were. And that's in Porto Rose that I met Estonian people belonging to the Estonian delegation. And these kind people had the idea to invite me here for this conference. And you know what? I said yes. Reason why I'm here today, and I'm very, very, very happy for this. Now this slide is about will happen in Bordeaux next year with the 4th International Congress, Woodrise Congress, a mixture of conferences, technical section, exhibition room, R&D, B2B business meetings, visits and tours. For those interested, I left some brochure leaflets on this future Congress on the tables in back. Now, after this promotion period, now I'm going to go through the lecture, starting with this recent press release from IPCC, I want to share with you, in which was pointed out the fact that it's still time for action. I would mean it's really time for action. And as the IPCC chair said, we have the tools and know-how required to limit warming, meaning that there are still some hopes. Also was pointed out the fact that action in this decade is critical to capture the mitigation potential of buildings, which accounted for 21% of global greenhouse gas emission in 2019. And finally, reducing the carbon footprint of building will require accelerating the energy efficient renovation of existing structure. So that's what I'm going to try to develop. Specifically what we have done in France. So this slide is the contents table I will develop. First, trying to explain the French context. Then this path we have followed, I want to show you where we move from R&D through collective engineering studies, passing through standardization issues, and finally how all the studies and involvement help to implement new solutions and to help wood to penetrate the market. I will also underline the issue of the economical competitiveness of wood compared to its competitor, specifically in this field of building renovation. I will also show you the generic tools that we have developed for different targets, meaning designers, meaning building owners, for instance, and in order to help this promotion of wood. And I will finish with the different examples on different type of structure and the way how a wooden solution were put in these different examples. So the French context is the following. Last year, in 2021, was adopted a national building energy renovation plan, the so-called Plan Climat. This plan makes energy renovation a national priority through the widespread mobilization of stakeholders. 4 priorities for this plan. The first one is to make the energy renovation of buildings a national priority. The second priority is focused on energy renovation of housing. The third one is more devoted to energy renovation for commercial business. And the fourth priority will try to show how innovation can be and is necessary to make this plan a success. The objectives are 5,000 buildings and homes renovation per year, and the means employed in terms of euro, it's 14 billion euro in public investment and premiums allocated to the plan, in which you can add 5 additional billion in energy saving certificates. So how to think of now make this plan operational? On this diagram, you see from the French National Environmental Agency, ADEME, you see that most of the heat loss comes out from the facades. So that invited us to focus mainly on facades issues and to wonder what wood can bring in this renovation with facades. In our opinion, construction system from the wood sector will be able to play a significant role in exterior insulation, thanks to intrinsic qualities of wood, if their use is encouraged and promoted. Now, I will go through what we have done 10 years ago in the field of R&D with a project called Effinov Bois, which was a very first project in France, supported by here the National French Agency ANR, of course, professional support also through the so-called CODIFAB. And the idea here of this work performed on the 2012 through 2015 period was to develop industrial solution for envelope regulation with wood-based systems, taking into account energy efficiency as well as hydrothermal behavior. We have seen earlier the importance of hydrothermal behavior in the wood solution, and as I said, to think of industrialized proposals. If we come up to the results of this R&D work, we have finally, after simulation and experimentation, we came up to the definition of 4 different solution configurations, each with specific benefit. The first one was the so-called low-cost facade solution. Then we had the high thermal performance and the very high thermal performance, and finally the whole wood solution. Whole wood meaning a facade with a framework and insulation with bio-based insulating compounds. So the results of this R&D work provided support, scientific support, which were used in standardization development through a French standard document, the so-called DTU 31.4. I will come back on this later on. Also with this work, one of the deliverables was a design guide, which was developed, including a compilation of experience, which provided a summary of different steps required to lead a wood-based renovation project. After this R&D work came the time of collective engineering studies. So I'm going to show you 2 examples. First, and to introduce this topic, I want to underline the fact that it's been now more than or around 20 years that there is a very strong and continuous support from the French government for developing wood in construction. And in order to catch up competition, several national wood plans occur, you see, in the period starting from 29 until now. As a matter of fact, you see 3 wood plans in a row. There is a 4th going on, which is more dedicated, I would say, to circular economy issues. But if I focus on what we have done in the past with a lot of studies, all the data collected through the studies were valorized with website tools. Excuse me. The first one here, the so-called Catalogue Bois Construction, is a tool for designers, for architects, for engineers. Here, the second one, the so-called BiblioBois, is a tool which has been developed for teachers and trainers. And finally, the third one, the Ambition Bois, as a tool, and I'm going to develop this later on, for building owners. So all these plans bois were supported by the French government, different ministries, the French Agency for Environment, and the professional funding bodies, with the help of professional organizations and different operators, including FCBA. First example dedicated to renovation, a study of the Wood Plan 1 about detached houses rehabilitation, and a guide which was delivered at the end of this work. So the idea was first to make a compilation of renovation solution, to see how technical assistance can be brought to professionals to implement the project. Also, there was an identification of 12 million potential detached houses to be renovated in the country. And finally, the guide, which has been performed, contains 5 chapters, nearly 30 pages of advice, diagram, and practical case studies. Here is the front page of this guide. Second example concerning renovation, study carried out during the wood plan number 2. The acronym is ARBRE, meaning tree in French, for developing and renovating with wood for rehabilitation. What we have done there, the objective was to promote the use of wood in rehabilitation of housing and commercial buildings, to detect, collect, consolidate example of wood rehabilitation projects, and then to produce sheet listing about the building owners' key goals and constraints when they think of their renovation project. So with all this work performed through R&D works, through this national wood plan, then came the time and the step of standardization issue. And because I was focusing on facade, the work won on this wooden facade design, and the French NFDTU 31.4. You see here, oops, excuse me, you see here the French page of the document. So this standard document pertains to new or existing primary structure made of concrete, wood, or metals, covered with facade containing wood frame components for buildings whereby the height of the floor on the top floor is less than or equal to 28 meters, considering some fire safety concerns. Here you have so in this document you have a construction section, also the renovation section, which is our interest today. And here you have a diagram with the facade components. On the left side you have the external sheeting, and on the right side the internal covering. So with this document set, that's new tools brought to the actors to help to make their project. And to see the reality behind all this, I want to show you market implementation through 2 examples. The first one will be the focusing on social housing, and the second one on building heightening. So there is a big social housing actor in France, the company Action Logement here, which at that time asked FCBA in order to promote wood in their action, in their renovation issues, to work on a guide whose objective is to promote and disseminate wooden knowledge. So we have produced this guide on behalf of Action Logement with the idea of bringing assistance to building owners with facade renovation using industrialized and prefabricated wooden construction system. And thanks with the Action Logement agreement, we have brought a free access to this guide, which is available on the Bois Ref website. Bois Ref, which is itself included in the catalogue Bois de Construction I have already mentioned. So in this guide, there are several chapters, framework of the guide, economic consideration, regulatory part, technical section, organization part on what will go on site, and finally, method for launching a wood rehabilitation project. Another example of work which has been done, so there was another framework, a study performed with here the support of the French Environmental Agency, ADEME, a work conducted by the French Carnot Institute MECD, in which the FCBA belongs to, along with other wooden construction technical centers. So here you have the website which has been developed. The project's name was Ligne de Toit, and we are here in the field of heightening. So I made the translation. The difficulty for me is that all these tools that I'm showing, of course, are for the French market in French language, and that needs to be translated if you want to understand more what's going on. And so here, heightening, estimate the potential, that's what you can see on the front page. Assess the feasibility of your project quickly and easily using this free decision support tool for professionals. So this tool is not a dedicated wood tool, but let's say a solution for heightening with different mix of material. So if you press the button, start the project, then you move through this page describing the Ligne de Toit tool in 5 steps. The first step is the idea of estimating the building's bearing capacity. Second step is to define the heightening project based on the catalog of constructive solutions available. Third, how to assess the project energy performance. Fourth, assess the project environmental impacts. And the fifth step is to carry out an economical assessment of the project. Some examples available in this website. We show three of those. First, the example of a hotel located in Paris. So with the heightening combined with thermal insulation. So internal thermal insulation on existing structure and external thermal insulation of the heightening section. The heightening section being a CLT structure covering with clay ties. Second example of heightening project. So here in northwestern France, near Nantes, in Saint-Nazaire, which is a port on the Atlantic Ocean. The example of a residential building. So also there was a thermic concern which had motivated the operation, combined with a heightening using wood. And one of the interests, there were two main interests of the use of wood solution for the heightening. First, in link with the weight of the structure, because this additional heightening didn't increase the global weight more than 9%. And second, to have an operation which has been conducted with an occupied site. Third example, back to Paris here. A social housing example, a residence for students and young workers. So here it's a bit complex because the project was heightening of one level on the street side, that's here, with a wood frame You see on the left upper part of the slide what happened during the operation. And on the courtyard, 3 additional levels on precast and concrete. Again, here, work has been done with an occupied setting. Now let's move to section 3 of the lecture. Let's talk a bit about economy. So here you have on the right side of the slide a diagram. It's a comparative economical situation on what's going on with the concrete construction compared to what's going on in the wood construction. So you see very easily where the economical differences are in between the two solutions. And when you see this diagram with additional costs for wood solution, which may evaluate in the future, certainly with the energy crisis, because as I said to some of you, I think that make this crisis, the energy crisis, may be more harmful for the competitors than for the wooden industry. But anyhow, also additional costs on manufacturing and on the studies. So the only way for wood really to be in the competition needs we need to transfer a maximum number of production houses from the work site to the prefabrication workshops. And that leads also to take into consideration architectural design specificities, also to ensure the coordination with the companies involved in the different lots of the operation, and to think in advance. I missed the... Yeah, there is no more... The green light is gone. It's here? Oh, okay. And to... the time is not running anymore. Yeah, but there is no time running, so I don't see where I am. It's 0-0. How many minutes left I have?
Time is over, that's why.
Time is over? Come on, I'm at 35 minutes.
With the questions.
What?
With the questions.
Oh, with the questions. Okay, so I'm going to go as quick as I can. The idea here is to underline the fact that the more industrialized the solution you have, specifically by promoting the structure envelope covering work package, which means exterior containing the structural component and the envelope that seals and insulates the structure and the external sheeting, then that's the best way to be competitive on the market. A few examples of generic digital tools. The catalogue Bois Construction for designers. So it compiles here and describes current and future standards for the part of the wood structure considered. In this website, you find a wealth of technical resources on model solution. There are some design assistant configurators, environmental data, BIM dictionaries. It's on open access, and you can download content. So if you move through the website, so here the structure envelope, the building model design, then the rehabilitation, and you make the focus, for instance, on external thermal insulation, that's where you arrive. So now I make a slide presentation of Ambition Bois. So it's a digital tool for building owners. This website offers solutions to assist building owners through the various phases of the project, either for construction or rehabilitation. What is taking into account here? First, rehabilitation goal. Second, constraint of executive structure. And then there are experience and feedbacks. So that's the different rehabilitation goals that the building owners may have, classified in 5 chapters. So I propose to you to focus on one of those, which is changing the building structure to bring the living area into compliance. What can the wood bring in with such an issue? In most cases, the low weight of wood and also the good mechanical performance make it possible to increase the surface area of the existing building without alteration of the foundation. That's what you can see here on this example in Paris, with what was going on during the operation, the prefabricated wood facade installed on the floor extension, and how it looks before and after with a building with an entirely new look. Considering the constraint of the existing structure, okay, all different criteria. I'm going to focus on one of them. The constraint of rehabilitation in a protected area. Here, what can the wood solution bring? Wood solution offer the design complete freedom in creating a facade that is in harmony with the building in the protected area. So you see here the existing structure. The final rehabilitating building, as you can see, is in harmony with the heritage site and what happened during the operation. And I will finish, if you leave me 2 or 3 additional minutes, with a rehabilitation example. So you will see it's all spread in the country. First here in the Alpine region, renovation of a holiday village. You see the Alpine mountains and the way it looks before and after. All these examples are, you can find all of these examples in the Ambition Bois website, of course. Second example, here in northeastern France, in Bourbon-les-Brins, it's a secondary school before and after the wooden renovation. Third, in the Pays de Loire, on the northwestern part of the country, here renovation of a multi-unit housing in Cholet. And here, as a matter of fact, it's not a commercial building, it's an hospital in Limoges, before and after. Or you can find all the website references I have described here. And I'm almost at the end. I want to thank you, all the colleagues who had helped me for this presentation. And I like to thank you for listening. And I hope to see a lot of you in 1 year time in Bordeaux in the Woodrise Congress. Thank you very much.
Thank you so much, Frederick, and I hope, I really don't want to be here in the person rushing the presentation and this session. I think from the wealth of material that you showed and the amazing work that you've done is so multi-layered and so vast that we have certainly many things, and I can assure this as head of housing here in Estonia, we have many things to learn from your experience and then from your work. But since we cannot take any questions at the moment because the time is ticking, I really encourage the audience to take this opportunity, this fantastic moment, and please capture this moment during lunchtime to approach Frederick and then ask the questions that might have raised. So thank you so much.
You will be welcome.
Yeah.
And thanks a lot.
Yeah. Thank you. And without further ado, it is my pleasure now to introduce a very interesting couple of speakers who come from Italy. And their focus is on creative sustainability in a rather fascinating way, because what they are doing is that they are rethinking, reusing and rebuilding the discarded pavilions of the Venice Biennale. And Estonia has been a very active participant, both at the Venice Architecture Biennale as well as the Venice Art Biennale, for more than 20 years now. So it is an important, also on a national level, an important topic for us. And I'm very, very interested to hear what Giulio Grillo and Tommaso Cacciari from Re Biennale are bringing to the stage today. So here you are, and please join me welcoming Giulio and Tommaso.
Hello, everybody. Very nice to see you. I cannot have too much lighting, and we are very happy to be here and with this young stage. And you are really the hope for the future. Now we are going to talk you about what happens behind the scenes of one of the most powerful and important events in the world. Now we are talking about the Art and Architecture Biennale. How many of you have ever been visiting the Biennale, or maybe have been part there or involved somehow in the designing of some pavilions? In Biennale, there are the most of the nations, they have own buildings, and many other, they have places in assignation. So they invest a lot of money to give space to their architects and artists and let them make some nice installation, very, very nice installation. But the truth is, and the shame is, that at the end of every Biennale, there is a lot of trash. They trash everything. And even such very nice and precious pavilions, they are dismantled at the end, they are demolished, and the most are, sometimes they are really destroyed and thrown away in the waste, in the landfill. Now, this is a shame, because this is an example. Now, we don't have so much time, so this is an example of the United States pavilion of the 2021 Biennale. It was very nice. They have used those timbers coming from the balloon frame tradition of the United States. They were looking so fantastic. But at the end, everything became destroyed from the creator, from the dismantlers. This is a real shame, because they invest. We normally can see, we have been evaluating now for each pavilion, they can invest from 100,000, we will see a pavilion, they invested 300,000 euro. And the very important thing for many of the creator team are just the 3 days, the 3 opening days. What happened at the end of Biennale? They don't care, and that's why we have been we born years ago, like Venetians protesting against this waste of energy, and this waste of opportunity. For example, the first time we had a workshop with the university, with the students. We were inside the Biennale for the first time with the students, coming from the architecture university. And for example, we were walking and just wondering, wow, Frank Gehry. It was a representation of a skyscraper they were building in Moscow. It was made with clay, with very massive pillars of 40 per 40 centimeters high, all the 8 long of the Arsenale. And we started to make questions. What happens at the end of the installation? What will you do with this fantastic material? So we found the studio of Gehry. We didn't think at it and we will destroy. Oh no. Okay, so the first step for us was making an association and involving a lot of students, a workshop in the university studying for the first time the life cycle assessment for the pavilion. We did this with very important for us, a very strategical curator who have been invited in Biennale, who decided to change. So to give this opportunity to local people to have another kind of approach and to try to find a way. And so, for example, we have been reusing a lot of this clay. So this one was one of the first reuses. And we made a game for children in the school, building with mud. It's a tradition. I know it's the mud lion we did with, for example, the Thomas Kilpert. It was the Danish pavilion talking about the freedom of speech. It was very not politically correct because it was an activist. But so he lost the funding for the dismantling. So he got in trouble because his mind, because his freedom of speech. So we made a deal with him, and we have been reconstructing the pavilion, dismantling with the artist, and reconstructing for an association who were growing, who were born in Venice, and an association that makes together artists, students coming from the school, and
so these were the first workshop to reuse the materials, and then in Venice Biennale, what happened? That a pavilion started calling us and said, "Oh, I like your workshop. Why don't you come and collect our leftover materials?" And we were saying, "Oh, okay, fantastic. We will have more materials." And then a second pavilion called us and said, "Well, we've seen that you collected the materials of our neighbor. Why don't you come and collect ours?" And we said, "Okay." The third pavilion that called us, we said no, because we started to understand two problems. The first problem is that if we collect material dismantled by other people, that material is likely to be very few, ruined, because reusing material is a matter of how you dismantle it in the first take. The second problem was that we started to see that acting like this, we were not really affecting the problem of waste in Venice Biennale. As Giulio said, everything you see, it becomes rubbish 1 minute after the exhibition. Acting like this, we were not really making a change. We were not really affecting the system of the waste production in the Venice Biennale. On the contrary, we were kind of greenwashing and solving a problem for the waste producers. If I go and collect your leftovers for free, we were just solving a problem for a wrong system, and we were not actually making the change. So what we started to think is that, and we started to say to all the pavilions, is that reusing, rethinking, rebuilding, recycling the materials have to be part of the process from the beginning. It cannot be a rubbish collector at the end. It has to be part of the process. First of all, part of the dismantling process, but even part of the building process, because I have to build thinking that I have to reuse that material, and part of the planning process as well. So I have to think of the pavilions using a material that can be reused. So obviously, wood is the best way to build a pavilion, because the best material that I can reuse. If I use, come si dice cartongesso?
Plasterboard.
Plasterboard. If I use, I have to avoid the using of materials that cannot be reused. So wood is the principal. So we definitely started to say to the pavilions, okay, I can come and collect, we can come and collect your leftover materials to reuse, to rethink, to replan, but you have to pay. You have to pay us for the dismantling, and because obviously there is even another big issue in Biennale that we know from years. Biennale is not only the kingdom of waste of materials, is even the kingdom of bad work. In Italy, we say black work, illegal work, work without contracts, work without safety measures. Students used like free workers by architects, by studies, by the ones who expound. And so there is even that big issue, because sustainability for us is an all-round concept. There cannot be sustainability only with materials, but even with work. Sustainability is not only an environmental issue, but even a social issue. So we started to become a company and trying to keep together as a whole this double sense of sustainability. Environmental on the materials and on the workers. We want regular proper wages, we want insurance, we want safety measure, we want to work as people has to work, and we want to save materials. So we started to become a company, and we started to get actually more and more professional, and we started even to make our plan. So this is quite simplified, but our economic plan is that pavilions pay us for the dismantling, so we get the work. They pay much more for our work, because if I have in mind disruptive dismantling, it takes a kind of hire of one bulldozer, 2 or 3 people, a couple of days. I crash and everything, I throw to the rubbish dump. If they pay us, they pay much more for the work, because we take over every single screw, every single piece of wood. So it's much more work, but nevertheless, they manage to pay less. Because in particular in Venice, and who knows, we are on the water transport, to make rubbish, they pay a lot. So even paying more the work, they pay less, because they don't pay the dismantling. And we get the money for the work and the materials. With that materials, we find out, we make other projects that can be social projects, private projects, other pavilions or other big events. And we don't make the other client pay for the material. So we get, again, the work, and he pays less because he doesn't pay the material that's coming from a second life cycle. And so the concept, quite simplified, is that pavilions spend less money, we get double money, and the other client spends less money, and altogether we get less waste in the earth. So this was kind of our first idea, a plan. We managed to become more and more professional and being engaged even in building. This, for example, was not a golden lion that everybody thought, but it was a super experience with Vu Trong architect from Vietnam. And here we managed to learn even different techniques from another world. All of this was made without a single screw, without a single nail. It was all
tied with ropes.
Incastri.
There were joints and ropes made by the bamboo.
And these are just a few examples. Thailand, we made, this was from Norway.
Yes, this was the Rintala Egerson architects from the Norway, and yeah, this is the last project we had.
Switzerland, that's now on. Even this was fantastic, fun working with
Latifa Echak, yeah.
And Burning Man artist from festival in United States. And it was great fun. And so this was the kind of our first development of our company.
Yeah, so this is absolutely great, this pavilion we made for Latifa and Swiss pavilion. If you are going to have a look to Biennale this last month, you will see this. No, this is a very nice project that started absolutely coming from the idea, okay, the artist, the Pro Helvetia, who is the foundation, who cares the pavilion from of the Switzerland, we knew each other, we have been collaborating. But this year, now okay, let's change. We are going to change the Pro Helvetia, the institution. So we started sharing our schedule, our database with the material we were collecting. In this project, there was the possibility to use the timber from the United States pavilion. And so we waited the very last day to be able to see, okay, we'll be able to reuse or not. And so this is, Tommaso said, no, we invented our job, we invented this strategy, we invented this job. Why? Because such a big event like the Biennale cannot become sustainable just thanks to a few crazy people who are doing a voluntary work. We can make a very nice, small life cycle, very virtuous or anything, but around it doesn't change anything. So this change needs to go deeper into the problem. No? And that's why the best strategies for a more sustainable event. The reuse cannot just invent it at the end of life cycle. So you have to plan it like Tommaso said. And why the circular economy? Why don't we think about the Biennale energies and economies to be like a generator for considering the short-term event installation as an armature through which you can give energies for good projects in the city. And for example, I'll show you this project with Anupama Kundo. She's a very famous architect from India. Now she's teaching in Spain. She had been invited in Venice quite a lot of time, doing workshop in the university and some exhibition in Biennale. At this time, she had to represent a building, very nice and very easy building she's doing in India, through the self-constructive methods, with a lot of carpentry, Indian carpenter. So it's very nice and simple house made by big boxes built with concrete and the chicken net as a structure. So they are very easy to make. They are very heavy. But the Biennale, we're talking us, okay, I have this project, can you help me constructing? Okay, but why are you going to invest a lot of energies, economies for something that will be very hard to reuse then? So if I make furniture from the wood I recycle from the Biennale, it doesn't make sense now in Venice to have furniture made by chicken net and concrete that are weight 200 kilo or a bit less. So at that time we were collaborating with the German pavilion Florian Ebner. We got dismantling this pavilion, and for example, now the Florian Ebner, we didn't build this. Now, so they had those panels. They are chetris coming from Czech Republic. They are made by a mix of concrete and part of powder of wood. No, but they have a certification as an ethical and sustainable material. No? So, but the idea for them was to plaster. So, dear Florian, if you are going to plaster everything, we will not be able anytime to take out the screws and to reuse them. So, okay, we can make a deal, we can be part of the dismantling and the sharing, just if you don't plaster it. Okay, good solution. We won't plaster it. And so we've been reusing a lot of panels. We made the boxes of the fulfill home from Anupamakundo. Those boxes that should have been planned to be in concrete. Instead, we made with these panels. And we had a lot of students that were paying a lot of money to be part of the installation of the Anupamakundo. They can, okay, she's an Archistar, so the students can pay €1,000 to travel all around the world and get in Venice for this experience. But we don't like when students get involved in the process of construction and maybe doing some works that is supposed to be done from workers. So the students has to study, has to go deeper the problem, has to create solution and start. So we keeping this keeping away from this pavilion the concrete meant that it was more easy to build. So we didn't need the students to do a very massive work in Biennale. So we sent them to the mainland, to a social cooperative who worked with the homeless people, with the refugees. And so they were planning, since the beginning, while we were building this pavilion, they started to have workshop in this social cooperative, how to manage and what to do then with those. And so we, at the end of the installation, we dismantled everything and we moved everything to the social cooperative, and with the African people, with Venetians, and with another workshop from, involving students from Venice, but also from Spain, we have been transforming. And yeah, so these are nice pictures from the, yeah, this is the boxes from the Anupamakundo reinvented for a common kitchen, or the wood we use for the understructure, because the pavilion of Anupamakundo, it was lifted on some of the structures, so we have this common area with those beams. This is another very nice example. Maybe it's one of the most perfect example of the life cycle of making a circular economies. Rural Studio is a department of the United States Architecture of Alabama, and they were invited in Biennale to have this theater of the useful. The name came after. Now they were invited because of their nice work in Alabama with communities. They have a lot. They have an open university that most of the time teach outside of the school. So in collaborating with the people, they do a lot of self-building and autoconstruction. And so they had a few square meters in the Biennale, and they just needed to build a room and to have some seat, to make projection, to talk to the world, not to the visitors about their work in Alabama. But they didn't want to spend money, to waste money for building a room with drywall, with plasterboard. At the end, those are absolutely unsustainable material, because it's very hard to separate the car from the gesso, and then you trash everything. In fact, in Venice, we pay a lot for the disposal of those materials. So they didn't want, oh, how can we build the room? Okay, we were collaborating with a couple of associations. One was of the social cooperative that got winning a project to extend the hospitality for the new refugees that were coming from Africa. No? And so they needed bed, cabinets, panels to make insulation of those new rooms. And so it was fantastic because the main theme is, okay, what is an exhibition? It's just a medium through which the curator, architect, artist, whatever it is, he communicates to the world his concept. No? So what if we change a bit the medium and we focus a bit better, much deeper to the second life. So maybe the media is changing, but the main concept remains the same, and sometimes it could be empowered. And so the Rural Studio bought exactly the bed, the cabinets, the insulating panels, and they built the room with those materials. And it was fantastic because this was a short-term event, giving, at the end, we used just a few energies and we didn't make any trash. And so after the dismantling, we just have shipped all those material to the social cooperative. Yeah.
Well.
Bye.
3 minutes, and we finished earlier.
Then we can have a lot of questions.
Another step of our experience was, of course, COVID pandemic, lockdown and closure, because Biennale closed for 1 year. And so for us, closing Biennale for 1 year, it means 2 times stop. Stop building and stop dismantling. So we say 19 months without Biennale. We said, okay, our company is closed. We are jobless. We just have to shut down everything. But we managed for a cavillo, how you say, for a kind of
small detail
to work in lockdown. And we said, okay, let's don't close everything. And what we learned in Biennale, building pavilions, architecture, and artistic Biennale, we try to put it in the private market, no? And we try to reinvent the job of the carpenter that in Italy is nearly completely disappeared. And so what we learned mounting Biennale pavilions, we started to give it on the private market, and we started to build how you say, custom-made furniture, tables, kitchens, libraries, wardrobes, internal beds, and we try to use not much recycled material, of course, because Biennale was closed, but natural wood. And we don't use the
MDF, OSB.
We don't use all those glued stuff material. We try to use all natural wood and natural finishing of the wood. And we have to say that things went on. And so now we got a little bit bigger, and we have these 2 legs of the company going around, the kind of more classic carpentry with natural wood furniture thing, and the reinventing, building, and dismantling the Venice Biennale pavilions that actually will start in about 1 week. And so I think this is all. We would very like to thank you for the invitation. I don't know, maybe you were mistaken because we are not architects, constructors, engineers. We are just carpenters and the workers, but I hope you appreciate our point of view anyway.
I want to add just one thing, because maybe this is a good opportunity to make an approach with the Estonian pavilion, which takes place in Biennale every year. I know the Estonian pavilion, we will have a very nice conference in this end of November because of the Swiss pavilion. We have been collaborating so many years so now with the Swiss pavilion and the Pro Helvetia Foundation. At the end of the month, we found the opportunity to make a conference, a workshop inviting there will be 30 curator commissioners from all around the world, and there will be also many connected by the internet, online. Also, the main goal should be to reopen a network where sharing the strategy, and we will bring to this meeting a lot of social public projects that are going to be developed in our territory. No? And so it will be nice in the future we could come back and talk about what we did with the Estonia.
I think it's difficult to underestimate the importance of your presentation and this added value, the cultural dimension that you bring into the discussion. It's magnificent, so thank you for a fantastic presentation. It's very insightful and also very inspiring what you're doing. May I ask if there are questions from the audience? Here, no?
No.
Yeah. Hello. So towards the end of your presentation, you were talking about, I'm here. You were talking about, am I supposed to stand up or can I sit down?
It's good, like as you are. Yeah, thank you.
So you said that during the pandemic, you had then 19 months to kind of reinvent yourself, so to speak. And then you were creating this, what was it, R33? Or a company which then also deals with materials of like low impact. I saw wood, I saw some steel. Now, is that something you're continuing now?
Yeah.
And then my next question is it something you're actually feeling ambitious about? Because 19 months or a year is like zero time as far as I'm concerned. Like you can think of something and then 1 year later you're just doing your first little sketches. But it sounds like you were forced to reinvent your activities and you got it going pretty quickly. Is that the case with you, and do you see a future with that too?
Yeah, exactly. We had in a rush to reinvent ourselves, even because in the pandemic lockdown, we got from Italian government, so a company that closes because it closed the main cultural event, we got about 600 euros 2 times a month. We have all like little children at home, you know, we're very forced to reinvent ourselves. So we kind of made a real rush, and things went on, and they are still going on. Even because carpenters in Italy and maybe in northern Italy more than the rest of Italy are really disappearing. So when people want a custom-made furniture or a custom-made allestimento for interior design in wood, in a artigianale, come si dice, craft, handcrafted, no, they really don't know where to go. They don't know, there are no more craftsmen that does that kind of work. And so we have lots of work that we've been asked for. And so obviously, and we have actually great fun working with natural woods, with massive woods, building things, inventing, designing things. We have great fun. So yes, we definitely are continuing to do that work. We are, I don't know if ambitious is the right word, but we definitely want to continue to keep these 2 levels going.
Thank you, and good luck.
Mm-hmm.
Thank you.
Any other questions? I cannot see too well from here. Can I see any hands? Well, certainly, the reason why I find your approach so amazing is what you also mentioned in your presentation, that you have direct contact and direct interaction with our top architects, artists around the world who come to the Venice Biennale, and I think this kind of changing the heads of those stars, because many follow their example, and people are looking up to what they are doing. So I think it's also in terms of communication and in terms of leading change, a clever move to or approach how to really be the key nudger of this shift towards a more sustainable future. So thank you so much for all these ideas that you bring. I'm very glad that you are here. So a big applause to Läheme eesti keelele üle.
We'll switch back to Estonian. Now we have the lunch break. Please be back at 12:30. So 12:40 we'll be back streaming. So please return to the auditorium at 12:30 after lunch. I'd also like to draw attention that behind the stands, behind the seats, we have our sponsors area, and do take some time to look around their tables. And I'd also like to remind you that you can ask questions via the web, so we can see your questions on our screens. So please don't hesitate to use the opportunities to approach our speakers during the lunch break, and see you back at 12:30. Thank you.
kompetents ja sujuv koostöö. See on Mark Wood.
Tere tulemast tagasi lõunapausilt.
Welcome back from the lunch break. I hope you're all feeling better and fresh. It is my great pleasure to introduce our next fifth speaker. Again, I'll switch over into English.
He has a Finnish name, but he's coming from Slovenia. He and his wife have, interestingly enough, built up-to-date Slovenia's largest timber building. What I also just learned is, since I have twins that are age of 5, he has a daughter, age of 8, and they play piano together. He and his wife, Eva Prelovšek-Niemela, and now you start to get an understanding who I'm introducing here. Their work has won many awards, so it's an internationally recognized and well-awarded practice. It is my honor to invite on stage Arne Johannes Niemela, who will be speaking to you about his research and his work in Slovenia. So please join me welcoming Johannes.
Everyone, also on my behalf. I represent, first of all, I'm a Finn, but I live in Slovenia. So I still also want to thank the organizers for invitation to speak here in Tallinn. It's a great honor and joy to be after many, many years here in Tallinn. So, Innory New Center of Excellence is a private non-profit research institute based in the Adriatic coastal town of Isola, Slovenia. It was founded in 2017 by Fraunhofer Institute, Wilhelm Clauditz Institute, based in Braunschweig in Germany, together with the University of Primorska in Slovenia, on the Slovene coast, and the Slovenia National Building and Civil Engineering Institute and Institute for the Protection of Cultural Heritage of Slovenia. Our core focus, so to say, is to create simply better buildings, better environments for people and environment by using renewable materials, including forest and agricultural materials, and also recovered materials to support circular economy. And why are forests particularly an important issue in Slovenia? Slovenia is actually the third most forest-covered country in Europe, after my native country Finland and Sweden. Despite the fact that most of the eastern coast oak forests were cut already for the needs of the Venetian Republic and once so glorious navy that they used to have. Innory New Center of Excellence has a very international outlook, and we have employees almost from all the continents. This map here is, is not completely up to date. We have also one representative from Africa at the moment. So, in this picture, hardly half of us are present, but of course the stuff is also a bit changing. And our work could be described somewhere on the midfield between science and innovation. So to say, building bridges, stimulating fruitful contacts between academic research, commercial actors, and wood-related industries. So to say, we are a platform where science meets innovation and business. As we at InnoRenew are of very diverse professional backgrounds, ranging from us architects and engineers to material scientists and computer experts, etc. One of our goals is to monitor human health within the built environment and how can the use of renewable materials contribute to it, to the health of people, also in buildings and in furniture, etc. Okay, of course, this is a bit challenging, also this interdisciplinarity, but the coordination is achieved in our institute by approximately 5 active research groups. Our group strives for combining the data of other groups to promote and realize sustainable buildings with renewable materials. And then, why we are located exactly in Isola. It's, I must say, also as a foreigner there, it's a very diverse and interesting region. It's far from province, what it actually is, if we only see it in strictly national point of view, because it's on the border of Slovenia, and then there is the Italian side, the border city Trieste. But that is a very multinational region of origin. Trieste was, as a gateway to Vienna, still 100 years ago, a real cosmopolitan center of culture, attracting also such residents like James Joyce, the world-famous writer, and so on. So in this respect, this region has got very much potential also in the future. And as an architect, I want to point out this, that especially I, as a foreign architect, there really want to understand and appreciate the local context in order to design, stand behind what we have made there. Of course, the region has got some challenges. It's not so well connected. There should be a better public transportation in urbanistic terms between Trieste and the Slovenian coastal towns that still so much remind of the Venetian Republic, but they are a bit lost in space still to some extent. Isola is a medieval small town there in the middle of that Slovene 45-kilometer strip of coast. It has roughly 12,000 inhabitants, and it's very vivid in summertime. But then, okay, in the wintertime, it's the lack of tourists and those, for example, international marina users are replaced by students of that local Primorska or Università del Litorale students. And our building can be seen actually here. It's approximately 1 kilometer apart from this medieval town center. And this district is still under development partly. There should be, particularly here, this is an abandoned railway. Unfortunately, there is no railway at the moment to combine the districts, but it is planned to be a cycling road, which already exists here further away to connect all the Slovene coastal towns until Piran. That was already shown in the previous presentations. It's a very fascinating Venetian-style town. This building here, just the rendering from the beginning of the project making, is almost completely in-house built. I mean, the only exceptions that we had to outsource, so to say, were light designer and landscape architect. But of course, our research team was very crucial help to define the goals, first of all. What do we want to achieve there? Especially I want to mention Dr. Istok Sustarsic, who is a structural expert of seismic wooden constructions, which is also an issue there. So the building, how it stands there, we had to follow the local urban master plan regarding the outer limits and the heights of certain zones, but we could still adjust a bit and define ourselves the shape of these volumes to a certain extent. And the ground floor, as we enter the building, is dominated and centered around this 4 floors high atrium. And the research laboratories are mostly concentrated also on the ground floor. And these connections, we wanted to simplify a bit this labyrinth-like layout of the ground floor by offering some vistas for these main semi-public corridors. And they also serve, of course, as emergency exits and some space for recreation. I here want to mention particularly about these laboratories, this acoustic laboratory here in the corner. It has got 2 very different chambers. This is the so-called reverberation chamber with reverberation time reaching up to 10 seconds. It's almost like in a cathedral, although this is just roughly like 6 to 6 to 6 meters size. And I once heard there a female choir singing, just making a short rehearsal, and it was truly impressive sound. Then there is the opposite for that, is the complete silent room, where all the echo is damped. I mean, there is foam on all the sides around, so you have to work on such a network. This is structurally out of wood, whereas this other chamber was unfortunately had to be made out of concrete. Other labs include chemistry, microscopy laboratory, workshop to provide wood samples for our testing facilities, and such. Then the traffic is arranged so that the necessary access for truck delivery for those like acoustic lab and workshop and composites manufacturing lab is arranged from outside. But otherwise, the pedestrian and bicycles and also those with some disabilities, their access to the building has been privileged to make it as attractive as possible. It's also connected with these outdoor recreational areas that I already mentioned. For example, here next to the main entrance, this patio and stair down, which is a result of a slightly sloping structure, sloping surroundings. We had to adjust the building into that situation, but we wanted to make that a gesture out of it. And then we have this kind of wooden canyon here, and then some spaces also where some breaks of events can take place. First floor, we have spaces for conferences and smaller seminars. This bigger conference hall can take maximum 120 people. And then we have a smaller one, and then there's still 3 seminar rooms. And this floor is also connected to the outdoors, which is a great opportunity for some events. Like there can be an exhibition, has been already on this roof terrace. It's there. Although the roof terraces are not completely finished yet, we have no wooden pavement or such, and then also some pergolas we wanted to install. And then I just want to point out still this access from the street level. Also, during the events, we can open the gate here so that the people can enter these outdoor spaces, and still further on to the second floor roof terrace, which I will, no, okay, this is now, otherwise second and third floor are quite similar. There are offices of our researchers, and in third floor also this open office. Second floor has got closed offices all around. And here also, still I pointed out these terraces, which here are also for testing purposes, like we have some wooden samples that our researchers are testing how they take weathering and other effects like also pollution and changing of temperature and so on. How do different modified wood samples behave? These sections just downwards on the slope, showing here through the main lobby and staircase, and here through the acoustic lab and workshop. We have also underground garage. Had to be so that, I mean, it has been also serving partly as a storage, but it's a kind of flexible space. Here is just a short video of the proceeding of the construction. So this piece of music composed in Venice by Vivaldi. Then how the construction started. Fortunately, we didn't find any big underground caves, which can happen in this region, or especially in the nearby karst area, with the world-famous UNESCO place, UNESCO cave Skocian, and then a bit more touristic Postojna. So we avoided bigger troubles, fortunately, here. So we proceeded quickly from the basement above the garage, and so we could finish all the non-wooden load-bearing constructions. Unfortunately, this much we had to make out of concrete and steel here, around this main atrium. So it went with the CLT assembly then from the first floor onwards. And here the main staircase element is being lifted to the final place. Those were manufactured indoors in a factory and then transported in pieces and lifted. Here, the lowest staircase run being installed. Then here is where the visions and the real-world construction practices are challenging each other. Staircase proceeding. And finally, this roof light. This is all made out of glulam, these stairs and the roof. Of course, the slabs are CLT and wall elements as well. Here we have the arcade, which is connecting the street level and those roof terraces. Again, some indoor comparison still quite unfinished. Then, since we are a research institute, this monitoring is a very important part of our institution because it's both from the scientific and research and from maintenance point of view. Humidity and temperature are measured constantly in several spots around the around the building, a bit on the outer facades, and then also flat roof leakage sensor system has been installed. Fortunately, there has nothing happened yet. Facades are also monitored, like wood aging. And then, as I already told, we have these niches for some coffee breaks and so on. They are also offering different microclimatic zones. We also measure the circumstances there. Of course, it all changes all year around. Sometimes, for example, this one here can be a very attractive place to hide away from the sun, while in wintertime it can be too cold. This is how the terrace should be one day, but we are still waiting for the offers to make it. Then still an engineer model pointing out the proceeding from the concrete phase to the steel addition, and finally the wooden parts completing the volume. We have, or particularly our expert Istok has performed vibration tests, taking into account the seismic activity of the region. Okay, of course, it's not so hazardous there as it is in some areas nearby on the Italian side, but still possible. Yeah, here is this vibrator operating. Just shortly, and some devices connected to that. Then, as we had in the last very interesting presentation, a lot of these life cycle things, we also tried to perform, from a research point of view, the analysis of how much waste and how the construction generated and how much we could avoid by recycling. We had to sort out like amounts and types of construction waste wood and try to minimize burnt waste. And then we have also a life cycle analysis expert in-house, so we made this kind of analysis. Just it was found out that the foundation is the real hotspot regarding the carbon footprint of this building. Of course, there is a lot of steel and concrete, which already generates it. But even if we take into account that it should remain there for a long time, but it's still a heavy issue. But we tried to compensate our CO2 emissions as a team-building event. We, with nearly all of our employees, contributed to planting altogether 3,000 oak trees around the region. We were, of course, choosing local species that have a chance to survive there. It was quite a big action, but fun. And then, wood moisture content had to be measured already in the construction phase. In many spots, especially around the facades. Of course, okay, here we are already in the phase where the roof is somehow closed, but as we couldn't have construction time shelter, it was we didn't have either so good luck. Sometimes there was a lot of rain, and also afterwards, I mean, especially in that phase, actually every gap, such a thoroughfare for pipes and border of materials, were a potential leakage spot. We were also using thermal cameras to discover some moisture. Unfortunately, some areas had to be opened. I mean, the hydro isolation had to be removed and dried and then reinstalled. when the wood was dry enough. Okay, this is a panoramic view. The building is not curved like this, but still pointing out that the shelter was not possible. Some details that were also causing some difficulties during the construction. Then how these CLT slabs, we were just figuring out that this lower type here was having a higher competence with vertical loads and also with potential earthquake situations. So that was used quite largely here. Still adding, closing the gaps. Of course, some moisture was discovered. It had to be dried as much as possible. In general, the south and west facades were most exposed, as well as leakage through unfinished roof. Exposure to wind and sun dried, on the other hand, the trapped water quite quickly, even despite lower temperatures. There is, of course, a strong Bora wind seasonally, very commonly occurring. So main challenges, we had to follow especially these issues like general precision of the works, which is really necessary for timber construction. And I must say that most of the contractors, especially in Slovenia, were not completely used to it. Then there was, of course, this global COVID-19 causing, if nothing else, but delays of everything. And then prices went up already before what is going on now. In that way, we were lucky that we finished the building before this current situation. And long delivery times for certain elements. And then, of course, last but not least, the public procurement demands. So now we are coming to the part where we can make a short round trip in the building, how it is. This is the main entrance, and this lunch break amphi, or however I would call it. Here is the bicycle storage. This seems not to work again, this pointer, but so we wanted to, as I told already earlier, to make the pedestrian and bicycle access as attractive as possible in order to support those modes of traffic instead of cars, which are otherwise quite dominating also there in Slovene coast. This is the main entrance. Here we have the reception desk. We wanted to make it out of solid timber. It was a bit difficult because the carpenter didn't have on stock such timber that would have dried out for 3 years. So we had to improvise there a bit, combine some pieces, but now it is there. Then this main staircase and atrium, we have some space for changing exhibitions. This is from the very beginning, there were some students having their projects presented. Then what I like in this staircase is the sound when you walk on it. It's like some wooden roller coaster to some extent. I mean, I don't feel that it would break down, but it's making this sound that you really feel that it's wood, the construction. Only some minor parts of steel to connect wooden components. We have also this illumination on the handrail, which is especially in the dark time, maybe more important. We were trying to follow the so-called REED principle, I mean restorative environmental ergonomic design. in terms of encouraging the people to use healthy manners of movement and working. So to say, going stairs up instead of taking elevator. And now at the moment, as we are also trying to spare energy there, I think the elevator is even switched off only, I mean, it's only for necessary transport of some items that we need, or of course if someone needs it for, I mean, someone in wheelchair or like that needs it. And then these balconies around the atrium are also like stand-up desks so that people can temporarily work there with laptops or, I mean, standing instead of sitting all the time in the office. Or then, of course, they are a nice place to socialize, to have a cup of coffee. Still some pictures reaching to the top. This is the main conference room. Here it's made for, it's set up for panel discussions at the moment, but we have flexible furniture. We can set them up also for more efficient rows. And then this main conference area bathrooms, we have such a specialty like wooden sinks. There is one local artist in Isola. She's using the trunks of some fallen trees. Like here we have linden. I think this is for ladies. And then for gentlemen there is oak, just to make some stereotypic use. But they are quite nice to use, and actually also we were a bit afraid how are they to maintain. But if we have some discipline to clean them up every here and then, they have resisted now at least these 1.5 years against bigger damage. This is the director's office. Dr. Andrea Kutnar is, when she's not traveling around the world in conferences, she's here, and there's an access to this loggia balcony and also to this still slightly unfinished roof terrace behind. Yeah, we wanted to keep as much of these load-bearing CLT elements visible in the indoor, in the interior. Okay, it doesn't need to be all around, because some of our researchers have also figured out that there is an amount of wood around you, after which the effect of wood doesn't anymore improve the way how you feel. We have those human health researchers who have analyzed through the saliva of the testing persons, how do they react when there is different sorts of wood, either in natural form or modified or painted. And of course, natural wood has, those research have suggested that the natural wood has got a very benign influence on reducing stress levels when a person is stressed by some other reasons. This is just an ordinary office room. We have also here this possibility of, I'm sorry, I have to find out, to pull out some desks to gain temporary desks to stand up. As we had this furniture made as much as of wood as possible, so we didn't finally, we couldn't finally use such tables that are lifted up and down. So this is kind of compensating that. And then actually all the windows are openable so that people can also themselves decide when to have some fresh air. Although, of course, there has to be a discipline to close all the windows, especially when you leave the office in the evenings. This is still the third floor. We have there a bit, this so-called open office is still a bit searching for its final shape. Here was the same exhibition of the students as we had in one of those first indoor photos. Now there are some working desks. Some of our staff is working there also, but we must develop further some acoustic elements to damp the echoes, especially on this event. Like if someone is having some Teams meeting, then everyone hears it in this in the same space. So it's not a problem in those offices, but in this open space we need still some elements. But we have in-house also acoustic experts who are working. We all are working together to solve these problems and also design it in such a way that it would fit to the demands of the employees. Here's still some evening photos. This is the pedestrian access towards the building from the street. And the staircase arcade to the roof terraces. And the loggia balcony facing towards the north, towards the sea. Here in the evening light, the sunset behind the town of Piran, that some of you remember from the Woodrise conference. I have 20 seconds time, according to this, so I can thank you for your time.
Thank you, Arne, so much for your beautiful presentation. I think the aesthetics of the building that you showed, the project, the whole visualization of such an atmospheric, wonderful project is utmost outstanding. So may we have questions from the audience, please? Can I see a raised hand somewhere? Is there a question?
Hi, it's me again. I didn't catch something because maybe I wasn't paying attention or I haven't done my homework, but you kept on talking. I understand you are an architect and your wife is an architect and you were the architects of the building, correct? I saw those two names, Eva and your name. And the company that the building is for is also your company. Is that true?
Yeah, we are not the owners of the company, by far not. Our director is not an architect, she is a wood scientist, but we are employed in the firm, also with my wife, to work together with those other experts, because they saw it earlier that it was too difficult for them to collaborate with some with the scientific issues. And they wanted in this way also that the building should demonstrate the possibilities of wood science and also these human health issues and such. And that's why it's all kind of integrated in this case.
Yes, it just seemed quite wonderful, whatever arrangement you have there. Because you have like a laboratory, then you can make the building, you can test things, and then you have this, you could say, enlightened company that is supporting all of this. So I just wanted to say I'm agreeing with you very much, the aesthetics, especially I love those handrails on the inside of the atrium, which are to scale with the ceiling, supporting the rooftop. And so you have a good bunch of scale working, different scale for the wood. And of course, finally, with those wash basins that you're going to see, how long will they last? Maybe in a year's time, you're going to be sanding it. I don't know. Anyhow, thank you very much.
Thank you. Thank you very much for your kind words. Of course, I felt a great responsibility as a foreign architect to do something. Of course, this is not my design alone, or not even mine and my wife's design only. There is added information from our other experts. And of course, that's why I was also talking about those cultural backgrounds, really a multitude of culture there in this Adriatic region. Of course, we wanted to respect that in a way. Thank you.
Thank you, Arne, again.
Thank you very much.
As was evidenced so well by Arne, how different disciplines and different kind of knowledge working in synergy can really result in fantastic outcomes. Our next presenter also combines the knowledge and expertise and competence of both an architect and an engineer. And she comes from Belgium. And she will present some quite remarkable large-scale timber projects that have been designed together with quite well-known architecture offices. So also collaboration, let's say, on an international scale, and certainly between different disciplines is very strongly coming through her work. And she certainly can show us how to use the right material in the right way, in the right place. So please join me welcoming on stage Charline Lefebvre.
So thank you for this introduction, and thank you for inviting me to this wood architectural conference. So I'm going first to present you quickly and briefly the office Ney & Partners. So it has been created in '98, and the Ney & Partners office is a general structural consultancy office that design bridges, special structure, and buildings. But in 2013, we decided to create Ney & Partners WOW, Worth of Wood. So an office specialized in timber engineering, because we were convinced that timber construction is the future, and that this material requires specific knowledge, and that the architects, the project owner, everybody in the design team needs to be well advised to include this material in his project from the very beginning of the design phase. And so, we work on many various projects, such as schools, housing buildings. We will have soon our first pedestrian wooden bridge. And we are based in Belgium, but we have now also an office in Paris, in France. So, let's speak about the two projects that I'm going to present you today. So they are both along the canal in Brussels. So it's not a coincidence if they are not far from each other. It's because it's a neighborhood that is really in development those last few years. And so there are a lot of projects that are developed in the neighborhood, and we are right now we are also working on a big housing project that will be just next to the Gare Maritime. The Gare Maritime, here you can see a photo of the project. It's located, as I said, on the site of Tour et Taxi in Brussels. So it was once Europe's largest railway station. It was built in the early 20th century. And so you can see that, yeah, the goods arrived from the canal. They were transported to this area that covers 40,000 square meters. And then it was distributed by train all over the country. And the development of roads and the progressive removal of custom barriers reduced the activity of the site until it was completely abandoned. And so it needed to be renovated. So the project, yeah, you can see here an old picture of the Gare Maritime. It's in French, but it means a maritime station. And so the structure consists is composed of 3 larger and 4 smaller halls. So the load-bearing structure consists of 3 hinged frame made of rifted steel trusses beams and covering a span of 26 meters. So yes, the project was divided into phases, of course. First, the renovation of the existing structure. So the structure was overall in good condition. Yes, there were only some damaged and corroded elements in the rear facade and under the gutters. And concerning the wood and carpentry, we had, of course, to replace some elements that had been burned or that had too much mold. But we made monitoring of the structure to ensure that it was correctly drying after the renovation of the wood. And this monitoring allows to prevent the replacement of many elements. So we were able to keep most of the original roof. So it's a real estate developer called Nextensa who bought the site and who developed the project. And so we were quickly convinced that a timber structure was the most appropriate solution for the Gare Maritime. First, there was a strong desire from the entire team to make the Gare Maritime a pioneering project in line with the existing structure at the time. And so the idea was to make it an example in terms of sustainability and circularity. And so this first part is really important because you need to have all the team that is involved and that wants to build in timber. It's really important, yes. Then, there was a demand to build in a really short time, a short period, and so a fully prefabricated structure was the most appropriate way to do it. Then we needed also a light structure because to limit the impacts of those new pavilions regarding the existing foundations, but also to be able to work with small and light machines because as we were under these big holes, it was not possible to use traditional cranes. And finally, but not the least, it's a covered site, so we are completely protected from the weather conditions. So it was really the ideal situation to have a timber construction. So it's the office, Nuteling's Riedeck architect, was chosen to develop the project. So there are 45,000 square meters of shops, retails, and offices that are divided into 12 pavilions. And yeah, there are two smaller in the front, but then we have 10 almost identical pavilions. And so the idea of the architect was to recreate a covered city inside the city. So that's why we have this main big street in the center of the hall that can host events. There is also a food market at the end. There are trees, and I think this year it hosts, for example, a world paddle competition. And yeah, we have the smaller street that distributes between the pavilions the circulation to the main street. So we can see it here. So this big main Rambla with the pavilions that are that goes up to the existing structure, but that remains completely independent from it. We had to develop, to think about joints to let the thermal expansion of the steel structure. We needed a movement possible up to 7 centimeters, so independent from the new pavilions. And so, as I'm a structural engineer, I'm going to talk to you a little bit about the structure. So here you can see one pavilion. So it's a 3D inside the existing structure. So basically, it's made with a CLT core. It's a column beam structure made with glulam and also LVL beams when we needed beams with higher mechanical properties. And all the floors are collaborative ribbed floors. So we have 10 centimeter thick CLT slab that is screwed with glulam ribs so that they can walk together. And so we have the ribs every 1.2 meter. And we have this high technical raised floor where the idea was to put most of the techniques inside to limit the number of holes that we had to make inside the ribs. So the stairs are also made in timber. So here you can see the crossing stairs connecting two pavilions. So it was simply made with two glulam stringers. So the wood remains mainly visible on the project, so we had to have invisible joints. So for example, here, to ensure the continuity of the glulam stringers, but also for the most heavily loaded beams on the project, we used a HSK system, so it's perforated steel plates, the HSK plates that are molded into the wood and that are glued with an epoxy resin so that it remains completely invisible. Here we can see the mounting of those stairs. And so the timber company that worked on the project was Dublin Timber. They are based in Germany. For the ribs, we had Sherpa connector, so we have a female connector on the ribs and a male connector on the main beam, and so they are just connected together after. So it's quite nice because it's we don't see anything, but you don't have a lot of tolerance for execution with this kind of connector, so you have to be careful to be sure that the timber company that is going to work is able to do it. And yeah, for the cantilevers, we took advantage of this technical floor to keep the principle of ribbed floor, but with a reversed rib, so that when we walk under the cantilever, we just have the impression that it's only a 10 centimeter thick slab that goes up to the existing structure. And so we see the final result here. So we are on the second floor. We see the existing structure and the mezzanine that is just on the right. So to connect the column and the beams, we used steel elements. So to ensure a direct transfer of vertical loads, but of course at the end it's completely hidden also for fire protection. And so fire protection, was a big topic on this project. On the beginning of the project, the project owner asked a derogation. And so we were asked to design the structure to be R30, so resistant to fire during 30 minutes. And very, very, very late in the process, they learned that the derogation was refused. And they asked us, okay, is it possible to keep the structure as it is, at the same section, to change nothing, and to make it R60? So if you know it from the beginning, it's easy, but if you learn it after, it's a little bit less funny. It was a big moment of stress for us. So we finally decided to use an intumescent transparent painting, especially developed for wood. So it's easy to find on the market paintings that improve the fire reaction of wood, but finding paintings that improve fire resistance with technical data valid to know what's the impact of this painting on the section of wood exposed to fire, it's a little bit more complicated. But we found one. And it had the technical data were valid for a certain span and a certain load, and these assumptions were not completely met regarding our project. So we had to make this real-scale mock-up of the floor to test it in a furnace. So we did that in collaboration with the University of Liège in Belgium. So you can see here in the lab. So you see here a photo inside the furnace just before the test. So the floor was already painted. So yeah, it's a transparent painting. The only difference is that it's just a little bit more shiny, I would say. But with the time, it becomes less shiny. And here, we also tested some configuration of different joints of the project with different type of protection. So you can see here all the samples with the thermocouples. So I put you here a small video. You won't see much because there is a lot of smoke, but just to feel the atmosphere of the test. And then we were quite happy because we reached the R60, but soon after, the structure finally broke down. So it's nice to share. At the lab, they were not very happy, but. So in addition to the fire tests, we made also, in collaboration with the University of Liège, finite element modeling of different joints of the project with the software Sapphire, so to perform thermal and mechanical analysis. We were wondering how we could define the load-bearing capacity of a joint exposed to fire, because the behavior of timber depends not only on its temperature, but also on the kind of solicitation, if it's tension, shear. Finally, so we had this general model with the joint. With this model, we were able to know the temperature that we have along the dowel. And then we modelized the dowel as a beam that was supported by stiffener. And the stiffener was representing the behavior of the wood. Yeah, thanks to the temperature along the dowel, we were able to characterize each stiffener, and then we put a load at the place of the slotted steel plates, and with an increment calculation, we were able to define the load-bearing capacity of the dowels. But so it was quite a work. So a few words about the mounting. So it was a beam project, and so the structure was fully prefabricated, and it was extremely fast. One pavilion was built in 8 weeks, and the entire timber structure was entirely executed in 10 months. So here you can see the core with the big LVL beams with nice cantilevers. Here the final results. So we are here in an office space with the cooling ceiling between the ribs. Here it's a staircase inside the course, or it's not emergency staircase. Here, we are in the main street with the trees. So at the end, we had 9,000 cubic meter of wood on the project. So it was 6,000 cubic meter of CLT and 3,000 cubic meter of glulam. So it was at the time it was built in 2019, one of the largest timber building in Europe in terms of volume of wood. And it won several prizes in Belgium, in the Netherlands, in Spain also. Yes, and we did calculation to see, as the European forests are growing, we calculated that it took only, in average, 16 minutes for European forests to regenerate the quantity of wood that is on the project. And of course, there is also a lot of oak that is not quantified, but in all the carpentries, parapets, and finishing. So now, if we go a little bit further on the canal, we arrived on the Brunfaux Tower. So it's an existing tower. And in 2013, a competition was organized for the renovation of this 16-story tower with 97 apartments and with steel frame structure. And so it was built in 1964 for social housing, and the tower needed to be completely refurbished. So the requirements implied an improvement of the means of escape, the accessibility, the thermal and acoustic comfort, and also the enlargement of some apartments to accommodate bigger families. And so together with A229 architect office and the tier architecture, we propose to keep the original volume, but to enlarge the width of the tower and also the height of the tower by adding 5 new stories. And so to be able to do that, on the 18th floor, we have those big transfer trusses beams, so that are carrying the 5 new floors, and so the span is the new width of the building, so that the support of this truss beam is the new facade, and so we have new foundations for this. So you can see it here. So we chose to make this extension also in steel, in a steel frame structure, to keep the same stiffness for the bracing facade, and also because so all those trusses beams that we have on each house on the 18th floor remain visible in the apartments. So we needed the small sections. But so you are going to ask me, where is the wood on the project? First, we can find it in the floors. So we had the existing floor system was extremely light. It was a simple steel deck. So we needed to find a complex floor light also, to be sure that we don't have too much extra load on the existing foundation. Then the height of one story was 2.78 meters, and so it was also important to find a thin, complex floor so that we could ensure enough height under the beams. And then we had to find a system that we could easily insert it inside the existing structure. So that's why we decided to work with CLT panels with a thickness of 16 centimeters. So the span is 3.60 meters, and the 16 centimeters are mostly needed for the fire requirements, because here we had also derogation to be R90. But at the support, we have big notches, and we have only 5 centimeters left. And the CLT floors acts also as a diaphragm to transfer wind forces to the cores and the bracing facades. So we had to design all the joints carefully. And so here, as we needed a light and thin floor, complex floor, it's CSTC, the Scientific and Technical Center for Construction in Belgium, who made tests with CDM. It's a company that sells acoustic resilience. And so they developed this finishing, and we have only, it's 10 centimeter thick. And so with this system, we were able to meet the acoustic requirements. Concerning the notches, we were not so comfortable to have such big notches. So we made a lot of research, because as we know, CLT is not in current standard. We have to find information with fabricants, universities. And we found a research made at the University of Lund in Sweden. They had made a lot of tests on CLT panels, notches, on CLT panels with a thickness of 16 centimeters. That was perfect, that was our case. But the conclusion were that if you have a notch with a height less than half of the thickness, it's okay, you can use the empirical formula that is given in Eurocode, but if you have more, you can do it, but the formula is not valid anymore. So we had to do tests again, this time with University of Mons in Belgium still. And we tested different type of configuration, different configuration of the layers, different types of screw reinforcement. And so we were quite happy. Here you can see the tests. So the load-bearing capacity that we reached was higher than what we needed, but as it was not possible to test long-term effects, moisture variation effects, we put screw reinforcement anyway. So in addition to the CLT floor, so wood has proven to be also particularly suitable for the construction of the facade. So we have timber frame facades that allow to integrate directly the insulation in the thickness of the facade. And they also allow a high degree of prefabrication. Here they arrived on site with the insulation, the inner and outer panels. It was a discussion with the timber company. We could have also had the carpentries and windows, but here for manutention and other parameters, they decided to have this level of finishing. And so in order to ensure the accuracy of the prefabrication, a point cloud of the existing structure was made. It was post-processed into a 3D model. And so this 3D model highlighted the slightest imperfection of difference of level. So we can see, that's why I chose this picture. You can see here that we had a steel beam that was quite deformed. And so on the basis of this model, the entire wooden structure was modeled in 3D using CADWorks software, and this enabled the wooden structure to fit perfectly into the steel structure. So you can see here the CLT floors. Here we have one level with the facades and the entire wooden structure. So now the timber structure has been completely executed, and we never received a call from the company to say we have a problem, it doesn't fit. So it was extremely efficient. So in conclusion, the steel framed Braunfaux Tower will have now 1,500 cubic meters of CLT, and 5,650 square meters of wooden facades. So the renovation of Brunfaux Tower demonstrates that timber is particularly adapted to this kind of, to meet requirements of such renovation rehabilitation project, thanks to the precision brought by the 3D modeling, the high degree of prefabrication, and also the lightness of the material. So here's some photos of the construction site. So it was the existing foundation just before having a new concrete raft for the new concrete core. Just to see the scale of the project. Here we have the CLT inside the existing structure, CLT panels. Here it was the mounting of the facades, but before they were not yet the 5 new stories. And yeah, here we have the tower with the Brussels landscapes. And it's more recent photos that we took recently, where you can see it's quite nice because the architect decided to have a finishing on the smaller facades that reflects light, and so we can already see here on the photos that it was on a sunny day. The tower is almost transparent into the blue sky. And so just a few more words to finish this presentation. So we like to use this graph that was developed by the Royal Institute of British Architects. So there is a lot of information on this graph, but basically what we can see is that now on the pink values, it's the CO2 emissions that we have per square meter for new buildings. And in green, it's what we should reach by 2030. And so we quickly see that it's almost, it's not almost, it's the half of what we build now. And if we look also those values that I've had so it's possible that you don't have exactly the same values. It depends on a lot of parameters, the products, and the type of cements and so on. And here I have excluded the end life scenario. But still, we can see that the CO2 emission for 1 cubic meter of concrete is 5 times, more or less 5 times more than 1 cubic meter of timber. So I'll let you do the math. For me, the conclusions are quite evident. So at the office, we are trying to do now the life cycle analysis of the structure of all our projects. And so we compare them. So here, as we work also with this general office and partners, we were able to compare the values that we had for 3 different types of offices. And so, yes, Gare Maritime that is in the center, you can see that there is really a difference. Something that we often hear is that, building in wood, it's more expensive. What I like to answer is that the structure is responsible for 75% of the CO2 emissions for the construction of a new building, and it represents only, in average, 30% of the total cost of the building. So it's worth it. So thank you for your attention, and if you have questions.
Thank you, Charlene, showing so delicate solutions about. Amazing was also on the first project how the wooden constructions can be done so purely without any visible connectors. I wanted to ask you also on the first project, you showed one staircase out of wood, and you said it's not the emergency one. Did you have a separate staircase for the emergency? And was it made out of wood also, or was it different?
They were made of wood, but they were considered as external staircases, even if it was inside a covered building. It was, on the outside of the pavilions, and so it was part of the derogation, but it was accepted to have those.
Do you remember what was the product for the fire safety locker? As you said, to get the 60 minutes fire resistance, it was hard to find.
Yeah.
And then I thought it's one of the main issues of doing very large or high wooden structures is basically, do you have the locker or you don't? And then you can build it or you cannot build out of wood because the fire resistance is the main factor.
The name of the product, it was Aton PV33.
Okay.
So it's
so architects,
it's produced in Italy.
It's the key for the wooden structures. So, do we have questions from the audience? Yeah, please. Erik, you are the second. I saw your hand was almost up.
The tower project, was it economically feasible compared to building a completely new one instead of this renovation on the steel frame?
Yeah, it's a really good question, because if we had decided to demolish the tower, in fact, it wouldn't have been possible anymore to build such a high building. So, yeah, so I think this was the best idea. And the budget of the project is 17 million euros, I think, just for the record.
Why wouldn't it be possible to rebuild it? Was it like city planning issue that when you take it down, then you have free landscape and you don't get the new permission to make anything high?
Yeah, it's not anymore in the city plan. So
yeah, comment or question from Erik.
Thank you very much for a very great presentation. I'm thinking that it's quite unique to have a company that is dedicated to timber solutions. And I was thinking, was it a collaborative decision, or was it the kind of vision of a partner, or was it your vision? And how has business been? Is business good? Estonians are all about the money, so I just want them to know that you're doing well. So,
yes, the business is good. I think that is the same in every country. We see that timber construction is growing more and more, even if we have the crisis now. But all the materials, including steel and concrete, are also impacted by the higher prices. So no, it's really working. And hopefully for us, you are almost the only one to do that in Belgium. So.
When you do these kind of constructions, I mean, to go into the aesthetics and detail, it means that engineering must be there in the very first stages of the sketch. Does it mean that when the architect, you work with different architects, is involved in some project, they ask your help or consultation immediately, or in which phase do you get involved in these kind of projects?
For both projects, we were involved immediately, and that's the best, because you don't build with the same span with the timber structure that with the concrete structure and so on, and so that's things that you must know.
Yeah. So it means from the first day on, the architect says, Charlene, come and help me. I don't know what kind of house I will do. I don't know what's the size, but be with me. Bear, hold on. When I get the idea, help me. So it means in the first days of the sketch, you already start thinking.
There are also a lot of timber engineering products that exist on the market, and architects maybe don't know everything that exists now, so we can also advise, or here it's better maybe to have a timber frame structure instead of a massive timber structure and so on. But yeah, as it's prefabricated, the problem is that usually, until now, there are still projects where it's not really calculated because it's prefabricated, so it's for the execution. And so sometimes timber companies come to us and say, and we have to find solution, but it's hard when the project is already in execution. It's not the same.
Thank you, Charlene.
Challenges.
Thank you for your presentation. Thanks.
Okay.
The next presentation will be by the co-founders of Mars Architects, directly from the heart of a city called Paris, France. And the company was founded 10 years ago by 3 partners, and 2 of them are mostly welcome to the stage, Raphaël Renard and Julien Broussard. Please, welcome.
Hello, everybody. First of all, we are already apologize for our English. You know, we are French, but I can assure you we are trying. So, first of all, let us introduce ourselves more precisely. I'm Julien Broussard. Like you say, I'm one of the co-founder of Mars Architects, and this is Raphaël Renard, my partner and my friend. And first of all, we are going to explain what we're trying to achieve on Mars Architect, and how each project is an adventure, and it's always different. And we are going to introduce and present you a project in Paris. And this project is a great adventure because it's in a very complex site. There is so much constraint, and all that constraint on that project become a real opportunity. Opportunity for us to discover new materials, a new way of build. And as you say, as architects, we are in the first lane for changing the world, and we believe in that. So we try to achieve in that project that's first step for us, of course, but also we have discovered that we can do more. So first of all, let's talk about the context. It's the first complexity and constraint for that project. So it is in Paris. So, like you see on the picture, it's most of a stone world. Wood is not so visible on it. And other constraint is the configuration of the site, and one is of the specificity of Paris is the Parisian block. So it's very dense. Paris is one of the megalopole, very most dense in the world, but also the lowest. And we have to work a lot on void created by this principle of urbanism. So as I say, the first of all for this project is constraint. We are on a Parisian typical block made by different kind of architecture, and as you know, as you see on the picture, you have a very huge building front of the street, and it's become the first constraint. You see on the diagram that so it's not working. The site is just behind, so it's in the earth of the Parisian block, as you see on the picture. And that is the situation that we discovered at the beginning of the project. That is the existing site. So first impression was to how to give a more pleasantful and a beautiful place that we found at the beginning. as maybe you don't know, but urban regulation in Paris is lots of constraints, so we try to find the better volumes to answer to a present situation and to create an housing project on the earth of that blocks. And we try to manage, of course, the view and to try to make a building which configuration could be pleasant for the apartment and the housing. So one other big issue of this project was the main access for passing through the first building on the street and to bring all the materials for the construction.
Excuse me, Julien, just one point. We have to add the fact that the construction must be done with the site occupied.
Yeah.
And it's another constraint that add to the complexity of the construction.
Yeah, it's, as you say, Raphael, all the building around the site are occupied, so we couldn't imagine to have a lift, a big lift from the street to pass through the upper building. So we had this constraint of, as you say, it's a red square. This was the only way to bring the materials inside the site. So it's an entrance for parking, and it's an entrance for parking, and the site is 3 meters by 2.3 meters high. So very small issue for bringing the materials. But first of all, like I say, when we conceived a new building, we try to tell us a new story, and we are from Paris, and we try to take all to bring all the project in some kind of contextual question of architecture, and so we look for our memory and Parisian imaginary to bring some new philosophy and to bring a philosophy in that architecture. So when you are on the street in Paris, you have a lot of doors, and you never know what's behind there. And sometimes you discover like a fantastic garden or a place you couldn't imagine from the street. And we try to bring all that, compile all that image, and to make it the basic for the conception of the project. All that picture we show us, it's placed inside Parisian block. Also that one. You think you're in Japan, but it's in Paris in the 16th district. Another point that we believe strongly in the office, that coming home is a really important way of living in a big city. For us, it's a fundamental point in the quality and the positive perception of a house. So that's why we take care very precisely that how we cross, how we arrive to his own door at home, and how will be the different sequences to go from street, from our intimity, our own space. In Japan, there is a Kenkai Nobi that's they call philosophy an aesthetic of the limits. So all that images, all that philosophy had to take a part of the project. Another thing that we learn about Japan is the science of assembly, of how timber will be assembled. As I say, timber was the obvious solution for that project. First of all, about the constraint of access. So we had to conceive the building entirely prefab to pass through the parking, to go up inside the blocks, and after to build a building. So that was our first project in timber. And we learned so much about it. And we tried to also make it very clever with the engineer, all the partners we had on this project. And it takes a lot of sweat for us, but also a lot of love to discover that construction type. So, as I say, all the materials bring from this little door by the construction company. After that, we make a hole on the existing parking, and we have bring all the material by his all using a lift to go inside the site. What was interesting was also all the process of the construction. We use different kind of lift machine for that, different size. The company. The construction company told us that they used all different kind of lift possibly can be used, so it was funny. And before at the conception, we tried to explain that we want to make all the parts prefab, and after different kind of process to achieve the building. And of course, what is also most important for us, that's also the garden in front of that building. So we make different models, and we always try to represent the project with the site and also the landscape we are going to create to be able to have an architecture in perfect symbiosis of new landscape we want to create. This is a view of the model in the other side, because as I say, we want to create different kind of atmosphere and different kind of paths that you will follow to go to your own apartment. So that's a plan of where is the entrance from the street. So you cross over a first hall, and after you discover that new garden you want to create, and discover also the architecture and symbiosis between him. All the, as I say before, all the apartments are crossing. We say traversant. Of course, it's better for the natural ventilation. It's also better for bringing light to every room of the apartment. So that was our first constraint that we input into ourselves to develop that project. That we say to the client, we want that every apartment have natural ventilation and natural light in every room. That's a view of the project just after his completion, and you see the way that we want to create with the garden. It's the garden. The pictures is almost 1 year ago, so the vegetation are growing a lot between them at the time. As I said, the importance of the path, that how do you cross the garden before to go to your privacy. So, as I say, we are fascinated by the beauty of traditional wooden assembly, so that we try to take that kind of details and little thing that it makes architecture so particular, with some good attention. So as you see, we are inspired by the Japanese architecture. So we try to understand why they paint the wood in white to protect the infiltration of the water. And we took that idea to input in all the wood of the columns of the beam.
Most generally, all the details are imagined to protect the wood from elements. So none of the facade is directly aligned to the building. Everything is a little bit. Comment tu dis reculé?
We use balcony.
Back, yeah.
We use balcony to protect the facade from the rain, from the
every part of the design is to protect wood.
Yeah.
Even the white paint of the extremity of beam is a kind of protection for humidity to not infiltrate in the beam.
There is often critics about wood facade. They are not doing so well. They are become gray by the time. So we try to input inside design some basic solution to keep it more longer in the state that we want to keep him. So as you see, we are inspiring about our journey or different country we discover, and it's become also in our own history, and we try to input on new project. Personally, I lived in Japan, and that's in Raphael also visit that country, and that's why it's become also a new input in how we see the architecture and how we can find solution in different countries. So basically, that we say that we can find a kind of symbiosis between architecture and its landscape, and it gives for us a particular ambience. And we think that one way to improve and to give also a very good images for the wood and timber construction is to conceive a project that could be a dialogue between site and also architecture, and he tried to make the link and to give that kind of right condition to express wood architecture. So that's the passage that you go through, and you discover a completely different atmosphere. You go through and you arrive to a very small courtyard. We call the white courtyard. It's different scale, and you have to through that corridor to go to your apartment. That's the way, and that's different sequences that you will cross. From the street, the first hall, discover the garden. After that, you cross the wide corridor. You go to the wide courtyard, and after you arrive and you achieve from your own door. That's the view of the wide courtyard. So, as I say before, we are constructing that project on the existing car park. So, also the wood the wood is the best solution because of the weight. We have to not so reinforce so much the structure. So we have optimized the intervention of the existing structure, and the wood is completely in adequation for that because the weight is so light compared to the concrete building. And the section is also showing that all the work on the design we make for crossing apartment, for ventilation and light, and how we can have the benefit of two atmospheres inside an apartment. And gross floor plan configuration, you know how the apartment work. That's a view of a typical apartment of the project. So you arrive from the ward courtyard and you go in through, and you have the we call that the kitchen and the bathroom, that humidity part, and you cross about something also deal with all the techniques, and after that you are the benefit of your living space and your bedroom, and we try to make it more open and to have the benefit of more light. We try also to have a perception of wood inside the apartment, but it was quite hard because the French regulation is not so easy to manage with some acoustic performance or fire regulation. So we try to put it at the right place. We could have the CLT appearance on the duplex apartment because it's the same, so we don't have the same constraint about acoustics and fire. So as you see, the project is based on frame, and that frame is the dimension of the frame is based on the way we could bring the materials from the car door park. So we try to find the right measure to give the project the more elegant way of it. That's a front view from the garden. And what also was fundamental and was really interesting for us, that building is using a different kind of timber construction solution. We have CLT for the floor. We have timber frame wall for the facade. And we use also massive wood for the columns and for the little beam for the balcony. So we have learned to make the assemble between different techniques. It was a great challenge for us to understand what we can use as building solution for timber construction at the right time and the right place, and in that way that was very interesting for us. Of course, we have using also biosourcing insulation because we try to achieve a very high demand of labels of certification. That's a view of construction. Like as I say, you see the different parts. You have the CLT balcony. You have the mass wood for the column and the beam, and after that you have the wall frame timber for the facade. And for the envelope, we have work on massive wood for the facade, and we've tried to work on it like carpenter. We try to have a very precious piece to frame the facade of the building, and that to us give us the image of quality and also of the good perception of the building. So it's a very, very small project because it's only 700 square meters, and we use 170 cubic meters by volume. That's the volume of wood, and we calculate also the footprint carbon, and it was very very low, and that's also the different certification labels we obtain. We are a level 3 bio-based building. It's a French regulation, and we have also a very good energetic and thermic performance for that building. So right now we are going to show you some little films, and it resume all while I try to explain to you, but maybe it will be more understandable with the film. So the first film is all the construction process, and the second one is more immersive. Is a film that we made just at the end of the construction process.
Le projet se situe 25 avenue de Saint-Mandé, juste à côté de Place de la Nation. C'est un projet de logement dans un site occupé par un grand immeuble en R+11.
Le site est très encaissé et donc le projet découle du possible, de ce qui nous est donné en termes de règles urbaines, tout ce qu'on est capable de faire dans un îlot parisien.
Quand on passe cette première épaisseur, on découvre en fait des univers toujours particuliers. Notre projet, il s'inscrit un peu dans cette dynamique-là et tente de proposer des lieux cachés, des lieux secrets. Le premier, c'est ce qu'on a défini comme étant un sous-bois, donc un paysage plutôt arboré, boisé, végétalisé, avec aussi une strate de végétation basse, avec un cheminement comme ça qui serpente. Et un deuxième paysage qu'on retrouvera ensuite en arrière-cour, qu'on a défini comme étant une cour blanche et qui propose de travailler sur la lumière, sur l'optimisation de cet apport de lumière en travaillant sur le blanc.
On a construit tout le bâtiment en bois. La première raison, c'était une raison environnementale, constructive, puisque en fait, on a tout passé par les sous-sols du parking. Donc tout passait dans un trou qui faisait de 3 mètres par 2,30 mètres de haut. Donc tout est passé par le bas pour être remonté derrière, parce qu'il fallait passer le grand immeuble.
La qualité du logement, elle vient de la séquence d'entrée, mais elle vient aussi de son plan, évidemment. On essaie toujours de faire des appartements traversants. On pense qu'il y a une qualité évidente à faire des appartements traversants pour la ventilation, pour le soleil, toutes les pièces sont éclairées, une optimisation des circulations. Enfin, il y a énormément de bienfaits avec ces plans-là.
Tous les logements ont des balcons, voire des terrasses dans les niveaux supérieurs. Et puis, c'était aussi la question de la protection. On ne pouvait pas faire une façade en bois si on ne la protégeait pas. C'est-à-dire que tout est protégé par des débordements qui désamorcent toute la massivité qu'on pourrait avoir sur une façade lisse ou ce genre de choses.
Les maîtres mots, c'était vraiment cette histoire de Paris caché, de sérénité quand on rentre, jusqu'à sa porte d'entrée finalement. Et on découvre une succession de séquences qui nous mettent dans un état d'esprit totalement différent de quand on est rentré. En fait.
C'est dans cette épaisseur-là qu'on n'a pas l'habitude de traiter, qu'on trouve une forme de sas entre le monde de l'intime et le monde extérieur.
Thank you, Julien and Raphael. I noticed on this project one thing, and it's about the context. Usually when we think that something is contextual, then it goes with the flow. Your building was very contextual in the sense that it added something what was missing in the courtyard. The courtyard was, or let's say the houses around the courtyard were all made from stone or concrete, so it was quite a stony wall around. And so you completed it with different color and different material. I wanted also to ask, that's just a note, I wanted to ask, are the apartments all sold for today in this building?
Yeah, in fact.
Such a sad story. I have thought many times about these things. When you do a good architectural project, you should tell to the real estate developer, that's my advice, that at least one apartment should be like rental, like Airbnb, so that the architectural lovers from all over the world could find a slot time and to enjoy it also. Because when you live in beautiful building for a long time, like these lucky guys who bought the apartments, they get used to it. But let's say for all other architects and wood architecture lovers, it would be nice maybe to experience that thing. Do we have questions from the audience? Do we have? Yeah? Lembit, is it you?
Yes, it's me. So, yeah, he says it all there. That's a very interesting idea, this Airbnb. But I was also wondering about the inhabitants of this particular dwelling. It's so special. It's such a piece of magic, you know, an oasis. Have you had any experience with the people who live there now? Are they all walking around like monks?
Yeah.
You know, like what is it doing to them?
Yeah, in fact, we are making so much visit of the project, so we have the occasion to discuss with the people who live there now, and I think they understood exactly what we try to achieve in that project, and they live it very quietly. And also the people who live there before in the building, the big building on the street, are very happy to have a new garden and to have also a piece of architecture completely in dialogue with the garden. So the experience that we feel and we receive from the people who live there are very positive in a very good way. There is people that are doing now work from home, and they love to stay at home here and to work every day. So we are very happy to see that building living well and living with the philosophy that we try to input on it. And just to tell that it's not for Airbnb, it's rent for a long time. And when they put on internet the apartment, they are all rent in 24 hours. So they see the pictures, and for now the apartment are occupied. So it's a success for the client, and he's really happy to have made this in wood.
Very cool.
One more question, if I may.
Yeah.
I kind of follow some French sort of like fantasy comic strips, you know, and Tintin, you know, Hergé.
Really? But you do.
And there's also, pardon me?
You do.
Yeah, well, I have a T-shirt, 3 of them, and I feel that this is a similar kind of imagination. There's the Orient, there's the Asia. It's kind of this fantastical thing. But my last question is just: has any filmmaker approached you to use your building for a film set?
Not yet, but
well,
maybe.
Okay. Anyhow, thanks a lot.
I wanted to ask you about also the fire safety issues. Did you have also specific cases which are, let's say, which were quite stressing for you, or was everything quite fluent and easy? I think you experimented on this building also.
Yeah, we also experimented. The chance that we had, it's not a really huge building. And also when we conceived that project, the fire regulation in Paris were more friendly. Between 2 years, they have changed their opinion of wood construction, and now it's become more hard to have visible wood on facade. So they are agree about timber construction in Paris, but we have to bring to them all the assurance that it will not be an issue for fire security. So at this time in Paris, we try to find solution to contain the fire security department. It's not easy because they changed their mind very recently, and also the politics and the city wants to have wood for, of course, for environmental question and issue, and they ask to architect to conceive the building in wood, most part of wood, to inside new regulation of carbon footprint. So for us, it's quite really hard to manage with the fire question and of course the environmental question of politics. And we try to every day to find a new solution and to discuss with all that authority to find the right solution.
Did you make also in the process of building or during your project also a lot of prototypes? Like Charlene told in previous presentation, they made constantly different like edges and types for strength and for fire safety. It's very interesting practice. I will have a comment after your answer.
Yeah, in fact, we would like, we love to make tests, but we have to explain to the client that he have to pay for them.
Yeah.
And so it's not so easy to make it acceptable for them. So for that project, we have tests for the facade. We have made a test for the wall and the assembly on the site. But of course, I think, particularly in timber construction, I think prototype is
part of the process.
Yeah, part of the process. So it's kind of a new way of explain to the client, or also to the partner. We are conceive that building that maybe we are going to take more time for conception, but less time for construction, and at the end, everybody will win. So
Absolutely. In Estonia, it's also so that when architect makes the drawings, then at the end, usually you don't have any money for the prototyping. And when you ask from the client, can we do some extra prototypes, it will cost you. Then they ask, okay, that's your school money, what you should pay. They say to architects, because they think that if you need a prototype, what is the problem? Don't you know how to do the drawing, or what is the issue? And then the architect thinks, okay, maybe the builder can solve it or not solve it. But I think in the wood constructions and wood buildings, it would be the normal process that you do the project, and on the allocated places, what you might not know from the beginning, you do the needed prototypes, and you are free to do, and the knowledge and testing just improves the project and gives you the certainty that how it works, and also the classified quality for the details for the builder. Because usually the building companies are chosen for the lowest price of something. And when you need a high quality, it's very hard to say where the quality and the price have a good cooperation point. Thank you. Thanks a lot.
Thanks a lot. Thank you.
So now we have a coffee break until 3 o'clock. Praegu kella 3-ni on kohvipaus, pärast seda koguneme uuesti siin. Ja peale järgmist sessiooni on oodata siis puitarhitektuuri auhinnagalat.
After the next session, we will also have the wood architecture award ceremony.
kompetents ja sujuv koostöö. See on Mark Wood.
Welcome back from coffee break. I hope you are well refreshed for our next speaker, who is coming from a neighboring country of Sweden, from a rather large office that does incredibly diverse projects and a variety of quite challenging briefs are on their tables. So the next speaker is actually the head of their competitions unit. And he's an architect, award-winning, internationally well-known. So please join me welcoming Robert Schmitz from White Architecture on the stage.
press it a little bit too fast. Let's see what we can do like this. Okay, thank you for having me at this conference, and thank you for this kind introduction. And I met Eric and Henrik this spring, guiding them to this project that I'm going to show you. And they already decided then that I was supposed to be participating in this conversation or this conference. So I'm very happy to be here. This building is not just one of the world's biggest or largest timber developments. This is also the strategy for Skellefteå municipality to become a more attractive region and grow from 70,000 up to 100,000 inhabitants over the next 10 years. And I'm an architect and partner at White Arkitekter. We're a Sweden-based office with about 700 people working there. We're scattered around Sweden in 14 different offices. We also have offices in Stuttgart, in London, and in Oslo. And we're working with projects all over Europe. And we have also projects in Canada and in Eastern Africa. We are a collective with one vision, and that is to have all our projects to be climate neutral by 2030 through design excellence. And so we have a roadmap for us to guiding our clients how to achieve this. And we're following the Paris Agreement also. The question or our addressing challenge is that more than 20% of the carbon emissions in Sweden are from the building and real estate sector. And if you consider it or take into account for all the emissions from material produced abroad, it's almost 40%. So we need to, as architects, advocate for different solutions to lower our climate impact. And that's something that we at White really take seriously. But it's also a very interesting time to be an architect these days, because we are now part of the solutions. You can also see that 30% of all the waste in Sweden comes from the building sector as well, almost 9 billion tons a year. And that's something also we need to address and start to think, change our mindset when working with the existing environment in order to create livable cities. How can we reuse or upgrade the already existing buildings in that context? And to do so, we believe in working in an interdisciplinary manner throughout the entire design process in order to find a holistic approach to a sustainable solution. And also to integrate that to the architecture from the very beginning. So we have a lot of different fields in our practice in-house that we set up in all our new projects that we are doing. Within this, we believe in process and collaboration. So we have a lot of workshops together with the client and the end users, but also in-house with all our different fields to get a better understanding what the question is and how we can solve it. We also work with White Research Lab, being a company that's owned by ourselves. It's an employee-owned company. It allows us to reinvest our profit back into practice-based research. And we do so to focus in our transition towards a more sustainable construction. And we have 3 focus areas where we use this. That is in digitalization, transformation, and in timber. And I will talk a little bit about the timber and the timber part and what drove us to suggest a building totally made of timber in the northern parts of Sweden, in Skellefteå. Sarah Culture Center, which I'm going to talk about. It's a culture center and a hotel located in the very center or very heart of Skellefteå. It has already won lots of different awards around the world, and it has really proven the brave initiatives by the municipality that you have to invest in the future and in order to become more attractive. But they're also doing it in a sustainable material. This has become more of just a culture center and a hotel. It's also become a showcase for how to use timber in practically any type of building, using these kinds of solutions. For us, this started as an international competition in 2015. With a quite complex brief from the client. It's a culture center for 17,000 square meters and a hotel for 11,000 square meters. And what we can say more about this is in Sweden, the drivers for construction, for climate neutral construction has been both the timber industry, but also the municipalities and the public sector. And they have a cluster or an organization that we call Timber Cities. It's basically, and they have put together this strategies how to develop a more sustainable construction through business, academia, and municipality working together and in collaboration to see the best use of timber. And Skellefteå, just to guide you how far up north this is the same latitude as Dawson City in Yukon. And when I speak in the America about this project, everyone, the audience will say, "Oh wow, how far up it is!" But I guess it's not that far from you guys. So it's 800 kilometers north from Sweden, just below the Arctic Circle. And Skellefteå, having a rich timber tradition and a heritage. This is something that we saw as an objective to advocate timber and to bring timber back into the city of Skellefteå. And this is a material that most of the people or the community can relate to. Most of the people in Skellefteå also own a part of the forest surrounding it. So we saw that this is a good opportunity for us to really drive this quest. The location was the last unbuilt plot in the central part of Skellefteå. It was used as a bus station and a parking place. It's located just beneath the main square and what is to become the new train station. So basically, this was the most central plot in the entire town. Before this was open, before the open competition, this place was kind of scattered, and this large empty plot divided the city into different parts. So by placing the culture center here, it unified it and the city and mended the city grid, and creating new paths and new movements and also destination. So it was not just a culture center that we had to build, we also had to build a city generator, basically. So our solution to this problem or challenge was to utilize the big stages that this contains and place them right in the center of the block, creating space around it that was speaking to the surrounding street, allowing for entrances in all the different directions so that we didn't create any backsides. We wanted all the different operations to be able to visibly at least look out to the street, but also for people to actually look in and see what was going on inside, to be able to participate in this culture workshop, basically. And we call this project Side by Side, placing all the stage side by sides, and filling up this entire city block, and placing the high-rise in the center of it with a short side facing the main square, working with a slender structure, but also here not to create any backsides. This becomes a new landmark for Skellefteå. It's twice as tall as the second tallest high-rise in this building, but this is the beginning of a transformation of the entire skyline of Skellefteå. And creating this building in timber is actually something that all the people of Skellefteå really looked forward to and embraced. So there hasn't been any complaints, basically, about building a big building like this, so central in this rather small city, I would say. The main entrance from the culture center is placed so that you walk underneath the high-rise into a void, so that you can really understand and feel the pressure and the volumes, and working with experience in this building. The program of it houses a regional theater, a youth theater group, Museum Anna Nordlander, art gallery, city library, 6 stages for performing arts, theater workshops, and joint office spaces. So it's a huge working place as well, and we wanted to manifest that, and not just the nice part of this building, but the entire building is supposed to have this energy of creative space. So we used large spans rooms so that they can transform depending on what the production or what was going on inside the building. And we also wanted everything to have a low threshold, or seamlessly you could walk around this building without feeling that it belonged to a certain operation. It belonged to everyone. You should be here in your own conditions, not just be here because you paid to see you play. So we try to create a new public space for the inhabitants, especially when you have a private hotel as part of this. The ground level, this is a split level, so it's 2 stories of culture center. The ground level with the main entrance towards the main square. Here we put the library and the hotel lobby with cafe. So, and in between those, we have the entrance with all the lifts to the hotel, so that we mixed all the different people or spectators going into this place. So this become a melting piece of or a new meeting place indoor in this subarctic climate. And this is what you come into when you enter the main square, main entrances. And you can see the adjointed pillars on each side, taking down all the forces from the high rises, all in sealed glulam timber. So here we created an oversized social staircase, being used as the 7th stage. But it's more of a public one where you don't have to pay. It's a speaker's corners. It's used as a, as you can see, as the high school people having a concert for spontaneously at lunchtime, for example. So, but from here you can reach all the different functions within the building, and also look into the people that is going to the hotel, so that this become a natural meeting place. We have worked with visible timber throughout the entire project, and all the way down to railings and stairs and pillars. But we're trying to use this as this methodic that we worked with material optimization, and we've been working with the characteristics of CLT mostly, with these elements that we have assembled together to create this atmosphere throughout the entire building, all the way down to actually using the handrails with the CNC force, for example. Going up one stair, we have the theater level. Here we have all the stages, and they're surrounded by a huge foyer going all the way around, basically, which can be used by the different operations within the building, depending on what their production is. So, for example, stage 1 or stage 2 can be used side by side independently, or even better, together. So we've been working with co-spaces, basically, so that the exhibition space can broaden up and become the foyer can be part of the exhibition space as well. But also can be used in many other different ways. This is the youth dance group having a rehearsal, perhaps, in this foyer space. But mostly in the morning, they have big yoga classes here with 100 people having yoga each morning. So it's really been taken under consideration from all the people in the community and empower the community for this. The main attraction, though, in the building and the heart is our grand auditorium. It has about 100 seats, and it's made entirely also from timber, as everything else. And here we really wanted to see how far we can get with just using the material as a component, or different components that have been set together to create an intimacy scale and something not only for the audience, but also for the people staying on stage, looking out. So it was equally important to bring something to the people going there to see the play, or for the people working on stage, for example. So we have been working with the material or timber all the way down to the acoustic panels, which we have optimized for the best acoustic in this room. And we also have a number of black boxes, not that easy to take a photo of, but you can understand because of the name of it, which ranges from 350 down to 80 people or seats throughout the building. We have gallery spaces. Here we have, they have to fulfill the requirements of humidity and safety, of course. So here we couldn't have exposed timber, but we still left a little bit of timber feeling in the ceiling. Here you can see the glulam pillars holding the roof. So throughout this entire project or building, we wanted people to experience, but also to participate in the cultural events and to find their own ways how to use this building. So I'm going to show you a little bit video, I hope, of how they found their new ways to utilize this building. Yeah, so the tower also become part of the culture center in this sense, having the 8th stage using the double skin facade as a dance stage. The Wood Hotel, which lies in the high rise, and here is a quite large scale model of the projects. It was exhibited in London Summer Fair this year. It contains of 205 hotel rooms. They have 3 restaurants, a conference center, a gym, and a rooftop spa. And it's also connected to the main grand auditorium, as you can see in this model. The plan layout is basically two elevator cores in each end of the plan. In between, it consists of 18 hotel modules, pre-manufactured and just assembled on site, stacked on top of each other for 13 stories. so the cores stabilizing them. And and this allows for showing all the CLT, the bearing CLT boards in both the ceiling and the walls, and it allows for this spectacular view overlooking Skellefteå. But this was a foggy night or foggy day, so you couldn't see much. But either way, we wanted to, building a high-rise like this, we wanted to give something back to the people or to the community with a public space and active top floors. So here we put a rooftop restaurant, but you can also come up here and enjoy the view without have to go into the actual restaurant. And this really creates a new site over Skellefteå and allows for the people to have a new perspective in this manner. And on top of everything, we have a spa, a wellness spa with a lap pool on top, where you can lay here and overlook the river of Skellefteå. And with all these different functions in the building, this has actually created a library of solution, how all the detailing and joints working with timber that we can use in many other different projects, not just culture center. It's most of the detailing we've been working in this is quite conventional ones, but not just they haven't done it in this scale before. But not everything is timber. We have a concrete foundation. But above from that, all the vertical load is from timber. Either it's glulam pillars and beam, or CLT boards for stabilizing walls or floor slabs. On top of the building, we needed a little bit extra weight to prevent from seasickness, and the acceleration for swayness in the tower. So the top two floors are made of. They have prefab concrete slabs on top of them, but they're not there for the statics. They're there for weight only. And the tower consists of these pre-manufactured CLT modules made in a factory just 50 kilometers outside of Skellefteå. The CLT is 9,500 cubic meters, used in these elements. The glulam is 2,200 cubic meters, but we also have a lot of steel in this building also to join all the parts together. It's about 500,000 screws just in the hotel towers, shafts or lift towers. So there was also a big part of this building as well. A timber building in this scale also at this moment needs a lot of steel to put it together. Throughout the project, we have been working with BIM all the way from the beginning. And it has been really the key for success in our case, working together with the client. And we have made lots of different ways. Coordination has been a really strong argument using this method. And since the 99% of the project is pre-manufactured, this has been a really good way of testing all the errors in the 3D model instead of on site. So we have reduced it down to, we didn't have almost any errors working on site in this project. But also as a dialogue together with the municipality, where the politicians also was really engaged in this project, so that we used the VR so that they can walk around and see how their new building was going to look like, and they also had a few input into this process as well, which has been really learnful from us as well. The construction, here you can see the modules being pushed together. We have been working. So this was a competition that we won, and then we were general consultants, white, up to tender drawings. And after that, it was a collaborational contract between the municipality, the developer, and a contractor. with us as a part of the team. We changed from the municipality to the contractor instead. So there we had that we worked with joint forces. We worked with open books and a fixed risk price. So because we did this, everyone also understood that we were on one team with one vision, that we're going to realize this project in timber. And we couldn't have done that without trusting each other. And I think that's the key to have a new mindset of thinking when building, that you don't have to hide stuff from each other. You should show it and learn from each other, especially in these pilot projects like this, that this is a real-life research project, basically, and we really, and everyone learned from it in this case. So the supplier was Martinsson. They've been bought up by Holmen. It's a CLT factory. It's also 50 kilometers outside of Skellefteå. Here we could build really large-scale element, so that we could use fewer connectors and have working with under safe conditions with all the working requirements that was needed. The largest element that was produced here was 27 times 3 meters, and it was erected standing, and it's one of the walls for the Grand Auditorium. On site, we had a 73-week montage of the timber, and doing the basement in concrete took about the same time. So it went really fast when we started with the timber production. We saved about a year of construction time working in this method, and reduced 80% of the transportations by both having the local source timber, but also as timber is 5 times lighter than concrete, we could spare a lot of trucks communicating them. The 3D hotel modules were created in another factory on the opposite side of the city. And here you can see the first module being created. It worked both as a show for the hotel operator, so that we could choose how wide we wanted the walls to be, or what kind of flooring we was going to use. But also, and this is also used. This was a mock-up that's also been used in the actual building later. It consists of CLT slabs on floor, ceiling, and walls, and on each corner it's glue lamp pillars, which you just stack, and you connect them to each other on top of each other with these steel connectors or steel blades in order to create a really stiff construction. And then it was just assembled on site. Of course, in Sweden we have the same challenges with fire regulations as the rest of the world, but we have a little different take of how to interpret it. We see that we don't have any material in our regulation. We think of it as not as a building. We only think of it as how safe the people that are in the buildings, how they can get out in a certain times without getting hurt. But the hotel tower is rated R90, and the culture center is R60. And then we have a lot of other ways to fulfill all the requirements in this building. But as for many other projects, we didn't need to do any testing our own, because we could rely on previous tests that has been done. And that was something that really made our process much more easier. But we worked closely together with the University of Luleå, for example, and RISE, the research program in Sweden. We also have concerned energy performance in this building. That we've been working with high performance envelopes. We have no thermal bridges with this, which is quite convenient working with timber instead of steel facades, for example. We have fixed and mobile sun protection, depending on which direction the facade is about. We're also working with the hybrid ventilations in the culture center. And the building is certified gold, which is the higher level for Sweden Green Building Council's Miljöbyggnad sustainable certification. We're also using a smart energy system. The entire building is run by 100% renewable energy. We're working with a heat pump, which is connected to the city grid through an AI computer, which will learn how to function the building so that we are reducing all the peaks of energy use. Because it's when the peaks goes in, then you have to use coal, for example, to gain energy. We also have batteries as a backup for sprinkler pump, for example. And all the timber comes from a radius of 60 kilometers around the sawmill. So this is basically a local sourced building, and we also did a calculation, and it takes about an hour for the Swedish forest to grow this building. So we can produce one culture center in an hour in Sweden. And about the environmental impact, we were not when we won the competition, we weren't driving to have a new environmental balanced building, but we had after we have done the building, we did an LCA, a carbon assessment, to see how low the emissions would be. And if you take the carbon sequestrations under consideration, you can see that it binds much more carbon that we actually produce or we emit, or our emissions in the building. So timber is a really environmental material to use. And here you could see also the material impact using this LCA, where you can see that the concrete stands for almost 42% of the entire impact, whereas timber is 16%. We have lots more timber in this building than we have concrete. So, but we also have to see that there is a lot of material working together, and we need to look all of them through in order to reduce our sustainable impact. So this building binds about 9,000 tons of carbon dioxide equivalents over the next 50 years, which is quite a lot. Yeah, this has been becoming a landmark, not just for the Skellefteå people or the community, but also around the world, guiding others in our collective thinking of and transition towards a more sustainable and livable world that we have. With that, I would like to thank you for your attention.
Thank you so much, Robert, for such an insightful presentation. Do we have questions from the audience? Yes, please.
Hi. So that was very impressive. I mean, to keep all of that in mind and so many things. First thing that ran through my mind was, you know, Sweden is kind of a Shangri-La now for architects like you, presumably, because this is a landmark project altogether. But my question is about the practice itself. You said that there are 700 employees. Was that true?
No, it works about 100 people there. My practice, sorry.
Yes.
Yeah, we're about 700, yeah.
Okay. So, and of course, you need an awful lot of people to get this sort of thing coordinated. Just to get the words out of your mouth took a lot of effort. I think there's a lot of work behind that too. So my question is, obviously, I would expect that this is your firm's kind of culmination of everything you've learned so far in wood. And did you say correctly in the beginning that the White Architects' goal is in fact to have the let's say the sustainable building as a kind of like a guiding light? Like that's where it all started from.
Yes.
And has every project had that? And now this is kind of using all of that experience. Is that what?
Yeah, I would say so. We work with practice-based research, and that is partly of understanding our previous project and knowledge sharing throughout the practice, because we're a lot of people and lots of partners, but we have this collective mind and triggering ourselves into doing even better the next time. So yes, this is one that I would say it's correct, but it's also something that we want to use that research to push ourselves, and we do that in competitions, for example, to really see how far we can go with timber or in other materials that we're using.
Last small question. So would you say that where you have ended up at now is being like a direct line there, or were you in the beginning of the practice, did you have like other focuses, but now gradually it has simply proven to be that this focus is the right one?
No, this is one of many focuses
we're
addressing. Everything from social sustainability to environmental sustainability. But we also have to have cost control working with buildings, because otherwise they won't be built. And this project, Serra Culture Center, we were also in a budget. And this project didn't cost more than it would have if we have made it in concrete, for example. So that's also something that you need to bear in mind when you're working with complex projects. So we have to have viable solutions so that we can compete with the traditional materials. We have to convince our clients that through really good architecture with timber, so that they can gain qualities as they could have, because everyone is scared of new things, and especially builders, they don't want to take any risks, for example, doing stuff that they have never done before. So I think it's a sum of all that knowledge, and be able to carry that through the entire design process together with the client, of course. And I think that's a strength coming from this big office, that we could rely on, that we have done not projects like this before, but we have at least experience with the criteria.
Anyhow, it's magnificent. Thank you very much.
Yeah, thank you again, Robert.
Yeah, thank you.
Yeah, I had a question. Why you cover like the part of a hotel with glass? It's protect like the wood.
Yeah, we're using I didn't have enough time to speak about the actual facades, but the facade is a double skin facade, and we don't use any insulation in the rest. So what you see behind the glass is the constructional CLT. So we saved a lot of facade just putting a glass screen to protect it from wind and weather.
Are you using like with ventilation also sometimes? We open like some part.
Yeah, and it's not controlled, but we're using it to in the summer take away heat, and in the winter to buffer heat, so that we even out the control. So yes, it works both ways. The double skin facade, and it's a combustible material, so we had to really look into that. We didn't get the chimney effect. So each floor is one fire cell, basically.
Thank you.
Yeah, thank you for this explanation. An important note taken. So thank you, Robert.
Thank you.
And our Our next speaker comes much, much further than Sweden. He is here from Canada. He's a principal partner and co-founder of Smith Vision Architects, and leading a truly amazing company that is integrating all these bioclimatic and passive design approaches into the very different projects that are handled by the firm. But also, besides leading a highly dedicated and creative architectural design team, our next speaker has also been actively involved in the architectural community. Daniel Smith, I'm honored to invite you on stage, as you have been also formerly president of the Quebec chapter and Leaders Forum chair of the Canada Green Building Council. And you have been, of course, been invited to many international conferences, and we really have the honor of having you here from such long distance. So please, the stage is yours. Please welcome Daniel.
Thank you for the introduction, and thank you for the organizing committee, Henrik and Eric, to invite me to this beautiful event. Actually, I'm impressed, and I hope this will follow up to certain friendships also with certain colleagues that I met. Next. Okay. So we'll start with who we are. We're a small firm, 40 more or less architects and designers the table of content, we'll be talking about that. Our approach, our design approach also is very important, so we can maintain high quality projects. Where? So we'll show you a little map of Canada. Why wood? Well, I don't need to convince you, but we'll show you some reasons why we believe wood is the material of the future. We'll show you some selected projects, and we have 5 case studies. So it'll be like a candy-like presentation. We won't go into great detail, but we will show you 5 different type of projects that we're working on and that we realized. So it's our 30th year today. Almost today, but we'll be celebrating it our 30th, the 17th of November. So if you want to come to Montreal, you're invited. We're 40 staff of creative personnel from all over the world, actually. We believe in teamwork. We work in the public and in the private sector. Right now, we're unbalanced. We like to keep 50-50. We're working on a lot more public projects right now, schools, hospitals. We specialize in low-carbon wooden buildings, so that's why we had a chance to work in China. So they came to us for certain projects that are ongoing. We believe in high-efficiency buildings. Even though Canada or in Quebec, we benefit from low energy costs, which doesn't help us when we want to innovate, because we need to have higher costs so we can bring in more high-specialized integrated systems into our buildings. So this is a continuous battle for us. And obviously, we live, like most of our time, inside buildings, so we believe that most of the buildings should be safe for living continuously in the buildings. Our 3 main pillars of our firm, it's sustainability. So ever since we were always preoccupied with how not to demolish buildings. So this was our first, how we started our practice. So we believe in conservation. And when we have to build, well, we try to use the best materials at the right place, you know. We believe in collaboration. We introduce the integrated design process into most of our projects, even though it's not part of our mission from our clients. So we believe that it's important that we instigate it into our way of working. And also we believe in innovation. So we're all working on BIM platforms, and it makes our job a lot easier to work and to coordinate our work with the engineers. In Canada, we do all servicing, so we do the design to the construction details, and we do site supervision, so that's part of our responsibility as architects in Canada. So it's full-fledged services. So, yes, Canada. So it's an abundance of wood, as you know. It's the second largest country in the world. And we've changed over time, because I remember when I was born, you know, most of the paper, a lot of the paper was for, yes, building, but also for the New York Times and for toilet paper. So now we've evolved from that. Thank God for online news, and so we don't have to waste that beautiful resource on paper, and also thank God for recycling too. We have a vast variety of wood, and obviously, you know, from coast to coast, it's you know, it's 5,500 kilometers, which is it's a big country. Sometimes I say it's a little too big for us. But anyway, so on the western side, you have the big firs, Douglas firs, hemlocks, the tall cedar trees, pine, obviously. In the middle, you have the poplar. And then eastward, this is where I live. Well, does it work? No. So I live more in the eastern side, where we have maple, birch, spruce, and firs. So they're smaller dimensional wood, but this is where we mostly we design our wood, our buildings with those woods, because we want to encourage locally fabricated materials. This is a very sensitive issue, and I was talking to some colleagues here. How do we harvest wood? So obviously, at our firm, I don't want to get into political discussions here, but we try to choose the right materials at the right place, and the volume of wood, for instance. So sometimes we will go with light frame structure, which will save a lot more of the wood volume of buildings. And when needed, we'll go to heavy timber design. So we do this analysis quite in detail. So sometimes it's for cost saving as well. So I think what we have to do, and I think we all agree, we have to be careful how we harvest and this beautiful resource. So why wood? So I think we all understand, and there was great projects here that demonstrated the good reasoning of using wood. So obviously there's a low carbon for structural reasons, the material property, well-being. But there's one thing I want to talk about is construction speed. And this is one argument that we're using a lot more to convince our clients and builders to go towards wood. The Paris project, it's a great example how clean that site was, most likely was, compared to a concrete or a steel erected building. So I think it's an argument that we're bringing up more when we want to promote a wood building. And obviously aesthetics. Who doesn't like wood? So these are some projects that we've done. We do residential. There's one college that we hope that will get out of the waiting list so we can build. A Shanghai tower. We've been invited to do a study for 18-story project in Shanghai, made out of wood. Very difficult because they have a building code very similar to the Canadian one, which is very, very strict. Patrick, I want to have him on my team when I go negotiate on a high-rise tower. We do passive house projects. College Notre Dame is our first public wood-cladded building. We had to go and battle to the city so we can use wood instead of masonry, which was the regulatory material for facades. And we work up in the north, not near, just below the Arctic Circle. So usually we do prefabricated systems. And 3 days before this, when I took this picture, it was all crisp and white, just pure frozen snow on this building. So here you see how it's important that our detailing and our design respects the very difficult conditions that we have. And I think like here in Estonia, we have similar weather conditions. This is a tower that we're working on in Montreal. It's at the beginning stage. So it's near the old port. So this area is destined to be redeveloped soon. We hope that it will be a very high environmentally the whole site vision. But it's in a very early stage. The reason why I want to show you, I'll show you later on. It's just near south of the downtown area. It's not a big building in its surface, but the client is hoping to bring to make it a landmark and a net zero building, and you'll see why. This is the sculpting of the building with regards to the sun orientation, which is part of our concept, and but also the client wants to maximize the building surface. So these are very preliminary views. We have a corner garden that we want to introduce for filtering the air. This is another battle that we have to work with our engineers. This is a preliminary view. But this is the slide I wanted to show you. It's an example of how we work in a holistic way, and we introduce not only wood in our buildings, but how we design the building as an ecosystem. So we're very lucky to be close to a water basin, so we want to use hydrothermal to be able to heat and cool the building. Obviously, natural ventilation, so we'll be going to war with our with the security and building code implementers, and for the natural ventilation. And there's all kinds of systems that we want to introduce and integrate within the building structure. So obviously, radiant heating, solar control, wood structure, and natural ventilation. And we'll see how far we can go with the the wood aesthetics that will be at view inside. This is a project, a national park project that we had to work in BIM. It wouldn't have been possible if not, because there's no element that is identical. Every truss, every wall part are totally different. So it's a sculptural building in a national park. It won several awards. Here, this is the land setting. So the program was to have one building, so it's a discovery center and also equipment facility. So it was supposed to be part of one element, and we decided to separate them because one, the equipment and rental facility is not heated, so there was no reason to have them all attached together. So we used this scheme to structure this area. There was no tree cutting, so we had to be very sensitive to its integration. There's a lot of willow trees on this in this park, so that's part of our concept. It was to make the volume, and I'll show you later on another screen. But this dividing program into two helped us to create an opening, a doorway to the waterways in the national park. And you can see also the advantage of creating a little space between each buildings so people can just relax. Sometimes in the wintertime there are high winds, so it creates a little zone that is protected from certain wind conditions. So this is an exploded view here. So we have the ribbon, and the ribbon and the canopy, which we were inspired by the willow tree. So these massive body of falling leaves and branches, which is part of our concept. And obviously you have the ground floor. There's a lot of transparency. We had good discussions with our engineers. Believe it or not, and I'm sorry to say, this is our first triple pane glass window project in Canada. Why? It's because the cost of energy is so low, and it was very difficult to be able to justify having these type of costs. It's ridiculous, but that's our reality. But the reason why we went with triple glaze here, because we wanted no heating system apparent. So we have, it's a very highly efficient envelope that we propose, and then most of the wood, it's the interior we use pine, and for the exterior, eastern cedar. This is a study that we do for all of our projects here. So there's no air conditioning in this building. We use solely natural ventilation. It's a smaller building. We control heat gains in the summertime, and for the wintertime, well, the sun can come in for around and heat around 75% of the space alone. We wanted to have vast openings as well, so it's the best to have just a shelter and have no windows and no walls. But so we wanted to have a vast amount of glazing so we can have this connection to the park. Like I said, BIM was necessary. There is not one truss that is identical. It's a hybrid with glulam, columns, and beams. And we use light frame wood structure for the walls, and obviously for the roof structure. Some pictures of the construction site. So obviously, there's a few areas where our engineers, well, like I mentioned yesterday, we like to make them sweat a little. And so we wanted to eliminate all columns at the exterior. So we have up to 8-meter cantilevering, and that's some discussions that we've had with our structural engineer. Obviously, there were some impacts with the sizes of the beams, but that was just integrated within the whole canopy volume, so there was no issue there. So these are a few pictures that I'll be showing here. It's a very sculptural building. Also, we created an alleyway for the evacuation of the heat for the natural ventilation. So you can see the interior. And so it's for natural light and natural ventilation. So we carved this place so we can have a more organic feel to the space and its integration into the park. Oh, sorry. And this is La Marquise, so the entrance. So that's, we have a 8-meter cantilevering. So because at first the engineer said to us, oh, there's a column missing at the end. And we said, there's no column on our drawings, so you're going to have to calculate here. And actually, he had fun to be able to work with us and understanding. So we were sharing the 3D model, because that's the only way we can work together and come up with these type of projects that are highly aesthetic, I guess. And there's another cantilever that's around 7.5 meters there. Another project here for a national park. This is Mont Tremblant National Park, so that's where we go skiing downhill. It's one of the first buildings where our La CEPAC, which is our client, they're the ones that organize that the national parks discovery throughout Quebec, and they wanted to review or renew what is the Discovery Center looks like. Usually, it was like a little, ordinary building with no windows, and then with exhibitions that are, that were old, where you have old bears and that are all fluffy and all, full of dust and all that. So here it's a new vision for the parks where they open up, and obviously they have more high-tech visualization to explain what the parks is all about. So it's a different way of discovering, and everything is online as well. So this is the same thing. We had a program where there was an amphitheater integrated with the discovery area, and so we decided to split them up and create another space where we can create sheltering. So you have the cantilevering roofs coming up to control solar heat gains in the summertime, but also it becomes an area that's covered in case it rains. And then we create an axis also towards the lake. So this is the view of Lake Monroe. Again, we put the building in a zone that we didn't have to cut one tree, so it was very sensitive to its setting. Like I was explaining, at first there was the ordinary typical pavilions that had no character really. So we obviously our inspirations were lean-tos. I don't know if you have that here, but these are very simple shelters that when you go when you're hiking. You can camp and without bringing a tent. So they're very, very simple. We've worked with the program by splitting the buildings into two pieces. Also, there was the framing of nature, which is part of the new concept, and creating new identities to the national parks, which the clients are really, really happy about. So obviously, these are certain conceptual sketches here, where we worked the program. Also, we worked with how do we play with simple forms, but it was simple for architects, but very difficult for engineers again. So especially for the roofscape. So here we opted for a hybrid steel and wood project. Again, we didn't want to have any columns inside, and so the whole concept was to play with planes instead of showing the structure itself. So again, we use knotty pine from all eastern Quebec, eastern cedar, Canadian hemlock. We have some western red cedar for our curtain wall. It's a wood curtain wall system that we use. So the company that does that, they only work with western cedar because of its stability. So we didn't have a choice to use that, but we're really happy to use a wood curtain wall in this project. And then also white ash for the furniture. Again, in this project, we use the hydrothermal heating system. And in Canada, we use a lot of geothermal. But here, since the lake was very close by, and then the authorities accepted that we did that, it was more sensitive than using geothermal because it does create a lot of problems on the site when there is the boring for the geothermal wells. So we use natural ventilation again, solar control screens on the outside. We use cantilevering as well for sun control. Prefabricated roof structure, steel and wood. And everything is automated, so the windows will open when the sensors say, well, we have to do a change of air, interior air. This is at no cost. Most of our projects, we aim to go at around 60% energy saving. So that's a natural way of designing for us. With working with our engineers, we achieve them most of the time. And certain pictures here. So there are no columns inside. There are long spans. So we had to choose a certain design strategies here. And then this was a beautiful surprise. These are, it's an exterior, but there's a lot of mosquitoes. And so we had to create certain screens so we can protect the young ones from getting bite by the mosquitoes. But we have this beautiful effect of sunlight and the shade of the trees inside. So sometimes when we design, we discover things. This is a school project. So our building code would permit us to do a 2-story wooden building for schools. We cannot do 3 stories. Our building code is in revision because there's this pressure to be able to build with higher, but with wood. So it is a constraint. So this is the school board accepted that we did a pilot project because also they were worried about the whole issue of maintenance. And we explained to them there's no problem with maintenance because we'll show them how to design well and also and to prove to them it's not an issue. Because you could have moisture problems with a steel building as much as it would, if it's not well designed. So they accepted it. So it's a different strategy here. So this is an agrandissement. How do you say that? It's a did I write it down? It's a major extension. Okay, so it's almost doubling the surface of the gray zone, which is the existing part, and then the part up here doesn't work. Was a renovation on the existing. So the lower part is the extension, and since it was a incombustible concrete building, we had to create a firewall, 2-hour rated firewall that you can see here that separates the extension from the existing building. And so that was very natural for us to do because we do that for different other projects as well. Also, what we've done here is we've worked with a light frame structure and a glue lam structure. So it's a hybrid wood building. So on the left is where the classrooms are, where there's a repetitive construction of each floor. It's the same floor plan. So it was very easy for us to integrate light wood framing for that part. And on the right, so you can see the little points, it's the glue lam post and beam zone. So this was the beginning of our headaches that we had with our engineers, because each section of the building, so light frame and glue lam, was calculated differently. So for seismic purposes, we had to work with, I thought there was a few sections here. Maybe it's later on. So anyway, so this is the gymnasium. So you have the long span with the glue lam columns, beams, and also glue lam deck. So there was no reason to use CLT for this project. Here you see some pictures, the agora, the stairs, and obviously, all our projects here are, this part of the building is sprinklered. And then this, since it was a one-story part of the building, we didn't have to encapsulate the wood structure, happily. Okay, these are the discussions that we had with our engineers. So at first, we were very critical about how do we do this. Do we all go with glue lam, or do we maintain our decision to go with a hybrid structure? So obviously, if we would have known that from the beginning, maybe it would have been either a light frame or completely a glue lam. But after some design issues that we had to, create a space of, I think it was like 15 centimeters between each structure because of the seismic requirements. So we learn in our process, and then also these areas had to be fire rated as well. So these were just little things that we should have known at the beginning instead of during our working drawings midway through. Certain pictures on site. it's beautiful to look at, right? And then this is from the solar screens from the exterior of the gymnasium. So that's the other facade. And finally, we were invited to do a project in Tianjin, China. It was our first experiment. And so it's a whole campus. It's a Canada Sino R&D center. And they wanted one building totally made out of glue lam and CLT. So you'll see later on that we've made them change their mind. So this is the certain concept. So there's a 13th-floor tower that obviously they did not want to do in wood, because at the beginning we thought it would be all wood, so we were all excited. So it's a simple concrete with glass tower. So obviously we had to bring a Canadian taste, so it's pictures of ice and the Rockies. And then so we played with also seasonal inspiration. And then there is the center, the R&D center. So we wanted to do like a tree house. And then there's another part of the building, which is the offices. And we've decided to go with light frame. So this is the project. Mars 1, 2, 3 are under construction. Those facades are made out of, it's done with the National Research Council of Canada. So it's a concrete structure, but they're using exterior wall, wood wall construction. So it's a part of a test that they're doing with our Chinese counterpart. Then there's the tower that you can see, and then you see the R&D building in the back. So obviously these are the footprint of the floors of the concept. And then we had good discussions about should we integrate it into one form or different forms, and they preferred that one of the buildings, which is more an exhibition space, would be identified as its own structure. So these are structural 3D modeling. And obviously, they were quite worried about the exhibition pavilion, because we didn't have straight columns going down at each corner. And so we worked hard with our engineers. They said it was possible, but it would be a little complex to build, because you have to build it in different sequences, but with supports, temporary supports for the erection of the structure. And then we convinced them that it was, since it's an R&D, let's go and show how we can build also with a light frame structure that they accepted. Obviously, building in China, it's not like building in Canada. Especially when we talked about natural ventilation, as you know. So we said we still want to do natural ventilation, but we'll take the air differently. You know, the air in China is not as pure as what we have here or in Canada. So obviously we're in high discussion here to create Canadian well, the Puy-Canadien. I don't know if it's like long tunnels underground, so you can take the air. It's refreshed, but we want to introduce some filtering systems so the air can be pure when it arrives into the building. So anyway, this is a section of the light frame area. And then this is another view. And then this is the heavy timber glue lam structure. That most likely it will be changed with CLT flooring and glue lam columns and beams. So again, we're introducing radiant heating and solar screens so we can avoid heat gains in the summertime. They don't have as many buildings as we have in Canada that are, how do you call that, climatisé, air conditioning. So that was one hurdle less for us to be able to exchange with them. So here's a couple views of what it's going to be when it will be built. So this is one of the views. We entered from the middle of the building, so we wanted to create this treehouse effect, and we have a mirrored ceiling at the bottom, under, and obviously we want to show all the structure, so it's mostly all glazed at the perimeter. So it's a building that will be able to entertain and explain how we can build differently. And here's a view of the campus that will be completed eventually. So thank you very much.
Thank you for your presentation. Amazing. Do we have questions from the audience? Erik. Oh, sorry. Lembit, yeah. Because the reason why I asked also Erik and Lembit, they both are born in Canada. They live in Estonia. They are basically Estonians. But in the same way, they can say they are Canadians.
Yeah.
Yeah.
Almost.
Except I'm born in New Zealand. But I grew up with Erik in Toronto. So we're not, our French is not very good. My question is this, you mentioned the desire to implement natural ventilation where you could, and you said in the last project it was more difficult. But just a very practical question, because I'm an architect as well, would you say that it's sufficient to have the air rise, let's say, only one floor? Because I saw, you know, the way you were saying, it was showing cross ventilation, obviously with the, what do they call it, chimney effect.
Yeah.
But I'm always thinking the chimney effect works when it's like 3 or 4 stories. But in your experience, even maybe a floor and a half.
Yeah, it's amazing. One of the projects I was doing a on-site presentation for our architectural tour, and the chimney effect and the whole ventilation was working perfectly, because one person said, can they turn off the air conditioning? You know, because of the wind, you know. So you have to understand the wind, dominant wind, it helps. It's not 100% necessary, but obviously it helps. And to positioning it that there is like a distance for the air intake at the lower part of the windows. And then heat rises. We did not invent that. It just rises naturally. So you need to have this ratio, and unfortunately, not every engineer understands that concept. So when you have an opening, it'll just create it. So what we want to do is have a great distance as far as possible, so we can bring up a lot more of the air away, but it does work. Does
it ever have anything also to do with the orientation regarding the sun, or you don't?
Well, obviously we want to go and avoid taking heated air, you know, even in the summertime. So we try to go on the north side if it's possible, and that's all part of the design of the concept. So we try to put our chances, you know, in the best way when we design and when we think, where will this be, that air intake, and for the outtake, it's a little less important. So we worked with the positive and negative wind pressures, if it's possible, on the building. And we understand also, because these people were, like the staff at the National Park, they say when it's 35 degrees, it's hot. But, you know, our body can understand that if there's a wind movement. You know, it could be maybe 32 outside, but inside, if it's like 29, and then you have wind movement on your skin, it's bearable, you know. So we had to work with that.
Thanks. Now I'll give the microphone to the other Canadian.
Again, thank you very much, Daniel, for a fantastic presentation. I was just thinking that if you followed in the footsteps of Charlene, and if you advertised your office as exclusively doing wood architecture, would you go bankrupt, or would you be more successful than you are already?
It's a good question. Obviously, my heart would say, let's just do wood, you know. So our wood buildings, I would say it's around 35% of our projects. You know, we're working on even if it's a non-wood building, we'll use a lot of wood finishing inside, you know. So it would be difficult for us to survive, or we would cut the staff in to 2/3, you know. So it's something that we strive to, and we work with building regulators to be able for them to change and to adapt different ways to make building mostly like schools, public schools, in wood, you know. So we always go that route, and then when we succeed, we're happy, and then if not, well, at least we tried. Yeah.
And one last thing, that not to think that Estonians are rude, that nobody's going to wish you happy birthday this evening. They consider it bad luck to wish it before your birthday. So as you're turning, your birthday is tomorrow, and you can expect birthday wishes at 12:001 minute this evening. So this is a little note, and a side note.
So thank you all.
Thank you, Eric. Thank you. Thank you, Daniel. Thank you. Our next guest and presentation maker is a man who comes also from quite far abroad. And despite of the long travel, he's very fit to tell us about an engineer's perspective of the architecture of Shigeru-ban. Welcome, Craig Kingsley, who is the president and CEO of KL&A Engineers and Builders, and he will tell about the innovation and evolution of timber design. Welcome.
Thank you very much. I'm really very, very honored to be here. This is actually my second time speaking at this conference. I was here in 2015, and I spoke then about this building, which is also a building by Shigeru-ban, the Aspen Art Museum, that I was the structural engineer for, together with Hermann Blumer, focused mostly on this wood roof structure. It was really a fun talk. It was really a great conference. I made a lot of friends, and found Estonia to be a really beautiful place. So I've been looking for an excuse to come back since then. We've done a number. We're not an exclusively wood structural engineer, but we do a number of different kinds of wood projects. Like this is a wood sculpture in a Dubai hotel. And here is a house that we're doing that's under construction for Studio Gang in Wyoming. And then this, here's some timber from Quebec, actually, in Canada, that is in a building in Denver. This is most of what we're doing right now, is mass timber commercial buildings and residential buildings, some in high-rise. So I thought I might be able to talk about these things, but in fact, for our inspiration for these kinds of structures, I tend to look east across the Atlantic to you guys for inspiration, and north to Canada. So I wasn't sure I had anything I could teach this crowd about tall wood buildings. But what I really wanted to talk about was this project that's in Kentucky, centered around a distillery that's called the Kentucky Owl Park. And this is a project that we won in competition together with Shigeru-ban, and it involves I lose count, 7 or 8 different buildings, all of them completely in wood structure, a really spectacular project. Here's a few of the key ones. You can see in the distance a train station, a guest center, and then the distillery is 3 wood pyramids. So the design of this is well underway. It's not done yet, but after I accepted to come or convinced Eric to invite me again, Shigeru Ban's office told me, well, we really strictly prohibit talking about projects that aren't complete. So I had then nothing to talk about. I can show you a couple of pictures that I stole off the internet, so they're public domain. Here, arrival at the train station, reminiscent of cast iron European train stations, and then the visitor center, reminiscent of bourbon barrels, which is what basically occupies this site, and then the pyramids themselves, which actually look a lot like the roof structure of the Aspen Art Museum. But I can't talk about those things. Maybe next time. I assure you that the project will come to completion. The whiskey that they're selling already comes emblazoned with the pyramids from the wood structure, so it's already pre-branded. We're ready to go. However, I do have a completed project recently, which is actually this book. I had the honor to work with the editor of this book, a woman from Shigeru's office, to be the structural advisor in editing this book. So I kind of got buried in all of his work over his whole history. And I thought that I might surreptitiously talk to you about the concepts that I would have about Kentucky Owl, but in the context of finished projects that Shigeru had done. So I'll try to sneak through it that way. Let me start, for those of you that don't know, Shigeru is an architect that is a Pritzker Prize winning architect. His main studio is in Tokyo, but he has also offices in Paris and in New York. And as far as I can tell, he just circles the earth, constantly dropping off occasionally at each one of those offices or his building sites. I don't know that he ever rests. In this slide, I asked the question that we've seen on multiple presentations so far today, which is why wood? And Shigeru addresses this question in the very first chapter of this book, but he addresses it from the point of view when he started his practice back, in the 60s. And no one was using the term sustainability or thinking about sustainable forestry, at least in those terms, or embodied carbon. But he quotes the 2 things that sort of drove him in all the materials that he uses, which include paper and bamboo and wood as well, that he doesn't like to waste things, and that he's interested in using weak materials in their own weak way. So hopefully you'll see some theme there. Another important aspect of this book that's dear to my heart is that he acknowledges right away his indebtedness to the collaboration that he's had with some really great structural engineers. I'm not including myself in that list. You'll see the 3, starting with famous structural engineer Gengo Matsui. At least he's famous among structural engineers. I can't speak for everybody here. Gengo Matsui started Shigeru with his very first structural paper tube structures that he's quite well known for. Another engineer that he had a direct collaboration with was Frei Otto, who you'll know from his lightweight structures and tension structures in Munich for the Olympics and many other really brilliant structures. And in this, he helped Shigeru with bamboo and timber and very lightweight structures like this pavilion. But the third engineer I want to mention is really, for me, the one that created the turning point in Shigeru's career. His name is Hermann Blumer, and I worked with him on the Aspen Art Museum and continue to work with him on Kentucky Owl. In fact, when you work as a structural engineer for Shigeru, it becomes an almost contractual obligation that you're willing to collaborate with Hermann because they come connected at the hip as collaborators, and there's no other way to get in the door. As it turns out, Hermann is quite a pleasure to work with, so it's been a delight every moment that I've spent. So I'm going to go through a few projects of Shigeru's, starting with some that are all called pre-Hermann and then post-Hermann, which sort of define his career. This is not how the book is presented. This is only in my mind, okay? So So the first sort of concept I want to think about is structure as architecture. And you've seen this already in projects that we've looked at today, is the idea of just exposing the structure and letting that have an architectural value. I almost should have written this the other way around, as architecture as structure, because Shigeru takes the paradigm a little further still. This is one of his very first projects that he calls Furniture House, where the structure of the building is not just exposed, but it's actually built out of the cabinets and the bookshelves that are in the building. So you can't move the bookshelves around anymore without structural collapse. But it's really quite a brilliant idea to take what the primary interior functions of the house and turn those into structure. Another project that he calls the House of Light and Shadow uses a similar approach. But now the notion of using weak materials in their own weak way starts to play. In this roof, it's just a bunch of straight members. He tilts one end to create a hyperbolic paraboloid shape, which obviously or clearly you can do simply by assembling straight lines across that plane. But he does it with quite a number of smaller elements. These are 38 millimeters wide, spaced 38 millimeters apart, so you can take very, very many, very small members and then connect them at the corners with a moment connection, which creates some rigidity in the joints. And with enough members over and over again, you can do this without giant connectors or without giant members, and it creates this really spectacular space. I'm at a loss as to where the insulation is in this system, so please don't ask me. I don't know how you stay warm, but there it is. This idea of intersecting planes matters. Wood in general likes to be, wood members like to pass by one another and be connected as they pass. So this notion of intersecting planes of timber and other structural elements is intriguing to me. It comes up a lot in our projects. In this Villa Tsengo Kubara, there's another articulated roof, very similar to the last one, where again he gets this doubly curved form out of straight members, but now we add one other component, which is the notion of extending the members through a glass plane without a big, ugly, heavy header underneath or a beam underneath to carry them. So to do that, it's actually a fairly simple trick to create a truss through which the wood members extend. So this is a structural member, all of steel, and then the wood passes through. By the way, as you work through the book and as you get into the post-Hermann world, you'll see the steel getting less and less until it disappears completely. So you can tell the earlier projects by how much steel is present. Let's see, here we go. So here it is in full view. And around the outside of the building, this beautiful, with an arrangement of wood members with an almost invisible girder, really. So same trick again, much larger scale at the Mount Fuji Shizuoka Airport. If anyone's Japanese, my apologies for my pronunciation. A similar idea, right? Again, something that I've noticed in my practice, which has been a relatively long one at this point, is that my best clients, friends, architects will find a good idea and then watch it evolve project to project as they get better to better. You can see that here. The same project from a house elevated to an airport with a much thinner steel frame. Again, much larger beams, much longer spans, so as to be almost totally invisible to create this amazing plane of members, right? So taking that concept out of the plane and into a doubly curved arch, elliptical sort of a curve, in this gymnasium project, it's actually a two-way structure, right? And this two-way structure intersects trusses going each way. And these trusses, the ones going the short direction, have wood members on the top and bottom chords, and then the diagonals, the webs, are created by steel members. And then in the longitudinal direction, The cords are steel pipes, and then the what I would call the diagonals or the web members are actually wood. That's the web members here, and then the cords here. And you combine those together over the whole nature of the structure, you get this really spectacular intersecting plane, which looks like all the wood occupies the same plane. The next concept, I just was looking into the notion of hardwood and softwood. Mostly we use softwood for construction. We're now moving into the post-Hermann phase, and you're starting to see his influence. These projects are not chronologically presented, but according to the concepts that I thought were interesting. This is the Tamedia headquarters that's in Zurich. It's a 6-story mass timber office building. And in this building started with, well, as all of Shigeru's projects start, they start with a sketch, which I come to recognize with his famous yellow pencil. They're very simple sketches, and the remarkable thing about all the projects that I've worked on so far is their clarity and their closeness to the actual final project. It's really quite remarkable how close they get, so I take them quite seriously. The other thing that's also true that I really respect about his work is that he not only shows what it's going to look like, but how it's going together and what the materials are, all sort of comprehensively, and how everything integrates with building systems and so on. So literally he hands this off and tells the engineers to go to work. So the concept of this building, actually let me go back to his sketch, is that there will be, there's large columns here, and then a long span with no columns in the middle of the building. This is a 20-meter space. So these columns are intended to have fixed connections at the ends of these beams, and that's accomplished with elliptical beams going through elliptical holes that then can't twist, that allow fixity of rotation here, but also just creating a continuous beam across this space. Here it is drawn a little bit more dramatically, or excuse me, a little bit more accurately, how the different pieces come together. Here's the columns, 2 pieces of a beam on either side, and then these elliptical pieces that are intended to pass through. But here we actually have a little trick of the eye, if you will. When Hermann took this project on as the structural engineer, he realized that these members that are made of spruce did not actually have the strength or density to do the job that was asked of them in this. But Shigeru had strict rules not to include or to minimize absolutely the steel in the structure. And I believe this one effectively has, I'm going to say almost none. There's going to be a piece of steel somewhere, but I don't know where it is. And in so doing, he's created these joints that include beech, plywood, hardwood, beams that pass through the middle. That's these dark sort of colored pieces, and the spruce just sort of hook on to the beech wood, so they express the work of the structure, but the real work is being done by this piece of hardwood and also 2 discs. Actually, let me go back just to point out that when this was constructed, these are 21-meter tall columns that came as one piece to the site and were all erected first, and then each of these modules of the building was just added one on to the next. So here, in addition, is beech plywood discs that fit into the columns and the beams and are connected through hardwood pegs into those elements to transfer forces that would otherwise overstress the spruce perpendicular to the grain, and also respects the direction of the grain of the wood. So this is one of the things that Hermann taught me. First, that you can use plywood to manipulate the stresses where they might normally work against the grain in a wood structure, and also to respect the use of hardwood in special cases and connections where it matters. So with that, we'll move on to the idea of three-dimensional space frames. This is actually a project that was done, it's a little bit more conventional looking. It's a triangular shaped roof over a house. And this one actually does include steel components. I've been listening today, and it's remarkable how many projects are driven by either cost or by local regulations. And in this case, Herman had designed a hardwood component to carry these forces at the nodes, where 9 different members come to meet at a point, and the local authorities wouldn't approve that. So he found instead a way to hide steel in there pretty deftly, so that you really can't see anything. There's a lot of pieces coming to a point in these joints. So there's a nicer view. So some compromise there. We'll take a moment actually to talk a little bit about the Aspen Art Museum, because presumably almost none of you were here in 2015, so I can talk about it again. But this is a project where it's actually mostly a concrete building down here, but there is a woven wood screen facade on the outside and this 3D space frame truss on the top. And here stairs go up both inside and outside. This glass wall occupies a space that separates the inside from the outside. And you come up to the top, look at this beautiful wood truss, and then work your way down through the museum. So this is the concept for this space frame structure, was again trying to get away from that notion of nodes and things coming together with steel connections. So Shigeru envisioned a number of curved pieces that would nest as you cut them out of wood panels, together with an offset frame of cords at the top and bottom. These cords are LVL from Norway, and then these are, this is actually, this is birch plywood, which I'll explain in some more detail. So we have hardwood webs and softwood spruce LVL cords. The connectors in this case are only screws. There's no metal connectors buried inside, and the curved cords just sort of slide past, or the curved webs slide past these webs. And again, here, because of the nature of these curved web elements, these diagonals, the stresses, especially around the columns, can get very high, and they also would be very difficult to make this out of wood that was cut out of a single sheet of wood with grain all running the same way. So in order to prevent tension from occurring perpendicular to the grain, we invented our own birch plywood, which looks like this. It has 2 layers going in one direction, the strong direction, then a weak direction, and so on as you work your way across this system. And then we piled up, glued together 4 of these, cut out of normal panels, in such a way that we could make these diagonals as long as we wanted, or as long as we could fit onto a truss. So there's a splice here, and then in the next node a splice here, and the next node a splice here, so we could really make them as long as we wanted, right? And here they are in fabrication. By the way, I'll interject this note that this was my first project with Shigeru, and I thought at first that the notion of curved diagonals in a truss was the stupidest idea I'd ever heard of in my life as a structural engineer, but I had no understanding of the force of his will, and so we have curved diagonals. Here they are under construction. And there's Shigeru on site. You can see that the members are actually quite fat when you get right up close to them. That's because we're in Aspen in the high mountains with relatively high snow loads. So we have a long span structure with a lot of load on. So here's the view, 2 photos looking down the outside stair where you come in from the outside, and here's a stair that's actually inside the conditioned part of the building. and you have the wood truss passing from inside to outside. And a couple of other views. I always point out, because I can't help it, that this is a window head. It's not holding up the structure. It really bothers me that it looks like it's holding up the structure, but in fact there's columns here. There is a column there. And there's the Aspen Ski Resort. So the last piece that I want to talk about in a little bit more detail is the whole notion of grid shells. And Shigeru's inspiration for three-dimensional grid shells is this Chinese hat. It's also a pattern that you can see in American furniture. I have dining room chairs with exactly this pattern of woven seats. But the idea is that it's a woven system with the members sort of working in and out through. But the structural benefit of this that's really amazing, I can illustrate, I think, through this diagram. Typically, I mean, here's members in a plane made of triangles, and we always are trying to make our space frames out of triangles. Here we have 6 members meeting at a point. And the move that Shigeru made to simplify this is simply to move these triangles down. So now only 4 members meet at a point. We still have a very rigid structure. I'm going to show you that again. It kind of looks like the triangles are shrinking, but only the one triangle group is moving down and the other one up. So we have exactly the same amount of material, but fewer connections at a node, right? More nodes, but fewer connections at a node, which simplifies how you put those connections together, okay? So that leads us to the Centre Pompidou Metz in France, which was actually the first project that Hermann Blumer did with Shigeru. I love the story of this structure. This is actually, to me, one of the most amazing wood structures that's ever been built, certainly in this century so far. The concept of it is the idea of this woven frame with the Chinese hat pattern, the hexagonal pattern, that drapes over a modern building that has almost no relation to this shape. It's literally like fabric draped over a building made up of a stack of rectangles. Really impressive. And he started working on this project with another engineer who informed them that he needed a certain amount of steel in the structure and, as I recall, a 3rd layer of wood in here instead of the 2. And it cost too much, and it looked like it wasn't going to come to pass. And then through a recommendation through friends, Shigeru met Hermann on this project and was introduced to him. There's a number of stories in the book that are interesting about Hermann going to pick Shigeru up at the airport and or at the train station, and neither of them speaks really terrific English, and they barely communicated one to the other, and Shigeru thought he was just a driver to get him to the actual meeting. Turned out not to be so. But the other thing that's amazing about Hermann is that he saw this concept and had no idea how to accomplish it, any aspect of it, how to make it work structurally, how to doubly curve the members. But as an engineer, unlike some of the other 2 that I introduced you to, Hermann has been working exclusively with wood his whole life. He's a carpenter, he's a builder, he's a fabricator. He's built several manufacturing facilities with his name on it all around Switzerland. And a truly brilliant engineer. And so being both optimistic and confident, Hermann promised that he would have a working system that would be within budget within 2 weeks, that he would deliver to Shigeru, and he had no idea. Hermann shared this story with me, and I thought it was like a special thing that he'd only let me know, but in fact he printed it in the book, so now I can tell everybody that story. So here's one of the models of that. I think it was hard enough to make the model. Note that the pattern of wood And the space frame twists down into these tornadoes of columns to complete the structure. So here's the concept to get the Chinese hat into structure. And now, if you were paying attention about planes intersecting planes, where trusses were intersecting trusses and moving past one another, where there was a steel truss and a wood truss, now it's all wood, right? And each of these planes is identical. There's 2 chords. Each of these is a truss, just a Vierendeel truss, where each of those members becomes, in fact, let me zoom in here. Each of these members becomes the web member of the Vierendeel truss, and then the nodal points are made with hardwood beech plywood dowels, again, to make these connections. And there is, I'm sorry to say, 1 bolt that goes through each connection, so there's some steel involved here. But these just pass by one another and connect. The next challenge of this was actually to get the doubly curved members themselves. I think I'll need another 40 minutes to talk about that, just what went on at Bloomer Amman at the time. And here's one of those beechwood dowels being hammered into place. There are these metal plates that hold things together, and here you can see the splices. One of Herman's contributions before he met Shigeru was developing extremely efficient small diameter dowel connections, which had a name. It's like the Bloomer something B2B system. But you have to go to Switzerland to get it made, so I've never been able to use them in our structures. But you can see the tangle of members here. It's a really remarkable story of both construction and engineering, not to mention envisioning from the architect. And a shot of it under construction so you can get a notion of scale. And then the finished structure so you can see sort of that draped fabric over the rectangular building components. And then from the inside, the view, now architecture as structure once again. So I think I've tied all my themes together in one show. Not long after this, Shigeru got a commission to do the 9 Bridges Golf Clubhouse that's in Korea. They wanted to use a similar roof system, but this is much simpler. It's effectively a flat roof, symmetrically arranged. And then one other key difference is that these members all occupy the same plane. We don't have the 2-layer truss system. He's got these members that are half-lapped and joined together, very much like the ones at the Aspen Art Museum, so that they look like they are occupying the same plane as they pass by one another, but in fact, they're cut down to interlock as Japanese joinery would. One aspect of that is that it tends to make the members a little bit heavier. So it might look a little heavier than Pompidou Metz by comparison, given the spans, but in my view, it looks light enough. An aspect that I forgot to identify specifically about the wood structures in this book that I'm talking about is that they all have as a thread the notion of consideration not only of engineering, stresses and strains in materials, but how construction will happen becomes an integral part of the design. It becomes very difficult to do these kind of projects in my mind where you have to design it and then tender it and look for the lowest cost. In general, these things have to be considered as a part of the design process. And in this case, you can see that the entire roof structure was made up of prefabricated components that came in, or that were built mostly on the ground, not very far away, but then lifted up and placed all together. And as I said, it looks light enough to me. One other grid shell structure that I just wanted to show, just to get a sense of scale, is, La Scène Musicale in Paris. And this is a large structure. You're seeing an entire concert hall here, enveloped now with another grid shell, not unlike the Pompidou, the Metz structure along the outside. but to get a sense of scale of a person standing next to this structure, or you can see here workers on the system. And in here, you can see the member depths are, I don't know, maybe a meter deep for these things. There's a great deal of wood to make this happen. Further to my point, though, about the construction process, this one, too, has its own unique system. They thought of it as a series of X's that were installed and then connected one to the next through a series of horizontal members. So again, that process became an integral part of the design. And then finally, I have just one more to show, but I think I have a number of slides on this one. This is more recently the Swatch headquarters. It finished up a few years ago in Switzerland. And it is also a grid shell, but not in the same way as the Chinese hat structure. This one is rectangular grid, and it's also enormous. It covers an entire commercial building in the shape of a snake here. This is a mass timber and CLT tall building that it connects to and drapes over on the other side of a road. Let me see, this isn't a very good picture to show. I will show, here you can see a little Swiss cross, which are peppered around the building, and if you look closely, you can see where those crosses, this is a slightly less stable structure than the one that is made up mostly of triangles and hexagons. So there's a clever way of introducing rigidity in each of those planes. This is a sky view of the structure as it's being constructed, and these are what the individual pieces looked like. Highly CNC cut. You can understand that without BIM modeling and 3D CAD modeling and digital fabrication, these projects would be utterly impossible. The joints are here, and there you see the bottom half of a beam, and then the top half of a beam will come down. So as you look over here, you can start to identify which pieces went through and which were the top and bottom half of the beams that made made the system complete. These angles are interesting, at least they're interesting to me from a structural point of view. In discussing with the engineer, a guy named Franz Chumperlin, who works with Hermann Blumer, who did all the analytical studies for actually all of these structures. I asked him about the motivation for these wedges. Was it because if we made the joints tight, it would compress, again, perpendicular to grain and introduce torsion into these systems? He said that was exactly right and provided me back a map that looked like this of what the rotation was at every single joint and how each angle of each of these is custom cut to allow the joint to close, but not too far. So every one of those is unique and individual around the entire structure. We often make the joke as we're working that we're not making Swiss watches here. You know, let's keep it simple. Let's keep the design simple. This is, in fact, a Swiss watch. And back to the notion of architecture as structure, he's within the structural system tying it a window, PTFE, a facade system, sprinkler lines. You know, every aspect of the building system was a part of the structural system. So an enormous amount of collaboration, collision detection, and work with everybody was necessary to keep that beautiful exposed structure from being just a giant clot of mechanical systems. So in fact, thanks to that hard work, this is what the space looks like on the inside. One of my disappointments, I guess, working on mass timber structures, I don't have a picture to show to illustrate this, though, is that a lot of the time it does get covered up with all the building systems and components and so on. And so some work that if you want to show off the wood, you have to think about showing off the wood and how that's going to happen without it getting hidden away in mechanical and fire protection systems. It's an enormous space. When they were just issuing the shop drawings for this, I visited Herman's group actually it was in Garmisch, where I met Eric, and we all went out to dinner together, me and the engineers, and they were exhausted because they had just submitted the shop drawings for this system, had been working nonstop for 2 weeks. And there's a final shot. And finally, I'll finish with some conclusions. By looking around, I think my intuition was right. There's a number of young folks here. These are mostly conclusions for those embarking on their career as much as us old folks. But if you're paying attention to wood architecture, remember, as Shigeru says, it's relatively weak. It's orthotropic, which means it's different in both directions. You have to pay attention to that, and the species are all different. So it's a really rich craft to pay attention to. If you're a young architect, I recommend that you befriend a good engineer. It will make your career much more easy, and it certainly worked for Shigeru. Likewise, if you're a structural engineer, I recommend that you befriend good architects. The richness of my career comes from the friends I've made and the collaboration work that I've done, but in this kind of integrated work, you can't afford to work in a silo, so you might as well work with your friends. Start with a clear structural idea. This is certainly a theme through Shigeru's work that I can completely stand behind. Hardwood is a good thing, used properly and in the right places. Let wood do the work. Most of the amazing things that I've learned from working with this group of engineers and architects is that you can, in fact, eliminate most of the steel that my intuition tells me should go into the structure. But in fact, wood can do the work. So you should aspire to let wood do the work. And then finally, in the face of the challenges that we face, seemingly insurmountable climate change, things that are underlying all of our work here in our dedication to lower embodied carbon and to wood architecture and wood buildings, take a clue from Herman, who, when he started the Centre Pompidou, started with optimism and proceeded with courage. So please do so, and we can do this. Thank you very much.
It was very thoughtful, all these steps for the engineers and the architects, and the main wording which was most important is that structure is architecture in both ways. Do we have questions?
None.
Eric, don't be shy. Yeah.
Thank you, Greg, for coming to Estonia a second time in November. This is truly exceptional. Next time we're going to have to make an exception and invite you in October. It's summertime then.
It's when the saunas are most appreciated.
Exactly. But the body of your work and what you spoke about, it's truly unbelievable. And it embodies the essence of what I guess we're all here, is using wood to its ultimate, which is a challenge that continues forever. And I think Greg said the most interesting thing when I met him years back. He said that having worked with steel and concrete for so long, he said he wasn't thinking. And he said he didn't study and spend all this time in school not to think, and that wood requires thinking. And the thought and thinking that goes into your work is just fantastic. So thank you from all of us here for making the journey and giving such a great presentation. And I'm going to say one more thing because this is always forgotten. I want to say right now, thank you for Andrus and Veronica, who have led the day on stage. And it seems like it's a very easy job. You can ask Lembit later, it's not, but...
it is easy.
Yeah. But thank you on behalf of the Estonian Forestry Industry Association that you've helped out once again.
Thanks, Eric. You are too early because it's the question round for Greg. I was one thought that when the idea in many cases for Shigeru was the Chinese hat, which is just a woven, easy structure so that human can do it easily. And the material bends easily and you get strong structure. Have you ever thought that, what the heck, I'm doing such a huge work to put the wood into the shape as you do in computer-generated images to get all the calculated how the CNC should cut. Have you ever thought that if you would be a giant 10 times bigger than the normal human, you would take the wood by hands and bend it like a Chinese hat? Have you ever come to the idea that the engineer's work is not so easy comparing how it looks?
Well, certainly I've had the idea that it's one thing to start with a simple idea of a woven mat, and it looks very simple when you're making it with your fingers, and remarkable to see how unbelievably complex it becomes when you're trying to do it at a much, much larger scale, particularly because the trees don't get any bigger in order to accomplish that, right? And then there's other things as well, like the Aspen Art Museum actually has a woven screen on the front of it, right, which involved a lot of challenges in terms of what material could actually accomplish those radii and so on. So I've just come to recognize that what looks simple isn't always simple at scale, but at the end of the day, I always appreciate how it looks and how it feels and what it represents. I always remember a contractor when we were standing back looking at something finished, and he said, you know, I can't see the pain from here. And I think that's the essence of it.
One more question about the technologies. One way is to create a woven structure so that you cut the material and you use it as basically like solid thing. The second thing is to steam wood and to use the methods how old wooden boats are done. Have you used this method also on the projects of Shigeru?
Excuse me, yes, absolutely. And I didn't point out that several of the, like for example, the gymnasium with the doubly curved roof, all of that was steamed wood. As an example.
How do you calculate that? Do you make also prototypes? I mean, how the steamed wood reacts and how are the forces in it? Is it already in the programs predictable?
Yeah, you can accumulate some of that residual stress, but the notion of steaming and bending has very, very low residual stress just by the nature of how it works. It's much better than just forcing the issue. I think that for Pompidou, for example, the Metz project with the doubly curved timbers, they more just forced those into place and have to calculate the spring back where it's going to bounce back, actually. So it's a little bit more violent than steam curing. But there's also, again, issues of scale, right? You can't steam members that are that long. So, and I think every technique for manipulating wood Shigeru has used in his career, I'm going to say.
Thank you. Thank you for your amazing work, and I'm happy you had this kind of, or you have this kind of cooperation with an architect, which brings you totally new inventions, which might look as simple as the Chinese hat, but that's truly amazing. Thank you, Greg.
Thank you very much. Thanks for having me.
Meie tänase konverentsi esinemised on lõppenud. Veronika.
And today's presentations are all done. Veronica, it's time for conclusions. Actually, there is a very interesting part of the evening still there. Yeah, you are speaking about the award gala, but let's speak about the day we have had. I think the last presentation was actually a very good conclusion. For example, you make it look very easy, which means that, well, looking on the pictures, images, everything seems to be so logical, so rational, amazing. But on the other hand, if you think about the work behind all that, how complicated problems have been tackled and
I think what really came through from the presentations today is this kind of rigor and relevance and also venturousness, that coupling excellent architecture with excellent engineering, and also coupling, as Greg pointed out, optimism with courage. These are, for me, the keywords that really surfaced from all the presentations.
Jaa, just täpselt. Ja noortele üliõpilastele siis peamine sõnum on see, et
exactly. And the main message for the young listeners, find a friend among the architects if you are an engineer, and if you are an engineer, find a friend who is a good architect. You also heard that from the last presentation. I'd like to thank all the speakers. I think that in Estonia, for this sector, it is of utmost importance that we had very high-level know-how, both on the engineering side and architectural side. And many of our guests have come here specifically to listen to these people. So once again, thank you. Thank you for making it possible to learn from your experience.
Tänase konverentsi korraldajaks on Eesti.
The organizers of this conference is the Wood and Timber Construction Association of Estonia. I'd like to thank them for continuously backing this annual event, and we'd like to thank other sponsors and who have made it possible to organize the conference on a high professional level. There are more than 10 operators working behind the stage so that we have good quality sound and image. And we also had the live conference available for everybody, if not in 1 week's time, definitely in 2 weeks' time. So that means that anybody of you can re-listen to these presentations you heard today. But now there will be a short break before we continue with our award gala. And for that purpose, we have also some music from a group called Duo Rut. The award gala is not going to be interpreted.
Kompetents ja sujuv koostöö. See on Mark Wood. kompetents ja sujuv koostöö. See on Markwood.
Yeah.
Mis sina puud põhjatuli, mis sina puud põhjatuli, ida tuuli, eruteled ida tuuli, eruteled kagutuuli, karuteled kagutuuli, karuteled lounatuuli, eruteled lounatuuli, eruteled edeltuuli, eruteled edeltuuli, eruteled laustuuli, längüteled laustuuli, längüteled veskari, vereteled veskari, vereteled luestuuli, loiguteled luestuuli, loiguteled põhjatuli, ida tuuli, eruteled ida tuuli, eruteled kagutuuli, karuteled kagutuuli, karuteled lounatuuli, eruteled lounatuuli, eruteled edeltuuli, edeltuuli, eruteled laustuuli, längüteled laustuuli, längüteled veskari, vereteled veskari, vereteled luestuuli, loiguteled luestuuli, loiguteled pukepuida, pukemaida, pukepuida, pukemaida, Maria, mageda, maida, Maria, mageda, maida. Mis sina puud põhjatuli, 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 mis sina puud, mis sina puud, sina puud. Seisab eivati kulsevesse perelel pamba võitante nemesad sesame terril terril terril. Seisab eivati kulsevesse perelel võitante nemesad sesame terril terril terril. Seisab eivati kulsevesse perelel võitante nemesad sesame terril terril terril. Seisab eivati kulsevesse perelel võitan teeme mesad sesame terrel verrel seisab ei vati kulse vesse lell pamba võitam teeme mesad sesame terrel verrel seisab ei vati kulse vesse perelel võitam teeme mesad sesame terrel verrel seisab ei vati kulse vesse perelel võitam teeme mesad sesame seisab ei vati kulse vesse pirrel pamba võitam teeme mesad sesame terrel seisab ei vati kulse vesse pirrel pamba võitam teeme mesad sesame terrel seisab ei vati kulse vesse pirrel pamba võitam teeme mesad sesame terrel seisab ei vati kulse vesse pirrel pamba võitam teeme mesad sesame veivati kulse vesse pirrel pamba võitam teeme mesad sesame terrel seisab veivati kulse vesse pirrel pamba võitam teeme mesad sesame terrel seisab veivati kulse vesse pirrel pamba võitam teeme mesad sesame terrel seisab veivati kulse vesse pirrel pamba võitam teeme mesad sesame terrel
Suur aitäh ja tere ka meie poolt. Meie oleme Duo Ruut. Mängime teile paar lugu ja me teeme enda töötlusi Eesti pärimusmuusikast kasutades ühte kannelt, mis on selline klaverivabriku
puust konstruktsioon, võiks öelda. Mängime seda kahekesi, mõtleme välja oma mängutehnikaid, oma mänguviise. Ja see teine lugu, mis me mängime, mis on meie tänane viimane lugu, on tantsma kutsumine, selline tantsulaul.
Hi everyone, we are Duo Root. We play this weird wooden instrument. It's an old Estonian traditional instrument called kannel, and we invent our own way of playing. And we use Estonian traditional texts and songs, and we make our own arrangements out of them. And today the second and the last song we're going to play is Tantsma kutsumine.
Neiukesed, noorekesed, neiukesed, noorekesed. Liinalaka linnukesed, liinalaka linnukesed. Käeharpeaga kaunikesed, käeharpeaga kaunikesed. Pange puunapaeladesse, pange puunapaeladesse. Sinisidi lintidesse, sinisidi lintidesse. Siis lähen tasa tantsimaie, siis lähen tasa tantsimaie. Neiukesed, noorekesed, neiukesed, noorekesed, neiukesed, noorekesed, liinalaka linnukesed, liinalaka kaunikesed, käeharpeaga kaunikesed, pange puunapaeladesse, pange puunapaeladesse, pange puunapaeladesse, sinisidi lintidesse, siis lähen tasa tantsimaie, siis lähen tasa tantsimaie, siis lähen tasa tantsimaie. Sindab tare tantsimista, liidab kinni litsumista, liidab kinni litsumista. Peijukene poisikene vaata vara, ergul silmi, vaata vara. Silmi ergul silmi, hella neiu, ergul silmi, hella neiu. Targil silmi, tarka neiu, targil silmi, tarka neiu. Poisikene, peijukene poisikene, vaata vara, ergul silmi, vaata vara, ergul silmi. Tarka neiu, targil silmi, neiu.
Tuo Ruudole. Mul on väga hea meel sisse juhatada meie tänaõhtuse aasta puitehitis 2022 gala. Ja küllap ikka kipume olema sellest mõjutatud, et me elame sellisel keerulisel ja kiiresti muutuval ajal. Ja kuna mul oli väga suur rõõm olla tänavuses aasta puitehitis 2022 žüriis, siis ma pean ausalt tõdema, et hea puitarhitektuur, nii nagu ka hea muusika, pakub just sellist emotsionaalset tuge ja soojendab hinge. Me käisime žüriiga läbi terve rea objekte ja võib öelda küll, et see, mida me nägime, kinnitab, et nii nagu puit on olnud ja puu on olnud meile hea kaaslane läbi aastatuhandete, siis ka täna on ta sellise hea sõbra rollis, keda nii arhitektid kui insenerid on järjest rohkem omaks võtmas ja järjest põnevamaid objekte sellest kujundamas. Lisaks minule kuulusid tänavu konkursi žüriisse ka Ülo Tarmo Stöör, kes oli meil žürii esimees ja ta on olnud ka aasta puitehitis 2021 ehk siis eelmise aasta autor. Samuti Kaupo Koitla, ehitusinsener ja Eesti Ehitusinseneride Liidu esindaja, siis ka Villu Kukk, ehitusinsener ja materjaliteadlane, Tallinna Tehnikaülikooli teadur, Martin Varvas, ehitusinsener ja ehitusettevõtja ja Kart Subi, sisearhitekt. Ja et minna kohe auhindade juurde, siis me alustame seekord Rightwoodi fassaadi auhinnast. Ja selle kohta võib öelda niimoodi, et üks pilt ütleb enam kui 1000 sõna. Ja üks pilk maja fassaadile ütleb kindlasti maja kohta rohkem kui 1000 sinna riputatud silti. Ja ideaalis peaks fassaad ütlema maja sisu kohta piisavalt, et vältida liigseid küsimusi ja häälestama meid sellele, mis meid seal maja sees ootab ja mis seal toimuma hakkab ja kuidas see maja meid peaks vastu võtma. Moodne puitfassaad võiks ju häälestada meid kestlikkusele, innovatsioonile või uuenduslikkusele, soojusele kindlasti, nagu juba eespool ütlesin, sõbralikkusele, siirusele, loomulikkusele. Sest et puitfassaadiga maja on koht, mis ei jäta kedagi külmaks. Nominentideks Rightwoodi fassaadi auhinda tarvis olid Nõmme gümnaasiumi spordihoone, Loodusvilla Käbi, Tabasalu riigigümnaasium ja nüüd on mul au lavale paluda Rightwoodi juhatuse esimees Ivar Dembovski. Palun, Ivar. Nii, ahaa, tuleb kuulutada välja võitja. Nii, ja meie võitjaks on?
Ja meie võitjaks on, aga enne kui võitja välja kuulutada, ma ütlen, et fassaadid puidust on imelised, puu tuleb metsast ja mets kasvab uuesti, aga võitja on Loodusvilla Käbi.
Aitäh kõigile selle imelise tunnustuse eest. Nagu siit piltidel on võimalik näha, siis seda fassaadi on siin tõesti kõvasti. Ja selle fassaadi lugu on tegelikult ka väga eriline. See on täiesti käsitsi tehtud kimmid Lõuna-Eesti kohaliku puutöömeistri poolt. Ja neid kimme on seal kokku 7500 tükki. Et see on olnud väga suur töö ja suur aplaus ka tellijale. Tellija on ka meil täna siin Maidla Nature Resort, kes on tõeliselt usaldusväärne nii-öelda tellijalt, kes alati läheb kaasa meie selliste arhitekti hullumeelsete ideedega. Ja ka aitäh Laur Lõvile, kes pani kokku selle konstruktiivse lahenduse. Ja lisaks minu hea partner Arvi Anderson, kellega koos me selle disaini siin koos oleme välja mõelnud. Ja ehitajad ja kõik, kes on olnud siin kambas. Ja loodan, et inimestel jätkub julgust ja rahakotti, et seda mõnusat ööbimiskohta endale lubada. See on tõesti väga vahva koht. Aitäh!
Kategooria on Arkwoodi liimpuidu auhind. Kas pole isegi tobe, kui meie unistusi aitab täita selline tavaline ja isegi banaalne asi nagu liim? Ilma liimita ei oleks liimpuitu ja ilma sellise puiduta jääksid täitumata paljude inimeste unistused ja sama paljude arhitektide visioonid. Liimpuit annab hoonele kandvust, massiivsust, loomulikul ja looduslikul viisil. Kasutades metalli- ja betoonkonstruktsioonide asemel liimpuitu muutuvad interjöörid soojemaks ja sõbralikumaks ja nõnda me ka ise alateadlikult. Arkwoodi liimpuidu auhinna nominendid on Püha Johannese kool, Rakvere töö- ja tehnoloogiakeskus ja Aasa kortermaja. Arkwoodi liimpuidu auhinna annab võitjale üle Arkwoodi juhatuse esimees Peeter Peedomaa.
Tere ka minu poolt. Esmalt paar sõna tahaks öelda konverentsi korraldajatele, kes on teinud tublit tööd, nagu peegeldab ka auditooriumi pilt, rahvast on hulga. Aga sellele rahvale julgeks ma öelda, et tänase päeva fookuses see on kindlasti ainuõige koht, kus olla täna. Ja veel tahaks tunnustada žüriid, kes võttis vaevaks ja käis need mitukümmend objekti üle. Ja ma usun, et meie tublid arhitektid peitsid nendesse objektidesse niinimetatud õige mitu magusat rosinat. Ja ma usun, et žürii leidis need üles. Ja loomulikult tunnustus moderaatoritele, Veronikale ja Andrusele, aga aasta puitehitis 2022 Arkwoodi liimpuidu võitja tehniliste lahenduste eest on paraku Aasa kortermaja. Tork Arhitektid OÜ.
Siis paar sõna või? Et tegelikult selle maja autoriteks olen mina, Lembit Tork, siis Kristo Põlluaas ja siis veel üks kolmas isik, Allan Pintson, kes ei ole praegu täna meiega siin. Aga see tuli, mind kõik see üllatas, ma olin peaaegu selle maja ära unustanud, kuni keegi helistas mulle, et me ikka seda ehitatakse ja on valmis ja ta oli kogu aeg ühe suure kile all, sest nagu me kuulsime esimesest ettekandes, kõige hullem asi puithoone jaoks on see vesi. Nii et ma viimane kord nägin seda maja, kui ta oli kile all ja nüüd ma näen seda siin ekraanil praktiliselt. Aga see kõik tuli väga suures koostöös muidugi Teljaga, kes seisab meie vasakut kätt ja ka muidugi inseneriga, sest et ilma, ütleme, me tegime niimoodi, et lõppkokkuvõttes põhiprojekti koostöö inseneriga oli meeletu ja insener ikka tegi suurem jagu sellest, meie olime need, kes selle esteetikat nagu suunasime. Igal juhul suur aitäh Kristo ja suur aitäh ka Allan, kes siin ei ole ja tänan teid kõike ka, tänan väga ja tänan sind, Peeter.
Enne järgmise auhinna välja kuulutamist ma klaarin ära ühe eksituse, mis puudutab Raidwoodi fassaadi auhinda. Ja nagu me kõik nägime, auhinda tuli vastu võtma autor Mari Hunt ja B210. Et slaidil oli ekslik info, aga me oleme väga tänulikud Marile selle fantastilise töö eest, mis ta on Loodusvilla Käbi puhul teinud. Aga läheme edasi. Meil on järgmisena välja anda Esplai interiööri auhind. Puit võidutses interiööris võib-olla ehk et eelmise sajandi esimeses pooles ja hiljem on jäänud see suurepärane materjal tehnilisele progressile jalgu, kui võib-olla liialt looduslik ja maalähedane. No, arvamusi on erinevaid, aga õnneks on trendid viimastel aastatel pöördunud ja puit on taas üha tervitatavam osa tänapäevasest interiöörist. Ja seesama tehniline progress, nagu me ka žüriis nägime, on tulnud igat pidi puidu kasutamisele sisearhitektuuris kasuks ja märgatavalt laiendanud ja avardanud neid kasutusvõimalusi. Ja seetõttu on mul hea meel välja kuulutada Esplai interiööri auhinna nominendid, milleks on Kultuuri- ja Hariduskeskus Viimsi Artium, Päevakoera eramu ja Loodusvilla Käbi. Ning Esplai interiööri auhinda palun ma lavale kätte andma Esplai tegevdirektori Ando Juki.
Kõigepealt parandame vea ära, et tere õhtust, et ma ei ole tegevjuht, ma olen nõukogu liige ja olen olnud selle Esplai üks, kuidas ma ütlen, võib-olla layout'i arhitektidest, et see, mis seal sees on ja sellega tegelenud, et selline kunstiline tegevus on mulle ka tuttav tehnilisel tasandil, et kuidas sellest puust võiks lõpuks üks toode saada. Et see, mis siin täna toimunud on ja hommikust saadik nagu siin vaadanud, et mis siin laval toimub, et nüüd on hea meel olla siin laval, sest esimene lavakogemus endal oli saunalavalt, nagu paljudel teistelt, aga nii ilusat lava puitarhitektuuri konkursil mina ei ole enne näinud, et see on tõeliselt ilus siin. Kunst on ilus asi, samamoodi Jah. Natuke venitan. Kuulutan välja siis interjööri auhinna võitja. Selleks on Kultuuri- ja Hariduskeskus Viimsi Artium, Siiri Valner ja Mari-Liis Sõber, Kava arhitektuuribüroo.
Tere! Ei teagi, mida kohe öelda.
Aitäh, et te võtsite meid siia konkursile, kuigi meie maja on tegelikult betoonist. Aga ma arvan, et te nägite, et me tahtsime väga seda puidust teha, sellepärast et nii seest kui väljast on see puiduga kaetud ja eks me järgmine kord teeme terve maja puidust.
Tulge palun tagasi lavale foto jaoks korraks.
Teeme foto ka ära.
Nii, aga meil on tegelikult žürii poolt ka ära märgitud tööd. Et kõik ei pääse Marjamaale, aga tegelikult ei ole puitehitiste auhindamisel nii nagu spordis ja sellepärast me tegelikult nägime sedavõrd tihedat konkurentsi ja niivõrd tihedat võistlust ja tasavägist sellist objektide võrdlust, et me pidasime vajalikuks esile tõsta veel mitut objekti. Ja need põhjused on väga erinevad, miks üks või teine objekt veel sealt tõesti sedavõrd meelt köitis, et me tahame nad välja tuua. Ja selleks ma palun lavale meie žürii esimehe Ülo Tarmo-Stööri.
Tere jälle. Ma laenan seda. Ma proovin nüüd niimoodi hästi krüptiliselt paar sõna ette öelda, et kohe aru ei saaks, mis majast või hoonest käib jutt, aga vaatame, kui hästi mul see välja tuleb. Aga esimesena märgiks ära ühe töö, kus meile tundus, et arhitekt on lähenenud sellele täiesti teise nurga alt, kui ootaks, kui tal selline ülesanne antakse. Ja teiseks tahaks väga tunnustada tellijat, kes ei ole valinud üldse lihtsat teed, et oleks võinud kindlasti teha ajutiselt, odavamalt, aga ütleme nii, et laulja vajab lava ja arhitekt sai sellega suurepäraselt hakkama, et tunnustaks Treski küünilava.
Jah, mulle lubati 2 sõnad. Jah, nagu öeldi, et tellija valis sellise väga ambitsioonika nagu idee, mida me pakkusime. Ja noh, kus ma alustan? Jah, no algul me mõtlesime, et äkki seda saab unistada, aga no tema tuli kaasa, et no selles mõttes oli väga hea koostöö, et saime sellise usalduse alusel, saime nii hästi hakkama. Muidu me peame tänama Maidule, kes viis meid Jalmari kokku, ja siis on see Reimo, kes ehitas koha peal kattega väga rasket, nagu see väga raske konstruktsiooni, isegi kraana abil, mis on tõstis selle katuse ka ära lõpuks. Ja siis on see inseneri Andrei ja siis on Maidu Tamm, kes pani selle projekti ilusti kokku. Et jah, me peame lõputult tänama inimestele, kes aitas ja toetas meid, et jah, ma olen väga tänulik. Aitäh!
Kuna Jalmar on Tartus salvestusel, siis ta palus edasi öelda aitäh toetajatele. Ilma toetajateta poleks lihtsalt seda lava võimalik olnud teha. Et see on väga vinge projekt, külastage kõik Setomaad, tulge Treskisse 2023 festivalipiletid läksid tänasest müüki, nii et Treskis näeme.
Järgmise ehitise kohta ütleks nii, et žürii ei jõudnud üksmeelele, et kui palju peab olema puitu rannas, aga nad olid kõik olime nõus, et see oli väga hästi teostatud, väga sellise puhta joonega tehtud maastikuprojekt ja üldse oli väga hea meel näha sellel võistlusel ka maastikuarhitektuuri projekt ehk tunnustaks Emajõe linna ujulat.
Nii kui nüüd autorid kuskilt just välja ei hüppa, siis me kindlasti toimetame nendele selle auhinnatahvli kohale, et väike meenutus sellest jääks.
Järgmine hoone oli väga hea maja, ütleme nii, et seal oli kõik hästi õigesti ja mulle endale tundub, et seal oli vist ideaalne koostöö arhitekti, tellija, kõikide teiste projekteerijate ja ehitaja vahel. Et tunnustaks Päevakoera eramut.
Aitäh kõigepealt heade sõnade eest. Tõepoolest see koostöö tellijaga oli super. Tellija usaldas meid vist esimesest hetkest peale. Aga tahaks veel eraldi tänada Estus, siin Marek Mardisood vist istub kusagil seal üleval. Ja siis neid hulle krohvijaid, Krohvin kohvistuudiost Andrus Needoga eesotsas, kes tegelikult tegid sellest majast tõsise kohvi workshopi. Et selliseid kohvi tasemel viimistletud seinu pole mina veel varem kusagil näinud. Et selle mõttes suured tänu teile. Aitäh!
Järgmise hoone kohta ütleks, et tegemist oli uue hoonega, aga see mõjus nagu vana tuttav seal maastikus, sobis siin ideaalselt ja jäi mulje, et see on olnud seal juba pikka aega. Ja väga vahva oli näha, kuidas üks hoone suudab endist militaarmaastikku üle kirjutada. Tunnustame Hara sadamahoonet.
Mina esindan Esthussi ehitaja poolt. Suured tänud Indrek Almani selle projekti loomise eest. Kõik need lahendused on päris omapärased ja kihtid ja meie omalt poolt siis lisasime sellele seda puidu osa juurde, et kogu see maja on siis ristkiht naelpuidust ehitatud, soojustatud puitkiude soojustusega ja kaetud siis orgaanovuudi ehk naturaalse viimistlusmaterjaliga laudisega. Aitäh!
Hoone sobis väga hästi maastikku ja hea meel on näha, et kui kogukond pingutab ja tudengid löövad kampa, siis on alati hea tulemus. Et tunnustaks Klooga Kosk või kogukonna saun.
Peame leidma võimaluse. See on siis kursusele. Reis stuudio, ma saan aru, kiitusega aitäh teile. Ma ei oleks arvanud, ma eeldan, et keegi meist ei oleks arvanud, et me siin oleks, aga siia satuks. Aga ma sooviks siis tänada kõiki toetajaid, kes võimaldasid selle projekti võimalust, et me ehitasime selle valmis ja ka kohalikku kogukonda, aga siis kõiki minu kursusekaaslasi ja ka Eesti Kunstiakadeemiat, ilma kelleta poleks võimalik, et ma oleks saanud juba nii varakult siis paberilt siis reaalsusesse sellise projekti ehitada. Ja kõik õppejõud ka midagi. Aitäh!
Järgmine puitarhitektuuri auhindade kategooria on Delfi moodne kodu rahvalemmik. Rahva arvamus on delikaatne ja polariseeriv teema mis tahes küsimuses, eriti maitse küsimustes, kus teatavasti isegi mitte ei vaielda, vaid kakeldakse. Me ei hakka siin kumbagi tegema, vaid võtame seda lihtsalt nii, nagu see on. Rahva arvamuse puhul pole tegu õige või vale vastusega, oluline on, et see on olemas. Ning kui arhitektuuri ja disaini üks eesmärke on ka sedasama rahvast harida, siis võib iga siinviibija vaikimisi enda jaoks ka otsustada, kui hästi on kaasaegsel Eesti arhitektuuril ja disainil õnnestunud harida näiteks Delfi lugejat. Delfi moodsa kodu rahvalemmiku auhinna annab võitjale kätte Erik Konse.
Tere õhtust! Huvitav on mõelda numbritele natukene, et üle 35 000 inimese hääletas sellel konkurssi esitatud tööde võidutöö selgitamiseks. See võiks panna mõnegi poliitiku mõtlema, et miks nad siin saalis ei ole, sest et väga vähesed poliitikud on Eestis saanud üle 35 000 hääle. Nii, et meie tänane võitja või mitte võitja, õigemini rahvalemmik. Rahvalemmik on projekteeritud ühe arhitekti poolt, kes on, ma arvan, seesmiselt ikka nagu väikene laps, aga ääretult hea ja vastutustundlik inimene, kelle nimeks on siis Mihkel Tüür ja objekt, mis valiti siis rahva poolt parimaks, nende arvu oli Poku.
Õnne. Annate sulle selle?
Ja siis Delfi veel otsustas, et nad kingivad Mihklile terve aasta nende erinevate väljaannete lugemisõigust ja veel lilled, nii et Mihklil on nüüd palju lugemist ootamas.
Võib-olla siis ütleks ka paar sõna, et jällegi, et autoriteks on ka Ott Kadarik ja Aleksei Petrov, et me neil seda kolmekesi ja siis see maja on jah, niimoodi puitarhitektuuri piiril, et me oleme sellega kombanud seal 3 erinevat konstruktsiooni viisi, et alustasime liimpuitkaartest ja lõpetasime siis Laur Lõvi kindla käe all, tema on küllalt tuntud siin laval, selliste CNC-ga välja lõigatud vineerraamide abil selle ruumi loomisega. Tänaks väga ka tellijat, kes on Maidla Resort ja loomulikult publikut. Aitäh!
Kindlalt, kuid vääramatult on meie õhtu jõudnud finaalini, selle kõige põnevama hetkeni, mida kõik on siia kokku tulles kirglikult oodanud ja mis on andnud sellele tänasele õhtule oma nime, aasta puitehitis 2022. Ehk et siis me natukene siin kruvime veel pinget ja kedagi otseselt välja ei kutsu, sest et tõesti see on ju ääretult põnev hetk. Ehk et daamid ja härrad, aasta 2022 puitehitise nominendid on Harasadama hoone, Rakvere Teadus- ja Tehnoloogiakeskus ja Päevakoera eramu. Ja aasta puitehitise 2022 auhinna annab võitjatele kätte Eesti Metsa- ja Puidutööstuse Liidu tegevjuht Henrik Välja. Palun sind lavale.
Nii, tere õhtust kõikidele. Saan siis ka võimaluse siin lava peal täna korraks seista. Ma pean tõdema, et siit tõesti ei näe, kas siin saalis on alles meil 3 inimest või rohkem. Need valgustid paistavad väga silma. Aga tegelikult ma ennem piilusin, mul on väga hea meel näha, et meil on tegelikult kogu päeva jooksul olnud siin saal julgelt täis ja te olete selle pika päeva vastu pidanud. Ei ole veel ära põgenenud. Ja ma natukene veel venitan selle väljakuulutamisega, sest et ikkagi peab paar sõna ütlema konverentsi kohta. Mul on au olnud seda konverentsi nüüd päris palju aastaid korraldada ja mul on tundub, et see ring hakkab aina enam täis saama, millest me siin räägime, hakkab teatud loogika tekkima. Kui te mäletate, kes osales meie eelmise aasta konverentsil, siis seal oli üks ettekanne Soomest Aalto professori Matti Kuitineni poolt, kelle õpetussõnad olid, et milline on jätkusuutlik ehitus, et parim ehitus on see, mis sa ei ehita. Kui sa selliselt ei saa, siis kasuta olemasolevat ja planeeri ja kui selliselt ka ei saa, siis ehita uus, aga ehita säästlikult ja tuleb planeerida ka materjalide ringkasutust. Ja sellest kõigest me olemegi täna kuulnud, kuidas oma roll selles kogu ringis on nii arhitektil, on inseneril, on ka puussepal ja ma väga loodan, et kui ma nüüd siin selle võite välja kuulutan ja me selle tseremoonia lõpule viime ning liigume etteruumi, kus meil on võimalik koos natukene vabalt õhtut veeta, siis te natuke näete vaeva selle nimel, et siit täna ära minnes igal arhitektil oleks siis üks insenerist sõber ja võiks olla ka üks puussepast sõber. Ja samamoodi inseneril arhitektist sõber ja puussepast sõber ning puussepal arhitektist ning insenerist sõber. Sest et head tulemust saavutab ikkagi koostöö kaudu ja loodan, et see tänane päev on olnud teile meeldejääv ja olete seda nautinud. Aga nüüd, 20. aasta puitehitis. 20 korda oleme me seda välja kuulutanud ja aastal 2022 on aasta puitehitise žürii valinud parimaks puitehitiseks Rakvere tehnoloogiakeskuse. Palun siia 6 arhitektid ja kui siin saalis on veel teisi objektiga seotud inimesi, tulge palun kõik lavale. Ning iga aasta puitehitise maja seinale, ma loodan, on tänaseks kinnitatud üks sükene majamärk ja toimetame siis sellega Rakvere ja vaatame, et see sinna seinal saaks.
Suur tänu. Tänase puidukonverentsi lõpuks on ilmselt kõigile selge, et puit on väga tore materjal. Ja minu õnneks teadsid juba paar aastat tagasi Rakvere linnavalitsuse inimesed, et see nii on ja realiseerisid sellise võrdlemisi ambitsioonika projekti ja ei kasutanud seda võimalust jätta ehitamata. Kuna ma esindan siin praegu sellist jäämäe tippu, sest tegelikult selle projekti taga on väga suur meeskond, siis ma kasutaks võimalust ja tänaks mõnda võtmetegijat, kes sellele projektile sisu ja välimuse andsid. Et sisearhitekt Kristi Jakobson, projektijuht Aare Asper, insenerid Ketsist ja konstruktorid Arro Agasillast. Suur tänu teile!
Veel kord palju õnne nominentidele, võitjatele. Ja me loodame üheskoos Andrusega, et hästi palju head ja väga head puitarhitektuuri ei ole teid muutnud liiga puiseks ega juuri alla kasvatanud. Ja see sõbrunemise üleskutse, mis siin Henrik enne välja hõikas, see on üks päris üleskutse, ehk et seal eespool ootab Kärbes Kitchen ja üleskutse siis nautida õhtut seal edasi pärast seda, kui meie ametlik osa läbi on. See kehtib tõepoolest, aga enne veel on meil palve, et nii tänased esinejad kui ka võitjad koguneksid lavale ühe ühispildi jaoks. I will just conclude in English that it's been such a fantastic day. And before we move on to this unofficial part of mingling and making friends among architects, carpenters, engineers, and so forth, may we invite all the presenters and also the winners on stage for a joint picture.
Yeah, please come.